And in this video, this is a part of a multi-part series where we are discussing every sheet individually in a construction set, the architectural set, the structural set, and all of the MEPs. In this class, we'll be going over the little portion of the specifications that are involved in that they have provided in this set, and also the typical construction schedule, how we read it, how we construct it, and, just to go over some details. Okay, so this is the second sheet in our full sheet, our Popeyes construction set, and this is the BR100. So it contains schedules and specifications. Okay, so bidding requirements is what the BR stands for, and basically what they've done is giving you some of the information from the actual set of specifications. And so examination of site, explanation to bidders, all the way through, things that you want to make sure you review. And again, these are all things that you would find in the actual specifications, but they've just included things that, that are important, bidding requirements that they want you to know. So they have also included it in the set of construction documents. So the most important one I like to see is the final payment and the AIA documents, what's required in order to get paid. That's very important, and how the information needs to be presented to them. So this is a good set for that. So again, this is the BR100 bidding requirements, giving you information from the specifications, and then also it's giving you a breakdown of a TYP, which is typical construction schedule. So anytime they include the word typical, that just means that every time they do something, they want to do it the same way. So they do it typical, they do it the same way, they don't want any variations, but of course, things change. So what this represents is the construction schedule from beginning to end for the project. And so the way we read it, the columns are everything that is going to be done within each of the columns, and then the amount of time they tell you it's going to take is the number at the bottom. So in this case, it's the amount of time in days that it is going to take them, or they say it's going to take, to achieve each of, or the full scope of the items in each of the columns. And so for our first one, what they wanted to take is 1 day to establish the construction schedule. The contractor receives notice to proceed and finalize all national account quotes and pre-construction meeting. They want all of those things to happen within 1 day. And so if we progress on, contractor mobilization, order national account buyouts, they assume that will take 3 days, and on and on and on. And so they begin with basically mobilization paperwork type stuff. Then they go to the surveying, rough grading. And so you can look at each of the columns and see the progression as the project moves forward. What comes first, what comes second, and this is a good teaching tool too, to show, the progression of any project. What comes first? What do we do first? What are some of the things that we can do at the same time? And so they have created a typical construction schedule for this Popeyes as they work through each of the items. And again, the bottom number is telling us how many days it's going to take them to achieve whatever is in the column. And so when we get to, if you do any project management courses, you know that you can, you need your detailed estimates in order to determine really to accuracy how long any of these scopes of work is going to take. So a good cost book will help you determine the man hours for each of these operations. And once we know how many man hours it takes to do whatever, then we can start to build the construction schedule, and we know how many days it will take to build, whether it's the framing or the roof finish. From the estimate, from a good estimate, you should be able to determine the man hours it's going to take for everything within that estimate. And so that's where you get these numbers as accurate as possible by doing a detailed estimate for each of the operations within that. And some of the things, again, you can do at the same time. Okay, so that's building a construction schedule. And that's a separate class. Okay, so again, this was pretty simple. Bidding requirements, BR100. They've taken some of the items from the set of specifications, included it in the construction documents. So For ease of review, and also the typical construction schedule gives each of the contractors, the subs, an idea when they are to perform their scope of work, who comes first, who comes second. And I always recommend that, if you do any project with a GC, the quality of the general contractor will be shown through the quality of their construction schedule, if they have one or not. So that's pretty much it for this sheet, the BR100. It's again part of a multi-part series. We're going to be looking at a full set of construction documents from the cover sheet all the way through the electrical set. If you have any questions or concerns, please go to our website, www.S as in Sam, F as in Frank, johnsonconsulting.com, and sign up for online office hours, and we will give you additional time one-on-one to go over any information on any of the classes. But again, thank you for joining me, and I will see you at the next class. Have an awesome morning, afternoon, evening, wherever you are. Hello, and thanks for joining me. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this class, we are going to discuss the roof plan in our multi-plan review of our plan reading basics class. And so we have the roof plan. Now, when we talk about the roof plan in the architectural set, we're only talking about the roof finish. We're talking about roof finish only, not roof framing, right? Because roof framing is part of the structural set. And so the finish is basically what we are discussing. And so when we look at the roof plan, we're looking at the roof from the plan view, right, from above, and really it reflects everything that makes a hole or a penetration within the roof, right? Because the roofer's job is to waterproof the roof, to put on the roof finish, and to make sure any openings within the roof are waterproof. No moisture goes through the roof. And so, as a result, the roof plan shows everything that has a potential to leak through the roof. So here we see all of the rooftop units, because all of the ductwork, right, is going to go from the rooftop unit into the building. And also same thing with the exhaust fans. The exhaust fans themselves, the hoods, are going to go from the interior of the building to the roof. And then all of the piping for the plumbing system for the vent to roof, all of that's going to go through the building. And so again, it's going to show all of the penetrations within the roof. And there will be detail sheets to show the roofer, how to in more detail on how to make sure that that's done. So some is here on this sheet where it shows the roof curb, and the rooftop unit sits on the curb. Within all of this is the roof joist, and doesn't give a good clear picture of the ductwork and all of that from this perspective. But here's another one that shows the vent pipe. Okay, and so the roofer knows how to put all of those, the pourable sealant, the membrane, how it's supposed to lap over, and everything else to make sure that no moisture goes in here. Obviously, you can tell from that it's pretty good. No moisture is going to go in. All right, so a couple of things specific to roofs when we're talking about a roof. We are always talking about the pitch of the roof or the angle of the roof, because all roofs have an angle. So all liquids and water and snow, right, run off of the roof into whatever kind of gutter system that they have available. And so what you'll see is the pitch represented on the plan. And so what this one says is, for every foot or 12 inches it goes forward, the angle is 1/4 of an inch. So this is almost next to a flat roof, but it has a slight pitch. And the arrow's always going to point in the direction of the water flow, or the direction of the gutters or whatever. So we know that there's some kind of gutter system this way. Okay, so that you always see the pitch, and the pitch does make a difference when we're talking about The material for the roof, especially when we're talking about shingle roofing, right? Because it's not butted up against each other. It's lapped over, so pitch becomes real important because of the additional amount of material that you're using when you're installing shingle roofing. So pitch, that is one thing specific to the roofing trade. Another thing that's specific to the roofing trade is the measurement of those. Back in the old days, you get the shingles in bundles of 100 square feet. And so for roofing, we use the square, and it's abbreviated capital SQ period square, and that's representative of 100 square feet. And so when we talk about roofing material, we typically talk about the square, or we price it by the square, which is again 100. It represents 100 square feet. So if we have a 5,000 square foot roof, right? It's They say, we're so cool. We say it's 50 squares. Hey, all right. So just know that's specific to shingle. Anything, even the siding, they'll go by the square, which again is just representative of 100 square feet. All right. So the roofing plan, all of our roof finish shows you all of the roof penetrations, and it will give the roofer details on how to close in those penetrations, right? The pitch is specific, it shows the angle of the roof. And then we also have something called our crickets. And a cricket is just additional framing that's built over our flat framing when we have really flat areas. So it makes like a tilt, it makes an angle to where, again, all liquids can flow off of it. So usually when we have flat areas, this is a cricket that's built here, where this is the ridge of the cricket and this is the valley. So if water were to flow this way, right, in the direction of the pitch, it would flow this way. Well, it would stop here and then it would flow down the valleys and into the overflow and the roof drains. Okay, so that's what a cricket is. It's just additional roofing that gives that area an angle where it would tend to be very flat. Alrighty, and there's a little cricket right there. Okay, so that's the roof plan. Roof plan, plan view, view from above. Now, it's going to give us some section views here, but it's really just more so, the intersection of the parapet. Do we have flashing over the parapet cap, that kind of thing. So you got to always make sure you take a look at that, and that is exactly what that is for. It's flashing over the parapet cap. So let's go real quick to 3 over A 425, and then it'll send us somewhere else. 425. 3 over 4. Do we have everything? There we go. 426. 425. 3. Okay, so we are the roofer. Because we are the roofer, we only care about things from the roof up. Okay, so we are the roofer. Now we know we have a roofing membrane, right, over 3-inch rigid insulation, then the cant strips and the riglet, and then we know we have all that good stuff. And now we have a call out right here. And so, we always have to follow the call outs if we think our scope of work is involved. Okay, so we also have a call out here. Okay, membrane flashing top parapet. So yes, that's our scope of work for the roofer. And then, we got to follow the call out. This is a call out. What is it doing? It's calling out whatever's in the circle. So if my scope of work is reflected in the circle, which pretty much is from rough carpentry to the roofing membrane, I have to go again and follow here because there's more detail at this call out at 2 over A 450 that I don't see here. So let's go to 2 over A 450. This is 450 and image number 2. They're never in order and I never can find it. All right, let's see. Here we go. So that's the very top, right? So I'm the roofer. So I'm going to check it out all the way up. I don't do insulation because I'm the roofer. I don't do studs because I'm the roofer. I don't do the top and bottom plate because I'm the roofer. Continuous 2x8, I don't do that because I'm the roofer, but I do continuous aluminum sheet and it's secured with the ring shank that I think I do that, right? Membrane flashing to top of parapet. I'm the roofer. I definitely do that. And the cap, I do that. And cut any wood, 2 bys. Nope, don't do that. So yes, it's very important. If you see your scope of work in a call out, the previous picture, you got to follow it because you have to make sure that you are including everything within plan view, section view, detail view. All right, so that is the roof plan, a short, quick review of what we look at when we are reviewing the roof plan. Who would review the roof plan? The roofer. And the roofer installs all of the roof finishes. So what's important is where are there holes basically in the roof? And show me as the roofer how you want me to secure and close in all of those holes. So here's the roof drain and overflow drains. And so it's going to point to everything. It's got our flashing right there. So if we're roofers, we know exactly what all this stuff is because here is, oh, this is our overflow. So this is our plumbing system that goes interior to the building and then out to the sewer system. So we never see that. And here's our roof hatch. So now it's going to tell us 1, 2, 3, 4, all the way to 11, every little piece and part that we have to make sure we account for. So we can make sure that there are no leaks at the roof hatch. Okay, so as the roofer, that's what we do. We look at the roof plan, we determine what type of material, we figure out how many square feet of that material. We look at the section view, but just in case our material has to go up the parapet and over the parapet wall, additional information, where are the holes and how do we secure them. Okay, so that is a brief overview of the roof plan. If you have any additional questions, problems, or concerns, please go to our website, www.sfjohnsonconsulting.com. At the lower right, you can fill out the form for online office hours, and we'll go over this more in detail with you on one-on-one. But as usual, thank you for joining us for this wonderful class, and we will see you next time. Bye-bye. Hello, everyone, and thank you for joining me. My name is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And then in this snippet, this is part of a multi-series class where we go through a set of construction documents, the architectural set, structural set, the civil set, and all the MEPs. And we go over them sheet by sheet for what's important, what you should be aware of, and basically what we're looking at. And in this snippet, we're going to be talking about the MEP site plan. Okay, and this is, we call it the MEP site plan because it is not a full site plan. It is a site plan that gives you kind of like a salad bowl of what is in a full set, a full civil set. The site plan is just one of the sets that is comprised within the civil set. And so this is like I said, it's a compilation of all of the trades just on one sheet. It's not used for detail, of course, because we need all of the individual sheets that would be comprised within a civil set. So this set or this sheet gives you contour lines, right, which would be found on the excavation page of a civil set. It's going to show us the parking lot striping and curbs and gutters, which would be found on the concrete asphalt plan in a civil set. Okay, so this is just one sheet that gives us kind of a little bit of everything that we would find in a full civil set. And then we're going to just go over each thing individually and give you an idea of what we're looking at. And so the first thing we'll start off with are these lines that look like mountains. And those are called contour lines. And those are the lines that kind of that do represent the GPS coordinates if we were to go out there and do a survey. Well, that's what they mark each of the contour lines, and it basically represents the height and the depths of the land or the dirt at various locations. And so what we're looking at on this MEP site plan are just a few of the contour lines. And what I want to go over is just how they represent, because the contour lines, again, represent what we would find on the excavation plan. And on the excavation plan, what is that? That's telling us how much dirt we need to either cut or fill in order to properly level the land to build, in this case, our restaurant. So the way they represent the contour lines of what they found on the survey, when they did the survey, the number that represents the number that, or basically before number, would be the number they represent here in the parentheses. Now, 588, we don't care what that means, but uh, we just want to make sure that before and after, right? Excavation, what we found before, and then what we need to either cut or fill to build our property or build or level it out for our foundations, our parking lots, and all of that good stuff. So the way they represent before is in a parentheses, and the way they show what we want as a result of the excavation is represented in a square. So this is for this particular architect and what they use to represent before and after, but it'll similarly be represented in some kind of way. Or we can see that before is represented by the broken lines, dot, 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 the broken lines, and where after is represented by the solid line. Okay, so in this MEP site plan, they're representing the heights and the depths of the dirt at various locations. Before is the broken line with the parentheses. What they want after they've done the excavation is represented by the square and the solid lines. Okay, so that's one thing for our MEP site plan. Another thing is underground utilities and how they represent underground utilities. Well, underground utilities are represented by, if they're existing, they're more of a gray color. And so we see here UT, so that tells me that's an underground telephone. They have G, it should be underground gas, but there's a lot of inconsistencies in this set. And then we see underground EUE, underground electrical. And so how do they represent utilities that are underground and that are existing? They represent those by a gray broken line. Usually, new construction is always represented by a black line, meaning this is the new construction as opposed to the existing. So if I had to look at this and say in words, we see that the SD, which stands for the storm drain, is black, where all of these other ones are more gray. So that would tell me maybe we have a new storm drain coming through the new construction that is junctioned or broken off from the existing storm drain, something like that. Okay, so underground utilities are represented by gray lines if they are existing and broken gray lines. So you just have to kind of look what's the existing, what's the new, and kind of determine it that way. And so if we look all around this set, we'll see that we have, now this is a black S. So even though the line is gray, the line is probably telling me it's underground, yes. But the black is telling me it's a new storm drain or sewer drain that's coming into the building right here. So underground utilities, again, if they're already existing, broken lines, gray color if they're new, more solid lines, or maybe a broken line, but a darker representation of what it is. And so here we see that there is and we know that these are new because, again, this is new construction. So we have 8-inch water, then we have the underground electrical, underground telephone, underground something else right there, 4-inch gas. Okay, so broken lines tells me it's all underground utilities, and they're all coming into the new construction. Okay, that's another thing for our site plan that's typical of a site plan. One thing we always have to make sure we do correctly is to make sure if we're using a digitized software that the set of construction documents or the plans are to scale. Okay, so what does that mean? That means if we were to print a full legitimate set of construction documents and we used a regular ruler, for every inch that we measured with that ruler, it would really mean that we are measuring 20 actual feet in real life. Okay, so you always want to make sure if you're using a digitized software that you confirm that the scale of the set that you receive is correct. And so here on our digitized software, we just tell it that for every 1 inch, it's 20 feet. We set the scale, and then we take a measurement somewhere on that set to confirm that between 20 and 40 should be 20 feet. So we know that this set is to scale, so when we do our measurements, we know that our measurements are correct. All right, On any set of construction documents, you're always going to have keynotes. And how the architect represents the keynotes is really based by architect to architect. But it's very important that you look at each of the keynotes individually, match them up with the keynotes that are on the page, so you can make sure that you covered everything on your set in terms of your full scope of work. Every set's going to have keynotes. It's important that you find a methodical way to make sure that you have covered every one of the keynotes and what you need to do. Okay, so let's go back. This is a very generic MEP site plan. It shows us some of the things that would be on the site plan all on one sheet. Remember that the civil set, sorry about that. The civil set is the set of construction documents that show us everything, all new construction outside. Okay, so when you walk outside any door of the office or home, what you're looking at is everything that you would find on a civil set if it was to be built new. What do we see? We see asphalt concrete. That would be a separate plan. We see, we see the results of underground utilities, right? We would see fire hydrants or something like that, or manhole covers or something like that. Well, that would mean that there are underground utilities under our feet. We would see trees, right? That's part of the landscape plan. That would be a part of our civil set. We see, again, in this Popeyes, we would see parking lot striping, handicap symbols for parking lots. We would see all of that. Again, all part of that same asphalt concrete striping plan that we would find in a full civil set. What they did here was give a little bit of underground utilities, a little bit of excavation, some parking lot striping, asphalt concrete, all of that on one sheet. Okay, so this is kind of like a salad sheet of what would be comprised individually in a civil set. Let's see what else. Scales, always important. Make sure you are always on the right scale when you're doing measurements, or else your measurements are not valid. And the only reason why we had to have a set of construction documents is that we can look at them, we can scale them, we can make measurements, and from those measurements, we can apply value to this is how many linear feet of new wall, this is how many cubic yards of concrete, and we can give a cost to how much it is to build this thing. Okay, so again, an overview. Underground utilities are represented by broken lines. If they are new utilities, you'll see black. If they are existing, you see gray. The contour lines are represented by the heights and depths of the dirt. Those are the contour lines when we go out there and do the survey. And it's showing us for the excavation plan what the height and depth of dirt is at certain locations, and then what we need to do to get it to the height and depth that we need it to be at, so we can build our storm drain basins and build our new foundations. Okay, so that's what we're seeing here. Make sure you read all the keynotes regardless of the sheet. And one thing, and we'll go over individually, we are looking at this sheet from a plan view. And you will look at any of the sheets from one of 4 different views. You'll look at the sheet from a plan view, which is the view from above, and we'll have a separate class detailing each of the 4 views, how we look at it, how we flow from one to the other. But on this sheet in particular, we're looking at anytime you see the plan. See, we always say, send me the set of plans or whatever, but really that's a misnomer, right? Because plan is a particular way that you're looking at the project. It's a perspective of the sheet from which you're looking at the project. The plan view is the view from above. It's as if you're hovering over, you're flying over, and that is the most basic of the views, is the plan view. Okay, so from the plan view, we get a good idea of the site plan. But if we were to, say, build the walls of the Popeyes, the plan view doesn't tell us the height of the walls. It doesn't even tell us the thickness of the walls. So we need other views, other sheets in order to give us more detail. All right, so this is the MEP site plan for our set that we are breaking apart and analyzing. And remember, if you have any questions or concerns, you can always go to our website, www.s as in Sam, F as in Frank, Johnson Consulting.com. Fill out our online office hours. We will make time at your convenience to go over anything with you to make sure you understand. Thank you very much for joining me this time, and please make sure to return. You're awesome, and well, I guess that's it. Have a wonderful rest of your day. Okay, everyone, thanks for joining me. My name is Stacy Johnson, and I'm the owner and operator of SF Johnson Consulting and Construction Services. And in this part of our multi-part series on our plan reading basics, we're going to be reviewing the floor plan. And the floor plan tells us all about the new wall construction. And what we are looking at here, all the colors basically represent all of our different wall sections broken down by section view. So what is the floor plan? The floor plan tells us all of our new wall construction. Typically, the framer would need the floor plan. And from the floor plan, we can determine how many linear feet of each type of wall. And so what we need to look for on the floor plan is what types of walls are we building? That's the most important thing. Are they going to be wood framing? Are they going to be metal framing? We need to figure that out first, of course. And of course, on the floor plan, you're going to have a legend of all of the different types of walls, how they mark them, how they name them, and what the wall construction is. And so we know that wall A is a 2x4 framing at the 16s on center. And what's that mean? That means that each of the studs are 16 inches apart. So if we know how many linear feet of wall construction, we can determine how many studs we need in order to build that wall. So the A walls are 2x4 framing at the 16s, B walls are 2x6 framing at the 24s, and all the way down. So now we know the types of walls. And so our framer would need the floor plan to determine, what types of walls. And second part is how many linear feet. The floor plan and plan view is the view from above. And so we can use the floor plan. This is the view of the project, all of the wall construction, as if the ceiling and the roof is off and we're looking down into the building. So that is the that is the plan view. And so it's really simple. We go by each of the section views, okay, and these are section view markers. And the only way that the architect can speak with us is by giving us symbols and lines and numbers and abbreviations to show us, tell us where to go in order to get a clearer picture of what we're doing. And so what the section view does is it tells us that based on the placement of the section view, that the architect is saying that this section of wall is built in a particular way. And if you want to know, which you do if you're the framer, you need to go to this view. So this is a section view. This is a section view marker. It's unique in that it has a circle. I call that the little hat, and the leg and the foot. And typically the leg will be going through the section, which is the portion of the wall that it is referencing. And so if you look at a full floor plan, in most cases, you're going to have a variety of section views because, again, it's the architect saying, I need to show you how that wall is built. And the only way to show you is to send you to another view or to another picture. And so all the way around this, the wall construction, we'll see that we have different section views. And it's up to you and your good judgment to determine where the section view on one begins and the other ends. But it's pretty simple based on where the placement of the section view is. Okay, so what the architect is telling us here is that if we want to know the wall construction at, and this represents a window, and we do have separate small videos on how we represent doors and windows and all the different component parts of our project, along with a separate section for section view, plan view, all of that. So you can put that all together because, right, a set of construction documents are just a bunch of pictures that are arranged in a particular way that help you figure out how to build something, how to build the wall, how to install the window, how to lay the flooring. And what you have to do is go from the most basic of the views, which is typically the plan view, to the section view, to the detail view, depending on the scope of work now. Now we're talking about the floor plan, and the framer needs the floor plan. The framer needs to build walls. Walls have two dimensions. One is how many linear feet of wall do we have? And that we get from the floor plan. The other is what's the height of the wall? And the height of the wall we get from the section view. So we would go to, and how you read this is we would go to image or picture number 1 on page A426, and it would show just a section view of this, and it would give us our wall construction. And again, section views are going to be handled separately, but for this class, we will go there. Okay, so again, the floor plan tells us all our new construction. What the architect tries to do is to break down all of the walls based on section views. And again, the section views are portions of the whole, sections of all of the walls that show us the walls built differently at the window, the walls built differently at the door, the wall is built differently where there is no opening, and the section views lead us to those views that show us how we build the walls. Okay, so the first one we're going to go to is 1 over A426, which for our purposes, the architect is saying the wall at window A is built this way. So we have to know. So we know if we've determined from our floor plan that we have 32 feet of this, we have one of the dimensions we need to build the wall. And now we go to the section view that gives us basically the height or the vertical measure, the up and down. And then we have 2 dimensions and we can build the wall. And so we will go to image number 1 on page A426. A426, boom, image number 1. So now we know the height of the wall at, this is the window. And so now if we are the framer, we know that a certain length of wall under the window is 2 feet 10 inches and some inches, 10, and we know that the studs or the length of wall above the window is a combination, and I broke it down from the top of the window to the top of the roof and then the parapet wall. Okay, the extension of the wall that we don't put insulation in is just for the basic purpose of hiding all the ugly stuff on the roof. So that's the section view. That's the second dimension our framer needs in order to build the wall. Okay, and then more detail. When we go over the views, we'll go into this in detail. So now we know the length of the wall from the floor plan, the height of the wall from the section view, and now there may be other details that the framer needs to know about, or the wall, the insulation person needs to know about, or the window installer needs to know about, and they go by following another one of the architect's directions, which we call the detail view. So this is a detail call out, and we're calling out what's in the circle. So whatever's in the circle, if that's your scope of work, you need to follow the call out, which again, image or picture number 5 on page A600. So we go more into plan view, section view, detail view, and the flow from one to the other in a separate video. Okay, but our purpose for this video is to simply go over the floor plan, which shows us all of our new wall construction. The floor plan, from the floor plan, we can determine how many linear feet of each type of wall that we have to build. And then we can go to the section views to determine the height. And a wall is length times height. And so we know how many square feet of wall we're going to build. Okay, so that is a great explanation of our floor plan, a little snippet of that. We will continue. The next section will be our ceiling plan and all of our new ceiling construction. But this is our floor plan used by the framer, used to tell us how many linear feet of different type of walls that we are building. Okay, and this is a highly dimensioned floor plan, and you will have some floor plans that say dimensioned, meaning it has measurements on it. And so if you don't have a highly digitized software, the measurements on here will assist you in measuring how many linear feet of any section of wall we have. And so we'll go over that real quickly. If you remember from grammar school, parallel lines, perpendicular lines. Parallel lines are 2 lines that will never cross. So if you know the length of one of the parallel lines, you can assume that is the length of the other. And so on a dimension plan, they give you basically that concept. They give you one parallel line, which represents the length, and they match it with the parallel section of wall. So if you know that this length is 7 feet, 7 inches, it is parallel to this section. So that tells me that this section of wall is also 7 feet, 7 inches. So on a dimension plan, you can use the dimensions with the parallel rule. Parallel sections are equal. So if I know one, I can assume that is the other, and then you can do your measurements all the way around and the interior wall lengths as well. They give you measurements there. Now, how you read the measurement is from hash mark to hash mark. What is a hash mark? Hash mark, here's a good example in the middle, where we're sharing a couple of hash marks. So that's a hash mark, that diagonal little mark. So what that says from hash mark to hash mark, the number in between is the actual length. And then from hash mark to hash mark, the number in between is the actual length. And so how we measure from hash mark to hash mark, right? So from hash mark to hash mark, that's this length. Okay, so that is a brief explanation of our basic overview of the floor plan. Remember, every sheet has instructions, symbols telling you what to do, notes from the architect to go to different views to see there's something here that you don't see. But if you go to image and page number, it will give you more instructions, because that's the only way the architect can talk to you, is by sending you to another view to give you more and more detail. Okay, so this is a floor plan, all new floor construction. We're going to look, first of all, what types of walls are we building? We know in this case they're all by something. So when we see X, right, something by something, that indicates that that is wood framing. Metal framing is indicated or represented by mixed numbers. So the equivalent of a 2x4 would be a 3 5/8. The equivalent of a 6-inch or 2x6 would be a 5 7/8. So if I saw B 5 7/8, I know that this B wall is metal framing. But because I see all X's, 2x8, 2x, that lets me know all the wall framing is wood studs. And we can roll that way. All right, so floor plan used by the framer. All new wall construction floor plan gives us the length. We'll always have to look at all of the keynotes. Then we go to the section views to determine the heights of the walls. Then we have our two-dimension length times height gives us our square feet of wall. Because we want to do a very good job, we break down all of the walls by section view. So we know that this wall at the wings represent doors, double doors. We know that this wall will have only a wall above the door, right? Because it's a door. So we want to look at that section view, because we want to make sure we buy studs that are as close in length as the ones we need, so we do not have to cut all 12-foot studs. Studs come in even height. So if you only need a 2-foot 8-inch stud for under window, then you would naturally just have to figure out how many linear feet of under the window we have, and then we can determine how many studs we need for under the window and buy a 4-foot stud and cut off just a little bit, as opposed to buying a 12-foot stud for everything. And very quickly, to determine how many studs you need, because we know how many linear feet of wall we have and we know the placement, we can determine how many studs we need to build that wall. So if we have 100 feet of 2x4 A wall, if we have 100 feet of that, so we change feet into inches by multiplying by 12. So we say 100 times 12 would be 1200. Then we divide by the placement. Divided by 16 tells us how many studs we need for that 100-foot length of wall. So again, thank you for joining me. If you have any questions or backup comments you want to give me, please sign up on our homepage, lower right, online office hours. We set a time that's convenient for you to go over anything you still need some help with. But thank you for joining. I hope this clears up a lot for your review of the basics in plan reading. This is our floor plan, all new wall construction, and our next class will be our ceiling construction or our ceiling plan. Thanks again, and I look forward to seeing you soon in the next class. All right, thank you everyone for joining me in this short bonus class where we will discuss the views. And what we mean by the views is that each of the sheets give you a different perspective of the project, and each of the views get more and more complicated, or each one gets more detail or gives you more detail. And because the architect, the only way that they can show you how something is built, how a wall is built, or uh, how any of the items in the project is built, they have to give you one perspective, then a more detailed perspective, then a more detailed one, and all the way through until the full picture is represented on how you should put this wall together or install this window or install tile on a wall or even, wall base, to adjacent walls. So that's what we're here to talk about today in this bonus episode for our basic plan reading class. And now we'll start with the first of the views, which is the plan view. And so when we talk about the plan view, we'll start with the site plan. We think we will. We'll start with the cover sheet, and we'll start with the MEP site plan somewhere in here. And why isn't it marked? Oh, because Stacy likes making this life difficult. Let's hope we didn't delete it. Okay, let's go back. Oh, there we go. All right, so we'll go with the MEP site plan. So plan view. So when we say plan, it's the view from above. It's like if you're hovering over, maybe flying over. It's the most basic of the views. So what we're looking at right here is the MEP site plan in our study set. MEP is mechanical, electrical, and plumbing, and it's basically showing us the site plan from the plan view of where all of those things are located. So if we pan in, we'll see 8-inch water, 4-inch gas, underground telephone. But the whole point is the view or how we're looking at this sheet. Okay, so the view is, again, the perspective from which you're looking at the sheet or looking at the information on the sheet. The plan view is the most basic of the views, and I say basic in terms of if we wanted to construct maybe the curves. From this view, we can't really do anything other than measure how many linear feet of curve that we're going to construct. It doesn't tell us anything about the thickness, the radius of this angle. It doesn't give us any of that stuff. And so we could do a very poor job if we decided to use this plan view, in order to construct anything here. Same thing with say, for instance, the exterior walls on the Popeyes, right? We can use this view to measure how many linear feet of exterior wall, but it doesn't give us detail to tell us the thickness of the walls. Is it 2x6, 2x8, whatever. Doesn't give us the height, right, of the wall. We don't know the height of these walls. So again, the plan view is the most basic of the views. And it gives us a good idea of what we're looking at. It's a view from above, but it doesn't give us detail. Let's go to another plan view, where from this floor plan, right, same view from above as if we've taken the ceiling and the roof off, and now we're looking into the building, same view from above, and same thing. It gives us the information where now we can measure how many linear feet of each of the interior walls are and exterior walls. Okay, they're even marked, so we know that this is wall B. Okay, and pretty much the plan view, that's all we can do from a plan view, because again, we have the same problem. We don't know the height of the wall. And so in order to see the height of the wall, we go to the second of the views, which is the section view. Okay, so section view gives us the vertical view of any section where it's intersecting. Okay, so this is a floor plan. And so what the floor plan gives us is how many linear feet. But the section view is going to say, well, I'm going to tell you the height of the wall along this stretch or this section of wall. And the way that you read it is that you go to image or picture number 1 on the page notified or signified at the bottom. So we go to image number 1 on page A426, and this is a section view. Again, the architect can only give us abbreviations and symbols and lines and numbers to represent what they want us to do in terms of, now I'm the framer and I have to build these walls. And so what I've done as the framer, I've broken down all the walls into appropriate sections. Then I go to the section view and I see the wall construction. All right, so now I'm going to go to 1 over A426 to see the vertical height at this section. Here we go, 1 over. So now we were up here, right? We were up here from the plan view looking down. Now we took that section view marker and we came down here. Now we know what the wall construction at that section. That was the wall at the window. There's the window. We have a certain portion of wall below the window. We have a certain portion of wall above the window. And so we use this to determine how many linear feet of this size and height of stud. We can use this to determine our material quantities now. Okay, so that's the section view. That's the second of the view. And again, it does give us more detail than a plan view. Now we go to the third of the views. So what is the architect saying? By giving us this detail view, we're going to look at a detail view. This is called a detail call out. Circle, dotted circle around in something that's inside the circle. Same concept applies if we want to see what is missing. So what the architect is saying, there's some stuff here. You see the seal, you see the chair rail, you see that it's 2x6 wood stud, you see everything on this side, but there are certain things detailed in here that we don't have written here that we need you to get another view. Okay, so you go to the third of the views, which is the section view. Same concept applies. So what do we see here? So we know what we don't see here when we go to 5 over A600. So you see what the difference is, right? So again, we see the seal, we see the chair rail, stone veneer, even the expansion joint right here. And actually we have 2 call outs, right? We have 5 over A600 for this encircled here, which is the intersection of the bottom of the window and the top of the wall. Okay, so that's pretty much what the architect is saying. There's something about that we need to see, that if you go to 5 over A600, and let's go there now, you can see what you don't see here. 5 over A600, here's A600, image number 5. Where is it? I don't have my glasses on, Grandma. All right, here we go. 5, detail at seal. So yeah, continuous caulking wasn't shown in the previous. Continuous flashing on the window wasn't shown in the previous, and all of this, okay? And so now you've gone to the third of the views, the detail view. It is a detail view. And you see at the detail view, it gives you everything that you didn't see at the section view, so you can complete the proper construction at that area. Okay, so that's the third of the views. Now the fourth of the views is kind of different in that we don't really need that view for construction. That view we need for the finish trades. Okay, so now what we're looking at here is the floor finish plan. But the floor finish plan is giving us all indication by all of the floor tags and the telling us what type of material it is by pointing to it. But what this floor finish plan also gives us is these little things that look like section view markers, but they are not. They are elevation markers. And so what it's telling us is that if we go to image number 7 over at page A120, we're going to see all the finishes that's here on this wall. If we go to image 9 over A120, we'll see all the finishes here and all the way around. And here, this is pretty much, you always want to see elevation markers. So this is an interior. These are interior elevation markers are what they're called. And they're used to point you to an individual wall, whatever it's pointing to. And if you go to that picture on that page, it's going to show you how the finishes are arranged on the wall. So Let's go to the first one, 7 over A120. Let's see, 7 over A120. This is 126, so we gotta go back up a little, 7. And then image number 7. Okay, so image number 7 is right here, the dining room elevation. Okay, so now it's showing us all our walls are built, right? So showing us where the finishes are going, where P2 is going, where WS/1 is going, where CB1 is going on that wall. So now I'm the finish contractor, I'm the painter, I'm installing it on some of the finish trim or finish whatever. I can make my measurements using the interior and exterior elevations. You also have the same thing on the exterior. Okay, so show you some exterior elevations, right? Same thing for the outside. So now exterior elevations show you all the finishes on the outside. So now I'm the brick veneer professional. I'm the caulker. I got to caulk around the windows. I can use this to make all my measurements. Okay, so that completes the 4 views. You have the plan view, the most basic of the views from above. Right? It's the view from above, most basic of the views. What we see the most is the floor plan. From the floor plan, of course, we're measuring how many linear feet of wall, but we need a height for the wall. So the section view takes us to the height. Okay, so that's the second of the views, which is the section view. Okay, so the section view now gives us the height. We were up here from the floor plan. Section view gives us all of the individual sections. So now we can see how the interior walls are built. Helps us with our wall construction, helps us determine how many square feet of wall. And then when we're in our section view, 9 times out of 10, we're going to go into a detail call out to take us to another view, which is giving us information about what we don't see here to ensure that we complete the proper construction. And then the last of the views, well, let's go to the detail view. Okay, so the detail view has all the things we didn't see in the circle. Okay, so you're going to always have a sheet of detail views pretty much in every set, right? Because there's always something, we've got to get down to the nitty gritty of the construction, all right? And then the last of the views are for the finish trays, interior elevations. So the painter and the finish trim and the this and that, the painter, the tile, the wall base professional knows where all of that goes, and that's at either an interior, inside elevation view, or an exterior elevation view. Let's find it. Oh, of course, that's not it. Or here we go. Or an exterior elevation view. Okay, so that completes the 4 views. If you have any additional questions or problems with this stuff, please sign up at our online office hours at www.sfjohnsonconsulting.com. And we'll be more than happy to help you. But otherwise, I will see you at the next class. And please remain awesome. See you later, alligators. Hello, and thank you for joining in this class as we review another sheet in our review of the full architectural set on the Plan Reading Basics class. In this snippet, we're going to review the floor finish plan and all of the interior and exterior elevations and how the finish plan flows right into the interior and exterior elevation sheets, and how we look at it and what the symbols are and how we associate the symbols. So now what we are looking at, even though it's the same schedule, right? So the schedule is just a list of all of the finishes that are within the full project, whether it's tile, paint, wall graphics, as you can see, tile base, even the grout. Of course, they're going to give you everything in great detail for all the finishes for everything that's within the set. And so we're going to know that T1, T2, T3, the type of tile. Here's T3. It goes on the restroom wall. It's the type of tile. It's the size of it, manufacturer, color, and all that good stuff. So, On our floor finish plan, it's going to tell us all of the finishes that are on the floor. So what we just need to do is use an area tool to measure the area of each of the different floor tile types, and then we'll have how many square feet of tile we have to place. Now, in this particular set, we have the interior elevation markers. And so what the interior elevation markers do is they point you in the direction of the interior wall, or we can have exterior elevation markers, which would be outside the building. It points you to a wall, and if you go to, same concept applies, image number 7 on page A120 is going to show you all the finishes that are on this wall. Same thing with this one, it's pointed in this direction. And so if you go to image 9 over A120, it's going to show you all of the finishes on this wall and so on all throughout the project. So from a floor finish plan, we have the interior elevation markers that are located within on the floor plan. And so it points us to the image or the picture in the sheet number where we can find the finishes that go or the items that are placed along each of the walls. So we'll just take a couple of looks. All right, so interior elevation sheets show you the view of the wall as if you are inside now. You're standing inside of the restaurant, and this is what that wall, that image 7 on page A square feet of wall, excluding the window, that I'm going to be painting. And if I'm doing the tile base or WS1, which is some kind of wall covering, I can use the interior elevation views in order to make all my measurements. Chair rail, I know how many linear feet using the interior elevation views. And you'll have one of these per wall, of course. So you can get all the detail you need, take all the measurements you need to accurately determine how many linear feet, square feet, or whatever of the finish. So that's just one. And here, just a couple of other ones. So a really good set of construction documents is going to give you a lot of interior elevation views. It's going to show you lighting contactors. So this is the kitchen elevation, and it looks like this is where the electrical panels are going to be. So it's going to kind of show you a visual of what, once they're installed, what it's going to look like. And all the equipment, and of course everything is marked its name. So K42 is this, whatever that is. So I know that that goes there, and N40 goes here, and N10 goes there. Okay, so that's what the interior elevations show you, all of the lifelike view as if you're standing in the restaurant. And let's see, we have just some more interior elevation views. Let's see if we have some exterior elevation views. I thought we marked it, but maybe we did not. Okay. Okay, here's the exterior elevation view. So it's the outside of the building. So now if I'm the tile person, or if I'm installing the windows, or I'm installing the lighting, I'm going to be able to use this to tell the distance between the lights I have to install, or all of the ornamental items that are here, or if I have to caulk the windows. And here we have a section view, so we go to 8 over A600 to determine what they're telling us to do. And it's probably telling us, how do we caulk between the tile and the window, something like that. So all of the exterior elevation views, okay, and you would get those. Of course, you'd only have 4 of those because a building only has 4 sides, unless it's like a hotel and then one of the sides extends or something like that. But so that's how we go from the finished plan to the interior elevation views and the exterior elevation views. And those views are totally intended for all of the finished trade. So the painter knows how many square feet. They can accurately use those sets of sheets to accurately measure how many square feet of wall they're going to paint, or how many linear feet of chair rail is necessary, or any of the finished trades. That helps them greatly in order to accurately measure, and they don't have to guess. They can go around windows and doors and get a very accurate takeoff or measurement. So if you have any questions in regards to this or any of the other classes, please go to our website, www.sfjohnsonconsulting.com, and complete our online form at lower right, so we can do some one-on-one online office hours for anything you still need any assistance in. But other than that, thank you again, and we will definitely see you at the next class. I think we will, if we can find the mouse. It never ends right. All right. See you later, alligator. All right. Thank you for joining me again. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services, where we are discussing plan reading basics for the civil set. And in this little recording, we are going to go over the basics of the utility plan. So we are looking at our overall utility plan for this set, this renovation to this huge high school. Okay, and so you always want to take a look at all the symbols, how they're representing the symbols. Storm drain, sanitary sewer, main gas, electric line, telephone line, catch basin, storm manhole, sanitary manhole, existing contours. Right, so all the existing information is going to be gray, right, as in any set of construction documents. And all of the new construction is going to be in black. Project limit line, so you want to take a look at everything. This is the full project in full, and then it gives you the basics, right? But this isn't enough to complete your takeoff, right? So you're going to go to each consecutive page where they're going to break down the full project to show you where you are. So the full thing is going to be broken down by pages. So this sheet represents this portion of the project. Same symbols, real easy. So if you have a digitized software, you just got to measure lines, the water line, the electrical, the water, the gas, telephone, and of course it's going to, as in all civil sets, you don't really get a big or any, uh, uh, oh God, my mind is flipping. You don't get any of the sheet notes, right? They write everything on the plan, so you just have to, go to each one, make sure you're covering everything. This is pretty simple. I mean, all you're doing is measuring lines, and then of course you have to go to, uh, the detail, so you can see what the configuration of the water service that's coming in. It's going to show you most likely how it's sitting, or how far underground it is, or what the bedding of it is. So let's go real quickly to image number 2 on page 508. This is 50 something. 2. Let's see. 7. Okay. And then image number, we forgot. So we're going to look at all of them. Image number 5. So what are we looking at? Standard gate box assembly. So what do we have to do in terms of the utility plan? Well, we got to count how many this is, in this configuration will show us the dimensions of it. And, a good cost book is going to give you a good price for this. If I'm the excavator, I'm going to look at this on my excavation plan, or however they call it. They always call it something different for every set, but basically the excavation plan, because what do I have to do? I have to account for excavating the dirt to fit it, and then to backfill it. And then here's our sanitary sewer pipes that are going to and from it. Okay, so we just have to look on all of these details to see, okay, is there a particular type of, here's the water service trench, And so if I'm the excavator or if I'm doing the utilities, it depends on, what my scope of work is, but I have to be able to determine all of the quantities of volume for everything I see from bottom to top. And service pipe, because I've already measured how many linear feet from the plan. So I know how many linear feet of that. I know how many linear feet of this whole section I have. And so if I know how many square feet from above times the linear feet from, here in the depth, right? So if I know the square feet, which is basically the area times, in this case, the linear feet, because I'm above here, right? I'm up here on the plan view. And so from the plan view, I can measure this area, right? So that's 2 dimensions all the way down the length, right? All the way down the length. So however many linear feet times that area, that's the square feet. And then here's our third dimension for this. And then I'll do the same thing for whatever this is. And then I do the same thing for whatever this is. Okay, and so I know how many cubic feet for each one of these things I see here. Sand. Okay, the tape, I can measure that however many linear feet of this I measured. Backfill material shall be blank, run, gravel, and paved area. Da, 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 da. I know what the volume of that is. So my material quantities can be easily determined for all of our volumes when we look at all of the detail views from our utility plan. Stone base, so I'd be able to knock this out real easy. And then the pavement, and of course that's from above. So, all right. So this is everything. For everything, finished grade, the curb, okay, the street. I know how, I got to trench this out. I know what connectors I'm going to need, mechanical joints, gate valve, mechanical joint, It shows me everything so I can do all my material quantities all the way up. And so all of these 4/508 taken from my utility plans, right? Okay, so again, big overall utility plan, broke it up. And so what is that? 2/507. Okay, that's a manhole, sanitary manhole, number 25. That's what that is, pointing to it. And so what is this? Okay, so we have 3 pipes, 1, 2, 3, coming out of the sanitary manhole. And so what this is telling us the size of the pipe, 8-inch PVC, and this is giving us the our up and down. What's our GPS coordinates for that? Top of frame is here. So the top of the manhole cover is there. And so our inlets in from the west side, in from the north side, east side out, giving us our elevations. So we will know how to connect our 8-inch PVC, and that's what these all are. Okay, so that's what those represent. And then 2/507 is what this is. What's the configure what we just looked at. Okay, so real easy. Once you do a zillion of them, oh, you've got it. Okay, so same thing here. Okay, utilities. So underground utilities, sewer, water, electrical, all the stuff we don't see when we walk outside. Okay, so what's this? This is, and they give you the length on the plan in most cases, but don't be lazy, okay, because half the time it's wrong. Okay, and then that is the slope, because we want the poopy, right, to slope out, down, out away from stuff. Away. Okay, so this is nice, huh? If you're a nerd, you just like, oh my God, I love it. So what does this have? 1, 2, 3, 4, right? This has 1, 2, 3, 4 things coming into it. This number 18. And so they number it 25. And you think, oh, I'm doing a counting tool. SMH18. Oh, okay, let me not. Okay. Thinking there's more than one of these. No, they're all the same. Okay, so just count sanitary manhole Okay, don't worry about 18, 15, 25, 1, 2, 3, because they're all the same. Especially, here's the configuration, and they all are 2 over 507. And it'll drive you crazy. Then you count them all, and you realize they're all 2 over 507. And you spend an extra hour counting 90 of them. You know what I mean? So take it from me. Don't do it. Don't do it. Dun-dun, dun-dun, dun-dun. Don't do it. Don't do it. Guess how old I am? Well, actually, I think that was my kids. That was for. Anyway, learning from me is chip chip. Hey, okay. How old am I? The Batman and the Titans. Yeah, that's how old I am. All right, so here we go. It's beautiful, right? Easy, easy. So all you have to do is count how many manholes, sanitary manholes, go to that. You know how many of that type you have, whatever it is, because they're basically all the same. If they're giving you the same detail number, it's the same thing here. Okay, so don't be a nerd. Don't do it. Don't do it. Take it from me. Okay, hydrants, pretty much all the same. And what you're looking for is this, right? Typical. So yeah, all the fire hydrants are the same. So what are you doing? You're counting the hydrant. And if you're doing the excavation, you're counting how many cubic yards of dirt you got to dig out to plant that in there. Right? Right. Okay. All right. So, you do the same thing all the way down until you run out of sheets to do it for. And remember, each of the sheets are broken down. They take the full project location. Right? This is what this sheet represents. So you're going to stop measuring. You won't go past your match line. Right? That's what that is. You don't go past this line on the measuring. Okay? Wherever that line is, you don't measure past it. Don't do it. Don't do it. All right. So you go all the way down, but basically that's your utility plan. What are you doing? You're measuring all the lengths and all your lengths of your pipe, right? Your water, your gas, your waters, your gas, your electricals, You're counting, And then you're counting all of your wonderful sanitary sewer, storm drain apparatus, and go into the detail view, figuring out, do you need bedding, do you need gravel. It's a nerd's dream because there's so many things to do. Okay, so any questions or concerns about anything that I've been able to or not help you with, feel free to sign up at our website, www.S F as in Frank, Johnson, consulting.com. We have online office hours for our little students there that love us. And anybody else, sign on and we can help you too, because that's what we do. All right. So this is your teacher, Stacy the Johnson, and I will see you. It was a beautiful day in the neighborhood. Okay. When I was a little girl. So there we go. Thanks a lot. Talk to you later. Hello, everyone, and thanks for joining me. My name is Stacy Johnson, and I'm the owner and operator of SF Johnson Consulting and Construction Services. And in this series of classes, we will discuss a set of construction documents on basic plan reading. We're going to look at each sheet individually per video, go over what is the most important, and hopefully give you a clearer understanding when you are looking through a basic architectural set of the construction documents. We'll start with the architectural set. We'll go into the structural set, and then individually each of the MEPs, or the mechanical, electrical, and plumbing. So in this set, we're going to be talking about the cover sheet. And the cover sheet is the first sheet that you'll see in the construction set, and it gives you a basic overview of the project itself. When you look at the cover sheet, you're able to determine if the project is from the ground up, renovation, and the extent of the project. So for this one in particular, with configuration of wire that it needs to power it properly. So, kitchens and things of that nature are usually very complex. So now, but what we're looking at again is the cover sheet. And so our cover sheet in particular has, if we go from left to right, we're looking at the project responsibility chart. And the responsibility chart basically is just a list of the items comprised within the project, not everything, but some things that they want to point out. And they'll tell you who's supplying the material and who's installing. And so they'll give you indications of supply and install. And when we look at a set of construction documents, it's an agreement between the owner of the property and the general contractor. And so it won't list subs, right? Because we know the general contractor just supervises all the subs that do the work. And so when you look at a set of construction documents, you'll see GC and owner. You won't see subs, but we know that subs do all of the work pretty much. Okay, so responsibility chart, all of the items, equipment, smallware, exterior signs, building signs, drain system, CO tank, security system. And again, it'll tell you who's going to supply the material, the owner or the GC or the GC subs, and who's going to install the material or the item, the owner or the GC subs. Okay, so that will be what we have there. And the most important thing is the sheet index, or the list of the sheets comprised within the set. And so when you look at the sheet, you can get a pretty good idea if it's from the ground up or if it is just a renovation. Anytime you see a set of structural drawings, you can assume it's from the ground up, especially if we have a foundation, right? Foundation means there's nothing there. So we are setting the foundation and building most probably a new building on top of it. Or you can have, renovations also have structural sets, but not a full complete, because chances are it's just we're adding to, or it's an addition where we're adding to the existing foundation. And so when I look at this tells me structural framing is probably from the ground up. Okay, so sheet index, all of the sheets that are comprised within the set. And so individually, we'll just talk individually about, what we'll be looking at in each one. So CS100 is the cover sheet. That's what we're looking at right now. BR100, bidding requirements. That's just excerpts that they have taken from the specifications and they have included within the construction documents, just to make some of the things easier to reference instead of going through the whole set of specifications. Site drawings. Okay, so this is the site drawings that we have here. They're very basic. They're not a full, complete set. This is more or less what they call the MEP site plan. So it's an overview on one sheet of everything that would be in a full set of site drawings, and we'll discuss that in detail. But that's what this set in particular provides. And then the architectural drawings, which is everything that goes in and on the building once the building's been constructed or once the structural components have been constructed. So we're looking at the new floor plan, new ceiling plan, new roof plan, and everything that goes in the building once the building's been constructed. So that's the architectural set. And always after the architectural set, we do have the structural drawings, which is the building box. So the foundation and all of the structural components, beams and headers, and the roof framing, that's the structural. And 9 times out of 10, you will always have the structural set come after the architectural set, although in real life, as we know, structural comes first. Okay, and also within this set, because it is a kitchen, you're going to have the kitchen set, which kind of shows you where all of the equipment is placed within the kitchen. And so the schedule of all the equipment, where it's placed. So we want every restaurant to look like every other restaurant. So of the same kind, right? Every McDonald's the layout is the same no matter where you go. And so that is because of the kitchen setup that we have here, or the equipment plan. Now, always last in the set of construction drawings are the MEPs, or the mechanical, and I put E before P, but P comes before E right here, but the mechanical, electrical, and plumbing. And the mechanical drawings handles the movement, cooling, heating of the air, so the HVAC system, Plumbing is the movement of the water in and out of the building, all of the liquids and gases in and out of the building. That's what plumbing drawings typically show you. And then the electrical set is how the building is powered and how we control the lighting. Okay, so on the cover sheet, of course, it's going to give you the sheet index, or all of the sheets that are comprised within the set. And in this class, we'll go over each of the sheets individually, what's most important, what we need to look for, and what you need to know. Also on the cover sheet, a legal requirement that, and let's get over to it, it's a legal requirement that the owner's information, the architect, and all of the engineers that contributed to the construction or the putting together this set, it's a legal requirement. Their contact information has to be on the cover sheet. So we have the owner, the architect, the mechanical, plumbing, electrical, and structural engineers that were used to put this set together. We always need to know who we need to sue. So that is why that information is there. And then by having the code information, it's saying, yes, the set is compliant with the codes that were in place at that time. And so by having them here, it verifies that, yes, the code for this year applies to this set because that was what was in place at the time. Building occupancy information. Remember, every set of construction documents is different, but this is the basic information you'll find in every set, whether it's on the cover sheet or the few sheets after the cover sheet. Okay, so building occupancy, square feet. If it's an apartment, with different types of units, it'll tell you how many, 20 of apartment A, 32 of apartment type B. Okay, so it gives you all that information. And then the Google Maps, so you can have a frame of reference as to where it is located. Now, on cover sheet and on every sheet, the right band is always going to have the same information, except for the page number, of course, because every page number is different. And the right band is going to be oriented in this direction because typically we roll up the set of construction documents. They're rolled up. And so as we have them all rolled up together, all we have to do is flip this end and then we can get the page number we want. So all of the same information, the project location, the project name, project location, and always, if the set has been approved for construction, it'll give you a permit date. Okay, and that's the date we always use when we say this estimate is based on specifications and plans dated that date. And so you always want to use, if there are addendums, you always want to use the last date of the addendum. And if there is no date there, that typically means, they're looking for prices and maybe they're pricing it before they get the permit because you cannot build something without the permit date on there. So be mindful of the permit date. Okay, so that is the cover sheet. That's the first sheet you'll see in the set of construction documents. In ours, it has the responsibility schedule, which tells you certain things within the project, who's going to provide the material and who's going to install that. Sheet index, always going to tell you the sheets that are comprised within the set. So you'll know the extent of the project, if it's a renovation, if it's from the ground up. And that is a clue to, is there a really detailed structural set of drawings? Okay, and then all the drawings, what are found, what we're looking at when we look at each of the sets. Oh, of course, we're going to have all of the abbreviations that we may find. We go here and we say, okay, we know AFF, above finished floor, TYP, typical, we'll look for stuff that we may not know. And then all of the symbols that they use within the set. Okay, how they show you, how's a note different from the window, different from the door, different from a revision number, different from an interior finish. Where's the section view marker, the detail view marker, the elevation marker. Okay, so these are all symbols used within the set because set of construction documents is just a graphical representation of a project, and the only way to describe it is by using symbols and numbers and abbreviations and all that good stuff. Okay, so the cover sheet, first sheet comprised within the set, gives us a good idea of what the project's going to be all about. And if you have any questions or concerns, of course, you can sign up to online office hours by going to our website, www.s as in Sam, F as in Frank, johnsonconsulting.com, and complete the online office hours, and we will set a time that's good for you. Otherwise, thank you so much again, as always, for joining me, and I will see you at the next class. Let's get smart and learn everything we need to about construction. See you next time. Bye bye. Hello, and thank you for joining me. And this is your teacher, owner, and operator of SF Johnson Consulting and Construction Services. And in this small snippet, we are going to discuss the ceiling plan for our series of our study of the plan reading basics. Okay, so now we're looking at the ceiling plan. So it's from the plan view, the view from above. And the ceiling plan is going to tell us all about our new ceiling construction. And so for commercial, the typical ceilings are going to be acoustical ceiling tile, which is represented by these lines that represent either the 2x2 tile or on this side, the 2x4 tile. And each of the rooms, it's going to have a ceiling tag or room tag, ceiling tag that's going to tell you two things. It's going to tell you the type of ceiling finish, and it's going to tell you the height of the ceiling. Not necessarily the height of the stud, so don't confuse the two. It is the height of the ceiling. And so on the ceiling plan, we're going to see everything that's going to go in the ceiling. Not only the ceiling finishes, but then we're going to see all of the HVAC supply grills represented by the X, all of the lighting fixtures and where they're represented, because the ceiling finish person needs to know, okay, we'll have 1, 2, 3, 10, 12, 15 less 2x2 tiles, because why? We have a grill in there, or we have a few of the tiles that need to be fitted for casings for the lights. Okay, so when you see the ceiling plan, you're going to see everything that's on the ceiling, that's represented on the ceiling, and it's typically for reference only for this whoever's installing the ceiling finish. So ceilings, again, for commercial, will have a 2x2 acoustical ceiling tile, 2x4 acoustical ceiling tile, and then we'll usually have some some gypsum or drywall, right? So this is saying that this is a drywall ceiling, and the height of the ceiling is 8 feet above finished floor. Okay, now always have to take a look, because here on our ceiling plan, we also have a section view marker. And what is that? Well, it's telling the ceiling contractor, whoever's installing the ceiling components, that there is some other view you need to look at, because the construction of the ceiling is a little different. And so we're always going to take a look at that. So we're going to look at image number 1 on A103, which is, this is page A103. And now this is image number 1. So in terms of our framing, because this is for our, our framer would need to know this information. So you would have to break this ceiling construction down in the most practical way in order for you to make measurements and to determine a cost for this. So we're basically just looking at the menu board that's represented here, and it's basically a wall coming down from the ceiling joist, as opposed to the floor plan where the walls come up from the ground. Same concept, just coming down from the ceiling. And then here on the right, this is the bulkhead. That is basically 2 walls, right, coming down from the ceiling, and then in between you have a flat surface like a ceiling. And so you would break it down in those 2 ways. And so how we would break it down, anytime we have a wall, we need 2 dimensions. What's the height of the wall? What's the length of the wall? And then we can determine the ceiling framing for this set or this section of wall. We know the height is 4 feet 10 and a half inches, and the length corresponds to the menu board, which is from the plan. We can measure here, that's the menu board length, and I think that's about 20 feet long. So 20 feet times the 4, whatever, how many square feet of that menu board framing you'd have to construct. And so you break it down to the framing, and it looks like you have the top plate, that would be that same 20 feet, right? The bottom plate, same 20 feet. And then you break this one down the same way. And so basically what you have is 2 walls that are 3 feet, 10 inches, whatever. Excuse me. You can combine that and say you have 7 feet worth of wall times what's the length of the bulkhead, right? The length of the bulkhead is this length, whatever that is. I think I can, oh no, we have to change the scale. The scale is different. And see, when you're looking at a set of construction documents and it's trying to tell me that that's 4 feet, that's obviously not 4 feet, right? 4.8 or 5 feet, 4.9. So that tells me, oh, something's wrong with the scale. But yeah, I was using the scale to measure this, right? And this scale is for every 3/4 of an inch, it's 1 foot. But I should have had it on this scale, which is much different. And so, yeah, the measurement's going to be different. Where the scale for this is for every 1/4 of an inch, it's 1 foot. So I have to make sure I change the scale, and that's important, or else you'll be measuring stuff wrong. All right, now we can go back and see what's the actual length of that bulkhead length right there. If I click on it again, it's 15 feet. That makes a way more sense, right? So we can round that up to 15 feet times, well, we say 2 times these lengths. So now you see these lengths have changed because the scale has changed. And so scale is very important when you're looking at a set of construction documents, that it is correct, because it's obvious the menu board bulkhead is not 12 feet. Area of this bathroom area is about 200 square feet for the bathroom, and we cut off the area for this, so we would determine that area plus the wall construction here, wall construction there, wall construction there. That would be the ceiling in terms of our framer. And then if we're the acoustical ceiling tile person, we're going to measure the area of all of this, of the 2 different types. Okay, so this is the ceiling plan. It tells you all about the new ceiling construction. If we're the framer, we're looking for any drywall construction or that bulkhead construction. If we're the acoustical ceiling tile professional, usually they don't do the same thing. So if I'm doing the drywall, I'm usually not doing the ACT, or I might. It really depends. But we always break that down separately, of course. Okay, but the typical framer is not going to do the acoustical ceiling tile. Okay, so it shows us everything on the ceiling for reference. So we know if we are installing the acoustical ceiling tile, we know we have a couple less tiles because we're going to have a supply grill for the for the HVAC system, and a couple, a few have to be specialty made for the can lights that are going to be coming through that. Okay, so that's pretty much all you need to know about the ceiling plan. All new ceiling construction, each room is going to have a ceiling tag that tells you 2 things: the ceiling finish and the height of the ceiling. If you have any questions about any of the information, please make sure to visit our website, www.sfjohnsonconsulting.com, and fill out our online office hours, and we'd be happy to set some time aside for you to go over this one by one. But again, thank you for joining, and I will most definitely see you at the next class. Take it easy. Hello, everyone, and thank you for joining me. My name is Stacy Johnson, and I'm the owner and operator of SF Johnson Consulting and Construction Services. And in this video, this is a part of a multi-part series where we are discussing every sheet individually in a construction set, the architectural set, the structural set, and all of the MEPs. In this class, we'll be going over the little portion of the specifications that are involved that they have provided in this set, and also the typical construction schedule, how we read it, how we construct it, and just to go over some details. Okay, so this is the second sheet in our full sheet, our Popeyes construction set, and this is the BR100. So it contains schedules and specifications. Okay, so bidding requirements is what the BR stands for. And basically what they've done is giving you some of the information from the actual set of specifications. And so examination of site, explanation to bidders, all the way through, things that you want to make sure you review. And again, these are all things that you would find in the actual specifications, but they've just included things that that are important, bidding requirements that they want you to know. So they have also included it in the set of construction documents. So the most important one I like to see is the final payment and the AIA documents, what's required in order to get paid. That's very important, and how the information needs to be presented to them. So this is a good set for that. So again, this is the BR100 bidding requirements, giving you information from the specifications, and then also it's giving you a breakdown of a TYP, which is typical construction schedule. So when anytime they include the word typical, that just means that every time they do something, they want to do it the same way. So they do it typical, they do it the same way, they don't want any variations, but of course, things change. So what this represents is the construction schedule from beginning to end for the project. And so the way we read it, the columns are everything that is going to be done within each of the columns. And then the amount of time they tell you it's going to take is the number at the bottom. So in this case, it's the amount of time in days that it is going to take them, or they say it's going to take to achieve each of, or the full scope of the items in each of the columns. And so for our first one, what they wanted to take is 1 day to establish the construction schedule. The contractor receives notice to proceed and finalize all national account quotes and pre-construction meeting. They want all of those things to happen within 1 day. And so if we progress on, contractor mobilization, order national account buyouts, they assume that will take 3 days, and on and on and on. And so they begin with basically mobilization paperwork type stuff. Then they go to the surveying, rough grading. And so you can look at each of the columns and see the progression as the project moves forward. What comes first, what comes second, and this is a good teaching tool too, to show, the progression of any project. What comes first? What do we do first? What are some of the things that we can do at the same time? And so they have created a typical construction schedule for this Popeyes as they work through each of the items. And again, the bottom number is telling us how many days it's going to take them to achieve whatever is in the column. And so when we get to, if you do any project management courses, you know that you can, you need your detailed estimates in order to determine really to accuracy how long any of these scopes of work is going to take. So a good cost book will help you determine the man hours for each of these operations. And once we know how many man hours it takes to do whatever, then we can start to build the construction schedule. And we know how many days it will take to build, whether it's the framing or the roof finish. From the estimate, from a good estimate, you should be able to determine the man hours it's going to take for everything within that estimate. And so that's where you get these numbers as accurate as possible by doing a detailed estimate for each of the operations within that. And some of the things, again, you can do at the same time. Okay, so that's building a construction schedule. And that's a separate class. Okay, so again, this was pretty simple. Bidding requirements, BR 100. They've taken some of the items from the set of specifications, included it in the construction documents. So for ease of review, and also the typical construction schedule gives each of the contractors, the subs, an idea when they are to perform their scope of work, who comes first, who comes second. And I always recommend that, if you do any project with a GC, the quality of the general contractor will be shown through the quality of their construction schedule, if they have one or not. So that's pretty much it for this sheet, the BR 100. It's, again, part of a multi-part series. We're going to be looking at a full set of construction documents from the cover sheet all the way through the electrical set. If you have any questions or concerns, please go to our website, www.S as in Sam, F as in Frank, johnsonconsulting.com, and sign up for online office hours, and we will give you additional time one-on-one to go over any information on any of the classes. But again, thank you for joining me, and I will see you at the next class. Have an awesome morning, afternoon, evening, wherever you are.
Hello, this is Stacy with SF Johnson Consulting and Construction Services. And in this small video, we're going to discuss the door schedule and some window elevations. Now, everything in the construction set is very important, as is the door schedule. And so we'll take a look at the schedule. This one also includes some details for the door jambs and some other things and some other exterior details, but we're going to focus on the door schedule. Now, in any project, every door is listed on the door schedule, even if it's the exact same size. regardless of where the door is, if it's a small door, if it's the storefront doors, if it's interior doors, exterior doors. They're all listed on the schedule and by the size, the door type, which they'll give you an elevation view of the door type. So those are the different door types: A, B, C, D, and E. So if you have to price them, then you know the exact type, and hopefully from a material supplier or a cost book you'll be able to get a pretty good price for that door. So it gives you the height and, well, the width is the first number. Height, of course, is the height of the door. And then if it is a pair of doors, it'll let you know. Okay, and so the type, the frame, uh, depends on, each of the different doors may have a different frame type. That's SF is most probably a steel frame and a hollow metal frame. And in commercial construction, most of the frames are hollow metal frames. And so to give you information about, well, some do about the finish on the door, how it's painted, and then all of the lock set and all of the hardware that's associated with each of the doors. So that's the door part of the door and window schedule. And then, of course, the window schedule is going to give you an elevation of the windows or the view of the windows as if you're standing in front of the window. So you can determine the height and the width of each of the windows as well and how they're uh, looked at. And two, who would need this? Of course, whoever's installing the doors and anyone doing the caulking around the doors would find this useful, so they could determine how many linear feet of caulking you need for the doors. So the door and window schedule is pretty simple. It just shows you all of the doors, and again, even if they're all the same size, which many of these are, they still have to list it. The type of door. Let's move that. The type of door, the frame for the door, all of the framing details, and that points us to a detail that's probably on this sheet that gives us the framing detail and a whole lot of other information: the stop, the threshold, the closer, the lock set, and water stripping, everything involved in the door. And again, the windows are going to give you all of the elevations of every window. Now, the difference between doors and windows: if you need to know the number of windows, then you have to look on the exterior elevations and count. Where if you need to know how many doors, they're all listed here, regardless if they're the same, they're all listed here. So we know that this project only has this many doors. But as far as the windows, again, we'd have to go count via the exterior elevations and count the different types of windows. I think there's probably two of these and two of those and whatever. But you got to look at the exterior elevations in order to determine the number of windows, where on the door schedule, it gives you the exact. You just count, it's there. For windows, again, you have to look at the exterior elevations, and like for a high rise or for an apartment, chances are they're marked A, B, C, D. So you use a counting tool, count all the A's, all the B's. Then again, you'll know how many windows you have. Okay, so this is Stacy Johnson, SF Johnson Consulting and Construction Services, where we teach classes of every kind. This is part of the basic plan reading class where we're looking at the door schedule and the window elevations. Feel free to contact us at info@sfjohnsonconsulting.com on questions on this or any other class. Thanks a lot, and we will see you next time. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we are going to discuss the master format or the specifications. And what is the master format? Well, remember in our classes, we have the construction documents and then we have the specifications. Well, the master format is the full list of all of the specifications that you could possibly have in construction. And they are listed by division. They start with 00, 00, 00, and go through, I think, 28 series. But basically, the specifications, as we can see by definition, they're the standard for all commercial building design and construction projects in North America. and it titles and sections numbers for the organizing of data about the construction. And so it will give you information regarding the material and how they want the material applied, or how they want, for instance, the drywall. Do they want it vertical or horizontally placed, and all of the good stuff. And so if you have to think about the construction documents, you would think in this way. The construction documents are pretty much the written words that go with the pictures. And so every time you see a picture, you're going to have uh, something related to that picture in the specifications. And so we start with they're ordered in a sequence of three digits, three component 2-digit numbers. And so the all of the zeros are pretty much paperwork, submittal information, scope of work, all of that type of information. So that's pretty much all the zeros. And then you just go through if you are of whatever type, and then you have to look in the woods division if you are framing wood framing. So everything, absolutely everything, everything. So 05 and 06. 05, 00 is metal. 06, 00 is wood and plastics and composites. And so you go through there. What you're going to do is you're going to read your specifications first, and then you're going to write down everything that's specific to your scope of work. You're going to take that into the construction documents, and then you'll put the two together and you'll produce an estimate. So again, master format, everything that you could think of. Roofing, roof, windows, and skylights. If you're into windows, you're going to look at what? 05, 50, 00. So when we have these specifications, class, and test, I will tell you that you are this kind of contractor doing this particular scope of work. And so what I would want you to do is go into the specifications and tell me specifically what division and all the way down to the subdivision of these specifications that you would have to read. And so if I say you're doing wood framing of a, it has to be, or if you're doing metal stud, light metal stud framing, that's easier because those are really specific divisions you can go to and break down, you know? And so that's what it would be. Or if I said you're doing a particular type of demolition, then you would go to existing conditions, specification, look through those subdivisions to find that particular specification that outlines how you are to perform your scope of work. So any questions, any concerns, please contact me at our website, which is S as in Sam, F as in Frank, johnsonconsulting.com. And thank you very much, as always, for joining me. And we'll see you next time.
Hello, and thank you for joining me. This is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services. And in this short video, we are going to review the foundation plan in the structural set. Okay, so the structural set typically comes after the architectural set in the set of plans, and the structural set is basically the set of plans that make up the box. And so in this case, we're going to be reviewing the foundation plan, the shear wall plan, the roof framing plan, and the details that go with it. So in this small section, we're just going to be reviewing the foundation plan. So when we look at the cover sheet for the structural set, the S plans, they typically will give you information about loads and things related to physics and things of that nature. And it will give you kind of information about stuff that's kind of different, because we're talking about calculations that are needed in order to build the foundation, the walls, the beams, the headers, everything that's needed to keep the building up. And so it typically involves math. And so you'll see on the cover sheet is a lot of math related calculations and information. And so in this set, we're going to be talking about the foundation. So 2,500 psi is a total load, and so they'll give you the pressure from which the concrete is placed, but for our purposes, that's not important. And then, of course, we're going to find out about the type of reinforcement. And so when we talk about the foundation, and we'll go to the foundation plan. Okay, so the foundation is basically the bottom of our box. And so when we think about the foundation, we're going to talk about the continuous footers, which is which makes up the structural portion of the load-bearing wall. So the continuous footers, and then we have some footers that are coming within the building, and then we also have some column pads. And so when you think about the foundation, basically what we do is we form it out in the shape that it's supposed to be in. We place the reinforcement based on the standards, based on what the structural engineer has determined it should be, and then we pour the concrete. Okay, so in order to perform a good estimate, what we need to do is first determine the footer, the continuous footer. And so like our floor plan, we're going to have section views that's going to give us information about the configuration of the footer, how the reinforcement is placed. And so what we typically do in order to perform an estimate, we're going to determine how many linear feet of each of the types of the section. Same thing we would do for the floor plan and for new walls that are built. And so this is broken down by section. And so the continuous footer, what we calculate first. And then in terms of the concrete slab, the slab on grade, we need to know what the area of that is. And the information here tells you about the thickness of the concrete and the reinforcement. 6x6 W1.4 by W1.4, that's reinforcement. And then we did a soils report, of course, for the subgrade preparation, for slab, okay? So that's not our concern when we're doing the estimate, but if you can see here, the foundation is built from two different thicknesses of concrete. On the left is 6-inch, and on the right is 4-inch. And so you just need to determine where the dividing line is, and it's clear that it is right here. And so what this is telling us is that from on the left portion is 6-inch, but on the right portion is 4-inch, and then we just measure our area. Okay, so let's break down the foundation in terms of the continuous footer, because we have to know slab on grade is a area we know, it's not much to it other than how we place the reinforcement. But for the continuous footers, they are of a particular configuration that you do have to determine the stem wall, the configuration of the rebar. And so we'll go to the section views. Foundation section view. So section view 101, which was the exterior wall footing. And so in terms of doing the takeoff for this, we would pretty much break this up into 3 sections, which would be the clear, the bottom portion of the footer, the continuous footer, the bottom portion, and then the stem wall leading up to this thickness, because this is an 8-inch thickness, but when we get here, 2 inches of it drops off. So we have 3 sections that we would need to determine the takeoff for. And so it's clear what the configuration of the rebar is. So you just have to make sure you understand how to read it and how to determine how many linear feet of each type. So we have number 3, number 5, number 6. And so if we start from the bottom for the rebar, okay, we would just say, okay, so we have number 4s, and each of the lengths is 18 inches, and they're placed every 24 inches or every 2 feet. So that's easy to calculate. Okay, so if we know how many linear feet of the continuous footer, which we do from getting the measurements from the floor plan, then you can determine how many placements or how many times. I think it's 300 feet. 300 feet of continuous footer. And so what does that mean? For this placement, that means if we're placing it every 24 inches. We're putting it every 2 feet, right? So that's 150 of these placements. So it's 150 18-inch pieces of number 4 rebar. Okay, so you just work your way up. So it's again, there's 3 of them. 1, 2, 3. Number 4 continuous. Provide corner bars lapped every 24 inches. So same thing. So if we have 300 feet, we know we have 900 feet of this. And then the last one we'll go over is this one. Number 5. This means that we're going to shape it in the shape of an L. And we're going to place that because this joins the stem wall and the continuous footer. So we're going to shape it in the shape of an L. And we're going to place that every 16 inches on center. And so it's real easy to determine how many linear feet of each type of rebar. You just work your way up, all the way up until you get there. This is to scale, right? So for every 3/4 of an inch, you really have 1 foot. And so you can determine, the only thing that's kind of tricky is like, what's the length of this L? And so if this is to scale, then I measured that to be, I don't know, almost a foot. And so I could estimate that to be probably 3 feet or something. I don't know. But yeah, let's see, 2.5. That's a foot. Yeah, something like that. Almost. So easy to determine all of your material quantities, even your hook anchor, your bolts, your anchor bolt, right? If you're putting them every 2 feet 8 inches on center, unless otherwise noted, right? If you got 300 feet divided by 8 over 12, so 2 point something feet, then you know how many placements for that. And you can determine how many anchor bolts you need. And the bottom plate, if it's 300 feet of walls, 300 feet of bottom plate. So it's really easy. And so these are all of the other section views. This is this is what it looks like going from our 4-inch to our 6-inch slab at that section view, giving you the makeup of the slab on grade. So it's real easy. You just got to break it apart piece by piece. Take your time. If you're a nerd, you'll be in concrete heaven. Okay, so this, it's more like a column pad. It's pretty big. What do we have? Now, in order to determine concrete totals, right? We did the rebar, we didn't talk about the concrete, right? So for the concrete, you need 3 dimensions. 3 dimensions, right? You need the length, the width, and the height, right? So if you do, well, it's going to tell you here, right? So not to scale, but it's 3 feet. 3 by 3, so 3 by 1, so it's 3. And then your third dimension, right? So it's 3 feet wide, 1 feet tall, 1 foot tall, and 300 feet long. So it's basically 900 cubic feet. And then you change that to cubic yards, and that's how much concrete. Same thing with this. So we know we have this width of the wall, stem wall. Then we're going to break it up here because we're good estimators. We break it up here, and we say this times that, right? Height times the length. That's cubic feet. Change those cubic feet into cubic yards, and you know how much concrete you need. Same thing with the slab on grade, okay? So you do the square feet from above, and then times the thickness, which is really times 0.25. So that is cubic feet of concrete slab on grade. Convert that to cubic yards, and you know how much concrete for the slab on grade. All right, so this is the first portion of any structural set, which is your foundation, which is your box bottom, the bottom of the thingy, the building, the thingy. Right, it's concrete. You have your continuous footer that makes up, so any wall that's connected to your continuous footer is going to be a load-bearing wall. And so we can tell that we have, and this is exterior concrete slab on grade, referred to the civil set, right? Because this is the structural set. It's only going to give us concrete for the building, not for outside, right? The civil set gives you the concrete for outside. All right, so we have our continuous footer, and any wall connected to our continuous footer is going to be a load bearing wall. So we have, of course, the exterior walls are load bearing walls because it has to hold the weight of the roof rafters. So you know those are load bearing walls. And we see that we have a few coming into the building. If you went over the A plans for this set, you'll know that that is the bathroom. So the two exterior walls of the bathroom are load bearing walls. Of course, the exterior is a load bearing wall, but there's a wall here that's built from the architectural set. So obviously, that is not a load bearing wall because there is no footer coming in where that wall is constructed on. And this is a load bearing wall. Okay, so that is our foundation plan. Continuous footer, slab on grade. If you have columns, you know, and this doesn't really have columns, these square, that's the, the universal symbol that there's a column, but it's just a huge pad. There's no actual beam or anything, I don't believe, connected to that. And if it is, we will see on the framing, structural framing plan, because this is only going to tell us our concrete and how it's reinforced. And so, of course, you want to look at all of your notes for keynotes and the general notes. And so that's pretty much all we have in terms of our foundation plan. Continuous footer, go to the section views, determine what that reinforcement configuration is, and then how many square feet of slab on grade times the thickness. And so remember, anytime we're talking about concrete, we're talking about a volume. So we need 3 dimensions. The sweeping hands right here refer to, they don't want to put this here, then here, then here, then here. That kind of indicates it's the whole area. Okay, same with this one, whole area. And because it's in exterior concrete, it's not going to give you any dimensions of anything not related to the actual set. All right, so this is the foundation plan as part of our plan reading basics, the structural set foundation plan. If you have any problems with any of the classes or need additional help, know that you can go to the homepage at www.sfjohnson. Hello, and thank you for joining me. This is Stacy Johnson with SF Johnson Consulting and Construction Services. And in this small class, we are going to review part of the structural set and the roof framing plan. So the roof framing plan is different from the roofing plan. Well, in the roof framing plan, because this is a single story building, the only framing portion would be the roof as far as the structural set. If we had multi stories, we would have the first floor ceiling joist and the second floor joist plan to look at, and then all the way up until we reached a ceiling plan. So this roof plan is part of the structural set. So what we'll find is the structural framing in terms of the roof framing, roof joists, and any of the columns, beams, and posts related to the structural framing. So this is a roof for a Popeyes Louisiana kitchen. And so what we're seeing here it's going to show us when we talk about the structural set, the way that they represent the framing is going to be a little different. They represent it by using a sweeping arrow, which goes from one end of the building to the other end of the building in this case. And what that means is that you have the same kind of framing all across the entire roof. If it was different, say for instance, if this was a home and this roof framing was different, there'd be another sweeping arm like this in this area, and it would tell you also the type of roof trusses. So this roof framing consists of a 30-inch minimum flat roof trusses, and they're placed at the 24 off center. And so basically the lines here represent the roof trusses, and they are manufactured to fit each roof specifically. So we know that this framing for the roof is their flat roof trusses Minimum width of them 30 inches, and we're placing them every 2 feet. So that's one thing. So we would determine, for the purpose of the estimate, you could do it two ways. You could do it, if you use a good cost book, it's going to give you the cost per square foot. And so you're going to determine how many square feet of roof you have. Or if you want to do it more specifically, you're going to determine how many roof trusses you have of each of the individual lengths. And so that would require from here to here, pretty much they're the same length. And then they get bigger here to here. And those are the same length until we get to here, right? And then they get bigger or larger when they get here. So two ways of doing it. It really depends on how detailed. But in real life, you would have to determine how many of the different lengths you would need. So, but the purpose of a cost, for a purpose of bidding, you can get a cost book that would give you the cost that's approximates the same thing, but it would give it to you in square feet amounts. So that would be good. Okay, so that's the first thing that you would determine, and then really you'd have to look in your methodical way of looking at each of the sheets. You start in one area and work your way all the way around until you got back to the other area. Because this is a structural set, we're going to be looking for the flat roof trusses. We're going to be looking for columns. What's the makeup of the columns? We're going to be looking for headers. So that's what we're looking for. And so everything here is marked. A means something. We have A's, and those are most likely the columns. And so there'll be a legend telling us what A and what B, C, and all the way down. So keyed roof notes. Here we go. So A's are 3. So we sandwich them together. 3, 1 3/4 by 5.5 LVL posts for hold down. Attach stud to stud with 2 rows of 16D sinkers at 12-inch off center. And so these are all of the posts. So in this case, you would count how many posts you would need of the particular height. And so wherever you have B's, you have 1, 2, whatever, and go all the way down and identify everything that's on the plan. Okay, so it's a matter of, now you have to look at a section view, which it gives you section views right here. So 209 is a section view that gives us a view, the vertical height at this section of wall. 207 is a section view that gives us a vertical. And really it's just showing us how the roof trusses are attached to the posts, the beams, and the exterior walls. Okay, so you have to make sure you have that. And then third are the headers, right? So why do we use headers? Anytime we put a hole in a structural member, meaning when we create doors and windows, and a structural member, meaning a load-bearing wall, we have to give the strength back in that area. And that's how we do it, by putting headers in the upper portion of the door and the window. So here it identifies different headers in the makeup of the headers. So header number 1 is a combination of 3 2x12s with a 1/2-inch plywood spacer to match the width and column of the wall. And the height basically is 9 feet 4 inches above finished floor. So in this case, you would measure how many linear feet of each type of header you have. So you go around, look at the headers. This is header number 5. We would measure how many linear feet, and then that's how we would price it. Okay, so roof framing, and again, the framing plan in the structural set will be all the structural framing, because this is only a single-story building. The only structural framing is the roof. If it was a multi-story building, this would be again the first floor ceiling joist attached to the second floor floor joist, and all the way up the building. So we'd have all of those, instead of the flat roof trusses, we'd have all the joists, and we'd have all the headers on the second floor, third floor, fourth floor. Think of a hotel. It would be the same all the way up until we got to the roof. And then the roof framing would be the last. So how they represent structural framing is by using the sweeping arms from one end of the building or wherever they're trying to represent that particular type of framing, all the way to the other. In this case, they put the description of the framing right in the middle so you'll know. So you need the area of that, or you can go through and specifically determine how many of each particular length of flat roof truss that you have, and that's what you'd have to do in real life when you order them because they're made to order. That's the first thing. Second are all the posts and columns. So you would look where they identify all posts and columns, and then in the description it would tell you. So if your cost in your cost book is going to give you one time, so of course you're going to go through whatever it gives you as the material cost and the labor cost. You're going to, of course, multiply it by three, by two, by whatever it tells you, right? Because the cost book is going to give you the cost for one of these. So back to, for the takeoff for an estimate, the area of the roof, or individually measure how many linear feet of each type of truss you have. Second are all the posts and columns based on the information they give you. And third are all the headers. So posts and columns, you're going to say I have 10, 20 of each particular height, and you're going to look at the section views in order to determine the height of those posts. And the headers, you're going to measure the linear feet, looking at also at the keynotes of the makeup of the header. So area for the roof, each for the posts and columns, and linear for the headers. And also in a cost book, it's going to give you, you'll add a certain percentage for connections. So it'll be, if the cost is, it's usually about 15% of the cost of the material we add just for the connection. So we don't have to go through there and do 1, 2, 3, 4, 5. 15% of the cost of all of the structural members would suffice for the additional cost for the connectors. Okay, so here are how the roof trusses represent the roof trusses, and then this represents just the insulation, and how we make a flat roof more of an angle. So that's what they're showing us there. And then if we can go to some section views. Oh goodness, we've got the blue circle. Okay, there we go. We go to a few section views. Let's see. Oh, we went to the wrong section view. Foundation. Boop, boop, boop. All right, here we go. All right, so section views showing you, and really that's all it's going to show you, is how the exterior load-bearing walls are connected to the roof trusses and how they're connected and what they use. And so the height really you'll get from, go to the architectural set, to determine the height of each of the posts. It's typically 10 feet for commercial, sometimes 12, 16, really depends. But in this case, you can go to any of the architectural sets, right, to give you section views of the exterior walls are here. So the posts are going to be, to the height, to this height. So really depends. You can go 14. And really for the purpose of cost estimate, you're going to, go over. So this is 14, 16 feet, columns or whatever, post 16 feet. You never want to cut yourself too short. So those are really, the height of the post would be really the height of these exterior walls. If you needed that information, that's where you could get it. So the posts here, A, B, C, headers, da 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 da. Okay, so that is structural framing for a single story building. We have our roof trusses, you have your posts and columns, and then there you have lateral bridging. Points it out right there. Lateral bridging, see detail 2 in 204. But we won't do that now because when you take the class, we would have done that already. So this is a quick overview of what structural framing looks like for a single story building. Roof trusses, post columns, headers, how they're connected. If you have any additional information you need and you're a student, please feel free to sign up at our homepage. We have online office hours where we'll set a time for you specifically to assist you in any other way that we can. Once again, thank you for joining, and I will see you at the next class. Hello, this is Stacy Johnson with SF Johnson Consulting and Construction Services. And in this small class, we are going to discuss the shear wall plan in the structural set. Now, the shear wall plan is basically just additional framing that we put over our uh, load bearing walls to shore it up and to help prevent the building from falling due to shear winds and earthquakes and things of that nature. So the shear wall plan is pretty simple. Where in this on this set they note them as P1 and P2, and they show you exactly where they should go. So it's really simple. Where P2 goes here, just this length of the wall, that length of the wall. P1 goes in 3 locations on this side, right side, and then this wall on the left side. So it tells you the configuration of each of the shear walls. It indicates one side of the wall to receive 15/32-inch sheathing fastened with 8D common nails, 3-inch on center. So 8D is the size of nails, and they're just telling you to place them every 3 inches at the panel and boundary edges with 1/2 and 12 inches off center at the inner supports, and then additional 3x6 studs at the edges. Okay, so it's really simple, and P2 incorporates some LVL beams with 2 rows of 16D sinker nails at 16-inch off center at panel edges. Okay, so shear walls really just additional framing over your load-bearing walls to help strengthen the wall. And so here in this set, this indicates a hold down. So they have A, B, and C. And so you can identify each one and, come up with a pretty good material quantities list. So shear walls is probably the easiest thing you'll ever have to determine. And the length of the height of the wall is usually the height of the building, right, or above. So you'll check the section views, and there should be a detail. It should give you a detail there. It should be a detail sheet to tell you the configuration, even more of an elevation view of the shear walls. Okay, so that is the shear wall plan. Very simple, very easy additional framing that goes over your load-bearing walls to strengthen them, to prevent the building from collapsing due to wind and earthquake shears. So if you need any additional help, please feel free to sign up at our website at www.s as in Sam, F as in Frank, Johnson Consulting.com, where we will set up online office hours for you to help you a little more if you do need it. But once again, thanks for joining, and I will see you at the next class.
Hello, this is Stacy with SF Johnson Consulting and Construction Services. And I just wanted to review or go over a short review for our Scooters Coffee Store 1116. What we will review on the civil in the civil set. The civil set, of course, is everything that is when you walk out of a building. The civil set is comprises everything we see when we look around. So it's all of the concrete, asphalt driveways, public lights, the lights that we see outside, the landscape that we see, everything underground. So all of the utilities that we don't see. And so we're going to review for the scooters just a few of the sheets comprised within the set for the basics class. And we will review the demolition plan, the utility plan, the grading and drainage plan, the paving plan, the erosion control plan, and the landscape plan. Those are, of course, the most important. Everything else are details. And as you can see in a civil set, the sheets comprised within the set are nothing compared to the sheets that would be comprised within an architectural set because there's so many more scopes of work involved. So again, this is our introduction to our Scooters Coffee. We're going to do the civil set review and just a few of those sheets. For this class or any other class, please visit our website at S as in Sam, F as in Frank, Johnson Consulting.com. And I will see you soon. Hello, everybody, and this is Stacy with SF Johnson Consulting and Construction Services. And this is a part of a few programs that we cover But in this short video, we're going to be going over the ins and outs of a demolition plan on in a civil set. And we know that the civil set is all of the new construction or any construction that goes on outside the building, right? So civil is like the civil is what we share amongst each other. So when you think about the civil set, you're thinking about all of the lighting, the power, the concrete, the asphalt that we share outside of a building. So when you walk outside, everything in the civil set is what you see. Now, this is the demolition plan for it was some existing that's here for the Scooters Coffee that we're going to be building from the ground up. And so, one part of the site demolition is to remove certain items on the site. And so, we're just going to go over quickly what this is to aid all of our students, in addition to the online class that we take a little slower. But you know, when you're looking at any of the plans, and we went over the different views, right? So you have the different views. You have the plan view, you have the section view, you have a detailed view, and you have an elevation view. Well, on a site plan, there probably is no elevation view. It may be, it depends. But we're definitely on every set, you're going to have a plan view, right? Which is the view from above. It's a view as if you are hovering over, flying over the site. This is what you would see. And so in our demo plan, you always want to review, first of all, good estimators always going to review the specifications for the existing condition portion in the spec. So that would be your division 010000, and it would give you all the details about the demolition. And then you'd go here after taking notes from reading the specifications and just take a real look at, and you got to know what your symbols are, right? So you're always going to look for, where are my symbols? You know, is it on this sheet? And on a site plan, you know, for this in particular, you know, we don't need a lot of symbols. So our legend is some of our terms. That means, oh, this is the work that has to be done. So we're going to look for these symbols to do our measurements, basically, right? Because we have a set of construction documents to what? Put the scale right, make sure what we got going on. We got a lot of stuff going on here. We got a lot going on outside. So we always want to make sure we're to scale. We know what the scale is. We set the scale, and then we take this sheet and we do our measurements. Okay, so for our demo plan, we just want to make sure we know what we're doing. And so for the site plans, the good thing, or maybe the bad thing about the site plans, is that they write pretty much everything you need to do on the plan itself. And so you want to take a look at the key notes just to see what they're, what they're pointing to, what they're talking about. So a circle, we're looking for the circle in the one, pavement stripping. And so we know that we're going to have to strip some of the pavement. So that's easy. And then existing concrete, we're going to have to saw cut some of the stuff. So let's see the general notes. And this is a really simple demo plan. So all saw cuts, and we know the symbol. This is the symbol of a saw cut. So I know I'm going to be looking for this symbol. Okay, I'm going to be looking for that. And that's just telling me what the existing concrete looks like. It always looks like that. Or drywall sometimes looks like that. Okay, so, you got to read between the lines as to what you got to do. Here's all the existing stuff. So if it's existing, we don't really have to bother with it. It's just telling us that it's there, right? And so we know with all of these ones, we're going to be taking off the striping, and this is parking lot striping, it looks like, in an area. So we'll be measuring that, because when we price that, we measure by well, you can measure by square feet, but that really doesn't make sense if you can measure by linear foot of removal of the striping, which we can, and which we would. So we would measure how many linear feet of the striping, and because the plans are to scale, right, it's supposed to be exact. We shouldn't have to guess. If the plans are to scale and we have a proper measuring tool, then we'll be able to measure everything we need to, all the striping that needs to come off. Now what this is, remember, this is a symbol for us to remove or cut the concrete. So I'm thinking, okay, Are we just cutting like this length by that width, which is fine? Okay, and it doesn't really say. It has something pointing to it, but it doesn't really tell us what to do. Where this definitely, right? This is a saw cut, so this is telling me I'm cutting out this whole area of concrete. And plus, it's going to tell me too, because on a site plan, it tells you exactly what you need to do, gives us some information on the easement, right? Terminology is the distance from the edge of the property that we're working on. So, like in commercial property, there's an easement between like the street itself and the sidewalk, or the sidewalk and where the commercial property's driveway begins, to where that belongs to the city. So you don't mess with it, or you have to ask permission, or something like that. So that's basically the definition of that. So this basically, in for the demolition plan, we're just demoing this whole area of concrete. And it says, take the striping off. But if I'm going to demo the concrete, there's no need to add additional cost for that, because it's going anyway. And so when we demo concrete like this, we have to saw cut it first. So we have two costs pretty much, along with the removal. This would be a good demo. Ooh, this would be a nice demo because of the weight of the concrete and the amount of the concrete that we're going to be demoing is beautiful. Very beautiful. All right. So first step is we have to measure how many linear feet. We have to saw cut it out and then start to boom, just demo it out. So we'd have that by, we know the thickness. Now, a cost book will give you, because we have concrete, right? There's three dimensions: the length, the width, the height, or how many cubic yards of concrete. Concrete's always measured by cubic yards because there is a depth. And the third cubic, three, right? So we have to incorporate the depth of the concrete. And so we'll have some amount. And because we can do this area very easily, right? We can do that area, we'll just multiply it by the third dimension, which would be the depth. And it's probably, I don't know, who knows, 8 inches. But there's something, right? We have a section view of this, so it will tell us the thickness, so we know what the thickness is, because that does have a lot to do with the cost of removal of the concrete and saw cutting it, right? We have to saw cut it a certain thickness. That thickness, it makes a difference whether it's a 4-inch thickness or a foot thickness, the cost of saw cutting that. And so just know, when you remove concrete, asphalt, whatever, two costs: one, the perimeter of the area as it is diagrammed here, so we know exactly how many linear feet, and then we have to start to tear that out and pull it out. Then we transfer it to a truck, and then we have to dispose of it at the proper disposal location. So all of those are costs. So demo for this nice little scooters, it's going to be rebuilt on this land, but first they're going to dig out the concrete, get rid of it, and we're going to start from, and this is a nice little location somewhere in Texas. So yes, this is part one, oh man, of all of the sheets that we're going to review. But this first one is the demolition site demo. First thing we'll discuss in the civil set. And so I'll ask you things like, in the interactive video for your quiz, what if this was whatever it is, because I'll measure, and you'll have to measure. And if you're not taking an estimating class, I already give you the thickness. No, or I'll give you the thickness. No, I'll probably give you the area, and the thickness. And I do stuff like asking you how many cubic yards, give you a cost book, let you determine what the cost of it is to cut it out and to remove it and to haul it, things like that. Because, if you're learning about site work, those are all of the things that are incorporated. It's really the only thing you have to do. And then also we'll go over the stripping of the thing here. So this is a really nice demo project for the site, for this coffee joint that's going up. And if you have any questions, please contact me directly. And this is your favorite teacher, Stacy, and always can be reached at S as in Sam, F as in Frank, Johnson Consulting.com. And I will see you next time, where we will talk about, what we're going to talk about. Oh, the utility plan. So now we've got the concrete out, right? So now we're going to excavate, trench, and backfill so we can lay in all of the new sewage pipe and all of the new stuff for our new building, basically. So, same thing if you were building a new home, but you wouldn't have to remove concrete, probably be all dirt. But this is a nice example. We building anything from the ground up. Just imagine your dream home. We go step by step by step, show you what you need to do. So thanks a lot, and I'll see you in the next class. Hello, this is Stacy with SF Johnson Consulting and Construction Services, and thank you for joining me for this short video, hopefully short, not quite short, on grading and drainage for our Scooters Coffee. And I'm very sad because determining our grading totals, our cutting and filling and taking off site if necessary totals, it's very difficult if we don't have a way to determine the depth of the land, pretty much. And in this set, I looked all through this set, and it does not give us profile views, meaning it's as if we would have taken the land and cut it down uh, various locations, like section views. Maybe one here, then one all the way across. Um, maybe one diagonally, so we can get a good idea of the existing condition of the land as opposed to, or juxtaposed to, I like that they use that. Let me move this over a little bit. The analness of me won't allow this to be crooked, so let's fix that real quick. All right. So yeah, this set doesn't give us what we need. Okay, so when you do an excavation, which is basically what this plan is, it's asking us to level off the earth so we can build a level driveway, parking lot, have the land level for our walkway, for our foundation, most importantly, for our drive-through, stuff like that, right? And we got the land as is, and I believe from the site plan, if you review the site demo plan, we demoed quite a large area, probably this whole area of concrete, or a nice portion of it. And so at that point, we had to go in and level it off. We had to, if there was concrete already there, then good shot that it's, nothing underneath. We have to dig out. We do have to do our excavation for our underground utilities, as we just went over. Maybe not you just saw it, but that was before this one. And so there are, those things we have to think about. But what this plan is showing us, the grading plan, and see, it's a grading plan. It's not an excavation plan, right? They don't say excavation, because when we excavate, we pull out large amount of dirt and underground stuff. I mean, we have to do that too for our underground utilities, and it really depends on the savviness of whoever puts the plans together. This could have actually been called an excavation plan. Oh, who knows? I don't know. But what we're looking at is what's important. And so when we're looking at the grading plan, what do we need to know? We need to know the existing elevation of the dirt, how it is existing, how it's laying before we need to move it, and then we need to know where we want it to be when we move it. Okay, so basically that's that's what we're talking about when we're talking about grading. What's the existing condition, and then what's the proposed? Where do we want it to be? And so when you're looking from a plan view perspective, it's very hard to determine how much dirt you got to move, to tell you the truth. Okay, so let me just show you what they do give us when we look at this. So these percentages are percentage of angle, as it like we're pitching a roof, right? We want it to angle, right? We want parking lots and driveways to have a angle to them so water will go or flow in a low in a particular direction, right, towards the drainage, so it just won't puddle up or whatever. So that is that's the numbers, the percentage numbers that they're showing us here is when we lay this curb, pretty much. Okay, top of curb, top of the point. So this is a curve, and what this is telling us is the top of the dirt is at this elevation. Everything's GPS. Every point on the earth has a number associated with it. And so the top of the curb needs to be at 508.65 GPS location, whatever that means. We don't care. We just want to know what it means. And then TP is where the ground is. That's the elevation of the ground. And then, of course, the top of the curb, right, is just a tad above that, a half an inch above that. So it's a half-inch curb. That makes sense. Or just a little less, 5 inches. Okay, so that's what we're looking at. That's what those boxes are. That's top of curb, top proposed, and that's the ground. I know. The percentages are like slope. We want it to slope a little, that curb to go. And it could also mean, now, if this is our paving plan, we would think that meant the radius. It might still be the radius, but when it's a grading and drainage, right? Drainage means we're sloping the ground so we can drain the water in a particular location in a way. And it's always the way of the arrow. Okay, so this concrete, whatever this is from our paving plan, when we're dropping the concrete, we want it to angle a little 5% angle this way, so because we must have some drainage stuff going on over here. Okay, so that's what you're looking at, and you know that all of the darker is all new construction, and so that, I mean, excavation, grading, it's telling, and this is fine grading because I believe, if I recall from the site plan, we didn't have to dig. We just had to uplift a whole bunch of big, huge 10,000 square feet of concrete. Had to be demoed, and then we're laying this. We lifted that up, then we went and laid the underground utilities, and then we did. Now we're doing the grading plan, right? We're grading it all nice, and then we are going to do the paving plan, where we're going to drop all the concrete, asphalt, striping, all that stuff. And now, how they represent, again, the heights and depths of the dirt prior to and after you move it. It's usually existing condition is gray. What we want is black. Everything here is black. They don't give you very much existing condition indication other than these dotted lines right here. Those are contour lines, and it's supposed to say how, yeah, there we go. The contour lines tell you what the height or what that particular GPS location of the dirt along this whole range, along this whole, so from here until we get to the next one, it's basically supposed to tell you between here and there, it's a foot of dirt, the difference in height, right? That's why you can't really do a cut and fill, because here you got to follow those lines, but then here we want it to be the top of this, the dirt, we need it to be a 58.18 plus or minus. Well, we have it at 507, so do we have to cut any? Nah, I don't know. 0.06 dirt, we got to add any? Is that 507 even right here? See, that's why you can't really do this. You go nuts, and I did a long time ago. Took a week. But you know what? Anything that doesn't kill you makes you stronger, and it made me really want to learn how to do cut and fill totals because it's very important. And then thank God, by the grace of God, engineers came up with the profile views, which we'll have in the actual class. We'll go over actual profile views so you can see how this sucks, and you could never be accurate with this ever. But this is our grading and drainage plan. And really, you just want to make sure you recognize what these things mean. It's the top, it's the elevation, GPS locations of the curb, and the dirt is the TP location. And then proposed 4-inch stem through curb, because we got something going through the curb, some kind of pipe going through the curb. So this is a curb. These are curbs, as you can tell. But we know it's a curb from I mean, we can look and see right here that it's a curb because we know what curbs look like. But this will be more detailed, the size and whatever of the curb, the radius of the curb, all of that on the paving plan, which is next. So, any questions about this? This is, again, to go with the detailed class that we have on the civil set. If you have any questions, please contact me directly at our website, which is S as in Sam, F as in Frank, JohnsonConsulting.com. This is Stacy again, and I will talk to you soon. Until next time. Hello again, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services. And this short, hopefully, video is all about paving. This is our scooters site plan, our restaurant, and we're still in the civil set. And we are going to go over the paving plan. And so, of course, what do you think about when you think about paving? Asphalt, concrete, curbs, gutters, all of the footings, okay, that all of the poles have to be in. The concrete person has to be mindful of those. So really, it's just a layout of all of that, showing our building envelope, telling us what? That the building is 664 square feet. That's the elevation, because of course it's supposed to be flat, right? So that's the elevation of the foundation. And here is all of the things that we have to do on our paving plan. So, of course, we're going to have a legend or keynotes or something like that to tell us exactly what to do, right? And so everything here that you see numbered, of course, is going to be reflected on the plan. And so when I'm doing a takeoff, because eventually everything's going to get colored in, right? Everything eventually, because you're going to do areas, right? And for concrete, of course, concrete is bought in the cubic yard, or you determine by cubic yard. But you do the area first, and then you look at your section views. All of your site details will tell you the thickness of the driveway, of this area, of whatever that is. It'll tell you, and so you'll have your third dimension. And so you can multiply that area by that third dimension, which you would turn into feet, right? And so if it's half-inch concrete, it would be times your area times 0.5, right? And then that would be cubic feet, and then you change cubic feet into cubic yards, and then you'd have the amount of concrete you need. Okay, so that's for the site concrete. If there's rebar involved, then it's going to show that in the section view of the concrete drywall, I'm mixing drywall and driveway, section views, and your curbs and everything. So all we have to do is go number by number, piece by piece. And again, because we're going to eventually color in all of everything here, that's how our takeoff software does. As we color in an area, it'll color it in. So I usually start with the lines first, which would be, this is the apron of the driveway. And so you have a separate price for driveway aprons. So I would measure both of these, the area of each of those. I get that separately, like from about right here. And then I'm going to look at the symbols and see what these dark lines mean. And here's our symbols. Those are our keynotes. Here's our symbols. So our 5-inch light duty concrete pavement looks like that. Little dots. Okay. And so we can go ahead and do our area. And then we know our third dimension, right, is inches, 5-inch, 6-inch. Okay. And then this is the concrete pavement connection. Okay, so we have to do a couple of things on this one. So we have the 2-inch saw cut, Okay, we would have had to probably do that in the demo plan. If not, we'd have to go back and check because we wouldn't want it in this plan because saw cutting, we wouldn't want it in this plan, cost for it in this estimate and also in the demo estimate. So we have to go back and make sure we haven't already accounted for that saw cut, which we probably did because we had to eliminate a lot of concrete when we had to do the demo plan. Okay, and so let's see what else it says. Saw cut, curb removal, dowel into existing pavement. Okay, so a couple things here. We need to know what the size is. So again, we have our concrete details in our civil details. Okay, I'm gonna switch to that real quick. So here, some things here to look at when we're looking at our. Let's pick one. The monolithic 6-inch concrete curb. Okay, so it's going to give us some information about the rebar and the radius of the curb and everything about it. So if you have a good cost book, they've been making these curbs forever, so they know pretty much what the standard rebar calculation should be, da 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 da. And so a good cost book will give you an assembly price, right? Assembly price would include the form work, the rebar, and the concrete setting and all that, curing and finishing and all of that. Okay, so good cost book, you might be able to find that with it already in it. But if not, you can do a takeoff on your own. This would be the curb takeoff. This would be the probably the driveway or the sidewalk or whatever it is take off. So you would separate the two and do the rebar for each one. And so what this would tell us if we looked at it, right here, hairpins at the 18-inch off center, number 4 bars with 10-inch bar laps. Looks like we have 3 or 2 if you include that one, but you don't want to count it twice. And so what's that mean at the 18-inch? So if we have 300 feet of this curb or whatever after we've done the takeoff, right, we change that 300 feet into inches by multiplying by 12, then divide by 18 because you're putting them every 18-inch off center or on center, however you want to say it. Meaning you have however many, so you divide, right? You divide that, well, however many inches, divide by 18. That's the number of locations that you'll have to put that. And so you'll know how many of these you need for that. Same thing with the rebar. If you know you have 300 feet of curb, then that's 300 times 3. You do it that way. Because this is into your flat, so you can account for that in there, but don't count it twice. Okay, so section view tell you all your information about this is our concrete sidewalk, so it's going to tell us all about that. Joint fillers, expansion joints at the 25 feet minimum, field width, and all that's going to be in the specifications, but it's good it's here because an estimator doesn't want to go through. If you're trying to, win a lot, you're going to do a lot of these, right? So you don't want to have to read through every little detail because, again, if they like your number, they're going to call you, give you opportunity to fix it, change stuff, get in there more detail, and then if they still like it, then it's a go. But you don't want to cheat yourself. But, too, you don't want to put so much into every estimate like that because you want to bid 20, 30 until you really start to win. The more you bid, the more you're going to win. It's just math. It's just how it works. And I've had clients that went on the first try and it's like $1 million project. I'm like, everything must have been in the line for that person, and I just came in and did what I do best, help people win. Okay, so our paving is fun. I mean, it's easy. Paving plan, we just have to go through and, go by the keynotes. What's 19? What's 9? What's 18? Da 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 da. Let's look at 18 real quick. A bollard. right? Those things stuck in the ground keep you from running into the building. Poles a little short, 3 feet maybe. I don't know. I'm only 5'2.5", so it may be 3 feet. It's almost. You know what I mean? So that is those. So everywhere you have an 18, you're going to count. Then you're going to go to your details because somewhere in your civil details it's going to tell you about the configuration of the bollard, the length, what it's made out of, the footing, da 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 da. Okay, all the way through. Okay, and so I mean it's easy. So what are we looking at again? This is the paving plan. So this is all new concrete driveway, and here they said this is where we're going to connect, right? And we have to put the dowels, and so it tells us to put a dowel again. Civil details going to tell us how many inches apart, how many feet apart we need to connect the new concrete to the existing. That's usually in every case. No matter when you're putting concrete, you're always going to connect the new to the existing. So that's what that is. Curbs, driveway. You don't worry about the foundation on a civil plan because that's in the structural set. Okay, so you don't worry about the foundation at all. It's just showing you the building envelope, but everything outside the building. All right, so that is it for paving. If you have any questions, contact me directly through the website, which is S as in Sam, F as in Frank, johnsonconsulting.com. And remember, this is to accompany our online class that we have during the week. So if you need any additional information, this should cover all the questions that we go over. Remember to always scale, look at your keynotes, and always go from one end of the plans all the way around to the other. Thanks for joining me. And again, always, let's see each other at the next class. See you soon. Hello, and thank you for joining me. This is Stacy, and this is another review of one of the sheets in our Scooters Coffee site plan review. And in this review, we're going to have a review of the utility plan. And remember, this is to accompany our class instructions. So if you need any kind of review, you can go back here and listen as many times as you need to. And so what's our utility plan? Remember, our civil set is everything that we see outside when we walk outside the door. And so our utility plan shows us all of the water, sewer, electrical, gas pipe that will be run to the building, connected to the public system, to the building. And it shows, where it's going to be, how it's laid, and some information that becomes important when we talk about the elevations of the pipe, where because the pipe is down in the earth, right? So we talk about the elevation of the portions of the pipe that are important, so the contractor knows how to lay the pipe. And so of course we do a full review before we even try to tackle any takeoff. We're gonna scale it, make sure our takeoff software is to scale. And so what this is telling us, right, we set it for every 1 inch is actually 10 feet actually. So we got to make sure we set that when we are setting our scale, and that's what we'll do now. 1 equals 10. And so yeah, we agree. So when we make our measurements, it's the same as making those measurements we're going to need in order to put together our professional estimate. So we're going to look through some stuff. We're going to make sure we know what all the symbols are. So SS, sanitary sewer. WL, water line. Storm sewer has this. This is the symbol for it. Proposed storm sewer. Now that looks like electrical to me. Okay, and so that's most likely electrical, and that's a typo, right? And all of the existing utilities will be more gray, and all of the new construction would be in a black or darker. And I'm almost certain we're talking about the electrical because they did repeat that twice. And you're always gonna find mistakes on plans. Okay, if you're looking at 10 sets of plans, probably about you'll find mistakes on half of them. one mistake or another. But common sense will tell you, and you'll know what it's trying to show you, and you'll figure it out after doing a lot. And if you're confused, make sure you ask the general contractor and point it out, because it shows that you're doing a good job and you're paying attention. All right, so here's our site. So we just got to look in there. We took a look at everything. We know pretty much what everything is. We look at the general notes because our plan view, right, is the view from above. So it's going to show us as if we're looking down, right? But these pipes also go into a certain portion of depth into the earth, right? And so when we're looking at our grading and drainage plan, that's going to show us how far down into the earth. Really, it'll give us a better indication of where exactly the pipe is going to be. But for the purpose of this utility plan, we're simply trying to get all of our measurements of all of the piping, how many linear feet, how many 90-degree angles, how many whatever it's telling us, manholes, whatever, to get those measurements. Now, as far as determining, the backfill numbers or the trenching numbers, and you got to think the trenching numbers, meaning how many linear feet of trench. You have to look, and when you see how they're going to lay the pipe, and this tells you how they're going to lay the pipe, right? And so the trenches will be adjacent to each other, and then you'll look at section views. So it gets so complicated when you do underground utilities, right? Because there's so many that run underground, and so you have to make sure you look at all of our detailed views, so we can see is, usually the sewer pipe would be the lowest in elevation, and then there's some, the water pipe would lay above, or the gas pipe, and they would have a certain distance apart, or certain pipes could not lay above each other, or they have to be anchored. There's so much involved when you talk about underground utilities. And so usually those estimates are time consuming because, yes, how much dirt to move, try figure go outside in your backyard right now and try to figure out how much dirt you're going to move. If I tell you to dig a hole, it's like, okay, accurately determine how much dirt that is, that's very difficult. But if you have a good set of construction documents, when we go over the grading and fine grading and the trenching and the drainage plan, that's going to give us views of wonder, okay? Because when I first started this, you had to pretty much, from a plan view, determine how much dirt you're going to move. And when we talk about moving dirt, it's cutting and filling, right? We cut, meaning we're taking it out, we fill, we put it in. There's no way on God's green earth, from a plan view, from this view right here, because there's the third dimension, right? There is the depth of the dirt, and so all it would give us is elevation numbers. Oh, it would just be crazy. But now, within maybe the past 6, 7, maybe more years, they start to give you profile views where you can see, it's scaled. And when we go over the drainage and grading plan, it's scaled. You can determine the area, and then you can look at it and determine the depth, right? So that's cubic. So you can determine pretty easy that way how many cubic feet of dirt you have to move, because you want to be as accurate as possible for your excavation estimate. Okay, but this is underground utility. So we're assuming we already excavated, right? And now we're concerned with trenching because we put these pipes in trenches. And so it just tells us where everything is, what we have. And the good thing about, again, the civil set, it tells you exactly what you're doing. It points to it. So I know that this is a PROP, proposed grease trap, and that's it right there. The E, of course, that's electrical. And so if I'm the electrician, if I'm the electrician, my electrical work is going to be in two places. It's going to be here on the site plan, in the utility plan, because if it's outside electrical, it is by definition an underground utility, but it will also be on the site electrical plan, just in case something's missing. And when I do an electrical estimate, I always go by the site electrical plan unless something's missing. Say, for instance, uh, we don't know where the transformer is. Okay, if we don't know where the transformer is, we may go ahead and look on the site utility plan because it's going to show us. Okay, so as far as now, who needs this plan? Yeah, if I'm doing the underground utilities, I need this plan because I need to determine how many linear feet of water pipe, electrical conduit, everything underground is PVC, and or it could be copper if we're talking about the water system. So, that's something to consider. Okay. And really, all we're doing is making linears. And if we have a manhole proposed, okay, pole mounted transformer. So, yeah. So, this is our secondary where it's coming from the city, coming from the city, coming from somewhere, enters here. And this is where we take it into our building. And so it ease our electrical. So, we're going to do all of that. Looks like we have the pole electrical, and this may be maybe a transformer or something. It's not pinpointing exactly. It's not telling us what it is, but it will tell us on the electrical plan. The water line, domestic water, DOM water line, 1.5 inches. Okay, so this is all we're looking at. And then, you just have to go to the specifications, right? Because the specifications will tell you what type of water line. Are we using copper? Are we using PVC? Is it coated with concrete? Da 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 for the electrical, for the telephone, for whatever. Okay. And these are meters: DOM, domestic water meter, irrigation, IRR, the irrigation meter is telling you it's right here. And so if I'm doing the takeoff, I'm going to count how many meters, and then it's important to have the size pipe, right? When you're determining the meters. It's like, you have a 2 inch, 3 inch, 4 inch, 3/4, whatever. They come in all sizes. So you want to note that when you're counting. And then, that's pretty basic for a site utility plan. This is a very simple one. Again, it's a coffee shop. What's coming to it? Water, gas, sewer, nothing too intricate. Just one or two lines coming in. Real easy. Read through everything. Make sure you do everything is to scale. And usually when your plans are this clear, when you're having you have your takeoff software and your plans are so clear, it usually means your plans are to scale. I had a set just today where I pan in like this and it's fuzzy. You can barely read that. Well, they're not to scale. And then you just do a little test. And one good way to test if you don't have a scale on a plan and you're trying to guess what it is, a doorway, a typical doorway, if you have a doorway, okay? In this case, you probably don't. We probably don't have a doorway, but most times you do. If you have a doorway is about what, 3.5 inches, 3 feet 2 inches, 3 feet 6 inches. So if you can measure that length, okay, then you pretty much can determine what your scale is and go from there. And just let the GC know. No scale, we've assumed it to be 1 inch equals 30 feet, whatever. Okay, so one last thing I want to go over are these numbers when it tells us, let's go over the grease trap. Okay, so basically the grease trap has two inputs, two things coming, and you can see right here, one thing coming in and one going out. Okay, so basically these, looks like we have three things coming out. Oh, that's coming out of here. 3 points coming out of here. So what these mean right here, okay, these right here, this will tell you, this is the, if you want to think GPS location of the underground utility, because everything is set by the government standard. That's how we got GPS, right? We know every physical point on Earth has a number associated with it, right? And so these are those numbers. The computer will tell us exactly the location associated with that number, so we'll know exactly where the 4-inch pipe and the 6-inch pipe, they have to be precisely in the right location, right? We have to place this, whatever this is, sample well. That's what that is. Okay, we have to place it in the proper location. And so, in order to do it, so we can have our pipes going in it and out of it, at, so we line it up right. Basically, that's what we're doing. Got to line it up, right? Everybody's seen that. I think on Facebook where they're building the bridge over the water, and then when they meet, they don't line up. Well, these numbers help us line up all of the pipe or the fittings or whatever that are coming in and going out of the piece of equipment. Under the grease trap, these numbers are important. That's what's coming in and coming out. The sample well, that number is important because something's coming in. One point is coming in, okay, and then going out. I'd have to look and see exactly, but that's what these numbers are referencing. That Y, which is this little break right there. That's the size of it. It's telling us a 4-inch by 6-inch, 6-inch by 4-inch, and it is located at the 6-inch pipe, and a 4-inch pipe is going in and going out, and that's the location. Not that it means anything when you're doing your takeoff or your estimate, but it's good to know, right? When you're reading it, what it means, right? Because you want to know what you're doing. So again, this is a coffee shop, right? So plan view from above. Here's the building. Here's the drive-through, right? We got some order menu boards, and see, we have a grease trap underneath, like a Popeyes, like a everything, where they have a system within the building, right, that pumps all that grease out into this trap, and at 3 in the morning, some big truck comes and takes it out, right? Takes it away when it's full, that kind of stuff. So underground utilities, putting in all the water, all the irrigation. See, here's the irrigation line, right? Irrigation is how we're going to water all the plants and trees and all that good stuff. And so, what is this? Necessary. What is that? That's a water pump. Proposed open cut as necessary for installation of proposed water taps. Yeah, okay. That's what we're going to tap into the city water, right? Right here. So you got a cost for breaking the concrete, right? Got to cut around, pull out. Cost for that. Cost for tapping into the county line or stopping it, or there's a cost for making sure everything works while you're working on it, or all the costs of stopping people from running you over. You got to think about all that. That's in a whole separate plan, right? Flagging and all that stuff. That's in a whole separate plan. This is underground utilities. It's not concrete. It's not demo. It's not, because in the demo plan that we already reviewed, we probably already had to cut that out, or showed us we had to cut that out, or maybe not, I don't know. But we know we got to cut that out to get into the concrete asphalt. And so there's a section view somewhere showing us the thickness, because we got to put it back once we tap into it, right? All that's a cost. Then running the pipe is a cost. Install everything is a cost. So you want to make sure when you're doing your estimate, line item, everything's a cost. And if you have a good cost book, it will give you the material cost, the time in man-hour units, really, which is wonderful. That's why my clients win, right? Because we don't go by, we've been doing it for 20 years kind of stuff. I say, yeah, I've been doing this for 13 years, but I've been going by the book for 13 years, right? Not just, taking a look at it, that's $1,300. You probably beat yourself out more than a little bit and all the time. But if you go by industry standards, nerdy standards, get the right measurements. If anybody's out there still, we use a wheel, throw that away. Stuff for free now works better than that, because you spend a lot of time. And that's how I've been successful. I understand, because I do it and I teach people to do it. We spend a lot of time trying to win. We don't just throw numbers out there. We try to be precise, accurate, have everything accounted for. Because if you do win, guess what? You're going to have to go by that number, or, what really happens, right? Because, and just stuff I've noticed, over the years, right? You have to present an estimate without having a site visit, always. But if you look in the details of all of the sets of plans, it always says don't present an estimate without a site visit. But they're like, yeah, yeah, we'll worry about that later. And so they make 10,000 people submit the bid, right? They go with the 5 or 3 or 4 that are the cheapest, not the best, but the least. Look through it, make sure everything's on there, and then talk to you about it, and then have you come out, have a conversation. Then maybe if there's something to look at, you look at it then. That's why you want to make sure you don't put more on the estimate than what's on the plans, and you make sure you don't guess. And if there's something there, you account for it. You let them know that you're accounting for it. If there's something that, like for us, electricians don't trench and backfill. That they may need it, right? They need it for their scope of work, but when you look at electrical, you won't see trenching and backfilling because that's not an electrical scope of work. So yeah, if you are an electrician, you gotta, trench out your whatever, or a plumber, whatever. You have to have separate estimates. One for your scope of work, one for the backfill or the excavation scope of work. If you're an HVAC person, you have one for the HVAC and then one for the refrigeration, or if there's plumbing, they're separate. A good estimator is going to make everything just like in the specifications. Everything should be separate. It could be in the same estimate, but totally separate totals. That way, that's the way they know you know what you're doing, and it's very clear, and nobody has to make 5,000 calls to you to make sure everything is included on your estimate. And so, underground utilities, everything underground, really simple. You just have to have something to make very accurate measurements, and piece by piece by piece, you're going to put everything together. Everything's underground. You want to make sure everything is to scale correctly, and you want to do a whole circle. Start here, read, make sure you're touching on every point. Make sure there is a way to, and there is, right? If this scale says this for every 1 inch is 10 feet, and I think we already said it, then when we make a measurement, right, from 0 to 5 should be 5 feet. That way I know before I start making my measurements that it's to scale, which it is. And then I know measurements are accurate. That way I can go to my good cost book, which is very accurate, and I'm putting together a very good bare bones estimate, a winning one. All right, so underground utilities teach you this every day of the week if you need help putting the estimates together. That's the second and third step. But the first step is to know what you're looking at, mark down everything, have accurate measurements, and if there's something missing, note it. If there's something to exclude because it's not your scope of work, note that as well. And if you need any help, please visit me at the website S as in Sam, F as in Frank, Johnson Consulting.com. And please join me next time. What are we doing next? Some exciting paving plan. Oh, that's fun, right? We're dropping the concrete, we're dropping the asphalt, we're dropping the curbs and gutters. We got some footings going for some signs. We're awesome. Talk to you soon. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and in this class, we are going to review the Scooters Coffee Landscape Plan. And as we know, the landscape plan is part of the civil set, and this is maybe 5 or 6 that we've reviewed, and it is in conjunction with our class, our basic plan reading class. And so what is a landscape plan? Landscape plan tells us where all of the shrubs and trees and plants and grasses are going to be placed, and also if there's decorative walk paths or something of that nature, it's going to show us that as well. And so again, from the plan view, we're going to see everything that's there. As always, we want to look at the scale, make sure the plans are to scale because we're going to make measurements. And then we just want to see from the legend of different types of plants and shrubs and trees what we'll be looking for. So typically what a landscape plan will give you is the plan view, showing you where everything is so you can make the counts and make the measurements. But then you'll also have a detail view to show you more detail about the how the tree is held up at first because they have to stake it and hold it up, how far into the ground it's going to be placed, a lot of different things about the placement of trees and shrubs. Looking through this set, the details don't have any of that information. So, I think this set was probably made on the fly, and so we would have to add a lot of additional information that's not actually shown on this set of plans. And so the good thing I like about the landscape plan is that it will give you the actual names of the different plants, what we call them here in the regular world, but then what the botanical name for each of the plants too. And then it will give you the size, and it's 1 gallon, 5 gallon, 3 gallon, and then here are the shrubs and all of the names, and then the botanical names as well. And then you just look on the plan, figure out where everything goes. Here for the buffalo grass, we would do first a square foot calculation, and then see the thickness of how thick they want it. We'd have to add some preparation of the soil, that kind of stuff. And so, very simple. Landscape plan shows you where all the trees and shrubs and grasses are located, and also the irrigation involved. There should also be a separate irrigation plan. But as you can see, there's a lot of things here that they say will be supplied by the owner at another time, at a later time. And so, really simple. This is again a small little coffee shop, so it's not a lot of landscape around it. A couple trees, some grasses just to make it look pretty, some shrubs, and so you would count each one. Same thing. And then one thing I found interesting about landscape contractors, for the pricing of the tree, they usually price it 2 to 3 times their cost, because in the event that it dies, then they don't want to go out of pocket to replace it. And also they have to provide maintenance programs for up to 3 to 6 months depending on the contract, to make sure they come and feed it and water it, make sure it's watered correctly, and make sure everything is structurally sound, so it's standing up and the way that it should. So that was interesting as far as the landscaper is concerned. But again, we should also have a irrigation plan that's not here, and the irrigation plan would just show us all of all the locations where all of the sprinkler heads are, and the piping that reaches to each of them, and all of that. So again, this is Stacy with SF Johnson Consulting and Construction Services. Just a small review of a small landscape plan. If you have additional questions or problems or concerns, please visit our website, which is S as in Sam, F as in Frank, johnsonconsulting.com, and we will see you at the next class. Bye for now. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and in this class we are going to discuss the erosion control plan. And what is erosion control? Well, when we have a new construction site, we want to make sure, well, in a general sense, erosion is the slowly decay of the land. It slowly decays because when we bother it, meaning when we move it, when we build stuff, we're messing with, I guess you can say, its natural way it wants to be. And so because we do that, we have to implement ways in order to maintain the natural landscape and the natural flows of water and the natural way things would go if we wouldn't have disturbed the land. But in construction, an erosion control plan is implemented to close off the area and to make sure when we're digging or when we're placing down concrete and all the waste that comes from that is maintained within the site. And so there are different measures that we put in place in order to maintain that control. And so, of course, with any of the sets of plans, we want to make sure we know what the scale is, and we set the proper scale so we can make the measurements. So in this case, for every 1 inch, it's 20 feet. And then some of the symbols that are involved. And this is a very simple erosion control plan. It shows us the stabilized construction entrance. In any new construction, you'll notice, or you should notice, or you will start to notice, that there is one entrance that all the trucks come in. They're not allowed to come through in every location because we want to mark off the construction site to, again, where everything that is performed is kept within a confined space. And so sheet C 6.3 is going to show us the detail about the construction entrance. And then we have a truck washout area. And then we have the fence, of course, the orange fence that closes in the area. And then this is very simple, a very simple plan. And so throughout the site, these are the symbols for the fence, and really simple. So in this case, we just be measuring how many linear feet of that fence do we have, and the washout area, which should be somewhere easy to find near the entrance. We would hope the washout area would be where. Let's see. That doesn't make sense. Washout area. Okay, let's see. Always look here. Okay, we're looking for that. Okay, so that would just be right here. Okay. So that's the main entrance. That's where it would be. And let's go to some of the details. All right, so here's the washout area. And so, you see, let's go back to the actual plan, because if you see how this is made, right, you see how that seems pretty simple. 15 feet by 35 feet. And let's go back to the plan. Okay, is that 15 feet by 35 feet? So, is that? Yes, it is. Okay, because when you're an estimator, you're supposed to be extremely anal. Okay, and so that symbol, that line up there, looks nothing like the detail plan. And so what I'd have to do is kind of try to make sense out of that, because, I would just say forget what it shows on the plan and go by this, because I know it has to be, because we have to determine how much rock, right? We have to determine actual measurements. That block on the plan looks nothing like this. And so I would go with this as far as determining actual measurements and breaking all of this down and all of that. I would have to I'd have to do that. Okay. Cuz that's very tricky. That's ugly. And so those are the kind of things that you'll get when you see a set of plans. Yeah, we'll put a little box there, but it has nothing to do with the dimensions of this, what they're showing here. And so what do I go by? Do I measure the box on the plan, or do I go by this? Oh, you go by this. Because this is giving you actual measurements, and based on plans and specifications, sheet, what, C 6.4. Okay, so those are the kind of things that annoy me when I look at plans. And then all of this is all of the other information about all of the washout and everything else you need, barrel storage, how they want it, material handling for the site, how they want everything stored, and then the inlet barriers. That's important. Okay, but then again, let's see if we saw any IPB on the plan. Let's return. Inlet protection. Do we see that anywhere? No. Inlet protection. No. Yeah, see, not very good. Because I know there's some inlet somewhere, right, where the water goes down into the sewer system, and that's what you're supposed to be protecting. Okay. See where the concrete washout is. Let's see how bad these plans really are. Because the symbol should be there, right? It's supposed to be. Only thing they make clear is the fence, and this, which isn't to scale according to the details, and then the washout area, not a very good set of plans. So, but luckily, not a lot to do. Okay, so erosion control, we basically just try to keep all of the construction material within the site using the fence, using the washout area. They'll use fiber rolls, hay rolls sometimes to keep everything within a confined space. Okay, so and on a bigger site, in on most sites, you'll also find the porta potty on the erosion control plan. So that's just a little extra added bonus. But yeah, this is a very simple erosion control plan, not very detailed. A lot of the symbols and signs that are on the in the details are not on the plan. And so you'd have to make a lot of allowances, put in a lot of notes because there's a lot of missing stuff and you'll have to guess a lot of this stuff. And which is guessing is okay as long as you make an accurate, educated guess. So this is Stacy with SF Johnson Consulting and Construction Services. And we're going to go on to our last video for this class, which would be the landscape plan. If you have any questions, please visit our website at S as in Sam, F as in Frank, johnsonconsulting.com, and we will see you next time. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and in this short video, we are going to review the scooter's electrical plan, just in short review prior to doing the electrical estimate and the takeoff and putting everything together. All right, so what we're looking at right here is E0.01, which is the electrical site plan. And if we pan in really quickly, they give you kind of a quick overview of it. There's a drive-through, and this is typical of any drive-through, where they'll show you the menu loop, where you drive over it so they know you're there, and then the speaker and all of that. And then that is connected underground to the power of the building and to the service loop, service window, all that good stuff. So that's kind of like in a nutshell, showing you each of the electrical components for the site. And this is the electrical site plan in general. So here's the building, and then here is, and of course there's always keynotes, so you have to follow each of the keynotes to see where it tells you what it tells you what to do, junction boxes. And then when we get into the electrical power plan, this is how they tell you which of the panels, panel A, and what position on the panel that piece of equipment is directly connected to. And we know it's directly connected to because this arrow represents what's called a home run. And of course, when you hit a home run, right, you hit the ball and you go all the way around. Well, basically, an electrical home run is telling you to go directly from that junction box to that panel A, position 3, and then whatever 5 and 1 is telling us. We have to make sure we follow that too. And so all throughout an electrical plan, whether it's the lighting plan, site plan, power plan, you're going to have some power component, in this case, some exterior building lights that are directly connected to each other. Okay, and same thing for outlets in a room directly connected to each other. And at some point, it's going to be directly or home run to a particular panel and a position in that panel. So depending on, these are all commercial buildings. So, I mean, the smallest we have seen is a 10 position distribution panel, or you have 84 position panels. It really depends on what the power requirement is and what they're doing in the building. Okay, so this is the site plan, shows you the loops, all of the underground. Of course, it's going to be underground wiring, so they don't need to show it ... underground, which broken line indicates underground because, yeah, it's the site plan. We know by virtue of this being a site plan that this is all run underground. Okay, and to the building itself, and then there's some other things and parking lot lights. I don't see parking lot lights. That must be coming along later, whatever. So it's all the signs for the building directly connected to a panel at some position. Okay, junction box, waterproof. Okay, so that's the site plan, and the photoelectric plan shows you how the light is supposed to be distributed throughout the parking lot and all of that. But that's not really not for us as estimators. Some specifications. All right, now this is our panel. So we have a 84 position panel, and it really, when we get in a more detailed class, we can give the details of everything, but basically it's going to show every position on the panel and what is connected to the panel. And then if there is a breaker, the size of the breaker, 20 amp, one pole breaker, depending on the equipment, it's going to be a different size breaker. And so when we're doing an estimate, we have to make sure we count how many different types of breakers we have, and then the particular type of panel that we have. Okay, so this looks like we only have one panel for the scooters, but it's an 84 position panel, so it's a pretty big panel. And you should also be given what's called the single line diagram, which shows, and this is a single line diagram, which shows from the utility transformer, which is the power that comes from our city. It's the utility transformer. We have to bring that power into underground conduit and wire to the meter, to the building disconnect switch, and into the building to the panel. And it looks like they have a time clock that controls all the lighting and how the lights come on and off and all that stuff. So that's a single line diagram required in every electrical set to show you how the main power is coming into the building. You're always going to have a meter. You're always going to have a building main disconnect, and then directly connected to the panel, that 84 position panel, and a time clock. So it gives you more details about how the outlets in the boxes should be wired and positioned. And again, all that's going to be in the specifications. Some legal requirements, and now we get to the two plans for electrical sets. You're going to have two plans. So one plan is going to tell you about all the lights and how they're controlled. So it's going to be the lighting plan, and that's what we're looking at here. There's a lighting schedule telling you it's calling this one light A. This is what it is. Da da da. So when you have to go and order those, you know what you have to order. So all of these call outs and all of the symbols you'll see on the plan. And it's a small little establishment, so it's really what it has, 2, 4, 6, 8 lights, some junction boxes connecting them, the emergency lights as required, and then the conduit that connects the lights. And then those are the building lights we saw from the site plan. And then the good old home run. Okay, now some plans have it, some plans don't. On your lighting plan, it's only the lights and how they're controlled. So the light fixtures, junction boxes, occupancy switches, that dollar sign is always a sign of a switch. Electrical, you have a ton of symbols. And so as you work on these more and more, you'll get more familiar with all the symbols you have. All right, so what you won't see is the power panel on a lighting plan. And so you have to look at your power panel or your power plan, figure out where your panel is. So when you accurately measure your conduit length from your home runs, you'll know where you're measuring it to. Okay, so this is the lighting plan. It shows all the lights and how they're controlled. If this was like a larger place and we had like some rooms they wanted on while other rooms were off, it'd be a totally different configuration, and we have some videos of that as well. But this is a really small place. All the switch bank. Okay, so lights, that's one of the plans you'll get in the electrical set, and the other one is the power plan. So power plan's only going to show you where the panel is. So now if I go back to that lighting plan and I have to run all my home runs, I know I'm going to run it to right here. See, it's probably right here, but they don't point it out that that's the panel, because on the lighting plan, the job of the lighting plan is to show you just where the lights are and how they're controlled. Okay, dimmer switches, exit lights, but no call out of the power panel. So now I know if I have to connect this junction box to here, I'm going to go right there. I'm going to measure just that length plus some distance down directly to that panel at position 50. All right, so power plan is way more complicated than the lighting plan because the power plan's job is to show you where all of the outlets are located. Junction box is required to connect other pieces of equipment. Quad outlets meaning four, so that's an outlet that has four. That's an outlet that has two. Sometimes they have outlets that only have one, so it'd just be one line sticking up. But in an electrical power plan, the job is to show you every component that needs power, what position on the panel it's connected to, uh, what it is, and also it's going to also show you where the phone special receptacles and phones and data jacks are for electrical set. The high voltage electrician will always have to provide junction boxes and conduit for all phone, computer, all that stuff based on, the specifications. Okay, so the power plan's way more complicated than the lighting plan because its job, again, every outlet and what position on the panel it's connected to. Okay, all of the HVAC equipment, where it's connected, disconnect switches. That's going to be somewhere we need to know the value of those because large equipment always has a disconnect switch, so we'll cut it off before it burns the building down. So large pieces of equipment always have a disconnect switch connected to it, where all of the outlets, its main means of disconnect are the breakers on the panel. Okay, so special receptacles in the CLG in the ceiling for special lights and stuff, whatever. Okay, so the electrical power plan's job is to show you everything that needs power in the building, how it's connected, what panel it's connected to, also data phone outlets, where they are, and tons of keynotes that you have to make sure you read in very good detail. Okay, so electrical set, lighting plan, power plan, single line diagram, all of those things that are needed to help the electrician properly power and light the building based on the specifications, based on the power requirements. Any other questions, concerns, please visit our website. We'd love to teach you more about this and other topics at S as in Sam, F as in Frank, johnsonconsulting.com. Thanks a lot and have a wonderful rest of your day, week, year, and life. Talk to you soon. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and in this short video, we are going to review the plumbing set prior to our doing the takeoff for our Scooters coffee. And so what we're looking at here is the initial cover sheet, and gives you a bunch of words that we just go right through because our job as estimators and for my job to review is to get down to the pages and what we need to do and how we need to identify each of the pages. This sheet basically just takes some and transcribes some stuff that is in the specifications, that if you are the electrician, if you are the plumber, you need to make sure you review that in detail. So they give you some little snippets of it here on our first sheet of the plumbing set. Second sheet is all of our details, all of our symbols, and what they mean and how we can identify one from the other. And so a lot of symbols, and as you do more and more of these, they'll become very familiar. So what is the plumbing set? It's basically all of the piping systems that connect to everything having to do with water and gas. So all of our sinks, our toilets, if there's the gas stove, the plumbing set will show you where all of the gas piping is located and all of the equipment that it's connected to. Plumbing is a very detailed scope of work. There are a lot of connections. There's a lot of angles and a lot of you also have to make sure, certain portions of the plumbing scope of work is underground, right? The sewer portion is underground, where the clean and fresh water portions are always above ground. So those are a lot of little things to know, and it'd be worth it if you are in the plumbing trade to do a very good deep class with us to get way more detail. But this is basically just to give you some basics of what you'll see in a plumbing set. So In the plumbing set, they'll give you all of the equipment, of course. So what type of plumbing equipment is going to be connected? Now, this project is from the ground up, and so when we talk about from the ground up projects and in plumbing, there are the roughing cost, which are the cost to connect a plumbing piece of equipment for the very first time, which is an additional cost above the cost to run the pipe and the cost to install the actual piece of equipment. So roughing costs can be anywhere from $300 for each piece to $1,200, depending on the type, or 15 or 2,500. Really depends on the type of plumbing equipment that we are installing for the very first time. And so, if you think about a roughing, it's basically all of the equipment required to connect that piece of plumbing equipment to the clean water and dirty water systems. And that's how you kind of want to think of a plumbing plan. And when you look at a plumbing set, there are two separate plans and some additional plans to help you, almost like the electrical set. And so, here on this page, it's all of the equipment, all of the connections, because we do have pipes, right? Each of the piece of plumbing equipment is connected to a piece of plumbing pipe, and the plumber needs to know specifically the size of the pipe. And so when we talk about connecting a piece of plumbing equipment to water sources, right? You have a hot water source, you have the cold water source, if it applies, right? A toilet, a hot water source doesn't apply, but a cold water source does apply, and then all of the sources, a sewer connection applies. So the plumber has to know what the hot water pipe size is, the cold water pipe size is, and the sewer pipe size. So you'll get a legend, a list of all of the equipment, all of the plumbing supplies, and the plumber needs to know. They'll be given what the size, things are falling apart here early in the morning, what the size of each of the cold water, hot water, and the waste, and the vent size, indirect. Waste and vent usually same size. So that's all of the little stuff. And so now we'll get to the plumbing plans. And this basically, we have some elevations and some details to tell the plumber how to connect the pipes, how they should be fastened. And let's go to the plumbing. Now this is the sanitary sewer. Sanitary is the waste plan. In a plumbing set, you'll have the waste plan pretty much and the water and gas plan. So it'll be connected to the same equipment, but it will just show you different sizes and different types of pipe. So this is the pipe that takes the waste away from the building. And so it tells you the size and it shows you what it's connected to. So this is a 3-inch sewer pipe. 3-inch FS is a floor sink. So you'll have a list of all your plumbing equipment that'll be noted by something. So I know that's a floor sink. Here's another floor sink, and it shows all of the pipe that connects to the floor sinks. So there's a main pipe that's a little bigger, right? Because we have to collect all of the waste from each of the pieces of equipment and then take it out to the main sewer system. Floor cleanouts. So if you're ever in a McDonald's and you see a drain in the bathroom, basically that's a floor clean out, and it just shows you all the sizes of the waste pipe that's connected to each of the pieces of plumbing equipment. This is a Scooter's coffee, so you can imagine you just have a bunch of sinks, and in the bathroom, somewhere there's a bathroom, there's a whole bunch of sinks to clean stuff, floor sinks, hand sinks, and then we have the vent to roof. In our plumbing system, we have the venting system, so that's noted. It's a 3-inch size, so very simple. And then here's the bathroom, the water closet, also known as the toilet in regular lingo, and the lab called the sink. Okay, and TW clean out, something clean out, and grease interceptor, always at the exterior of the building. We take out the grease and whatever, and then it comes and gets picked up somewhere. And then we have more 4-inch waste underground. Once it goes outside, it's underground, our waste system. So that's one of the sheets in the plan. So for plumbing, we have two plans. One's a sanitary plan, shows you all of the sanitary pipe connections to each of the pieces of equipment. And then we go to, so I call that the dirty water system. And now we go to the clean water system. And again, and I'll come back to what that is. Go back to the clean water system, and now it shows you all of the water pipes and the connections and controls to the same equipment, but now the size of the water. Okay, and it'll direct you. And again, there's always something to read and to know. But for the purpose of estimating, we need to determine how many linear feet of each size pipe. Okay, so let's look at these real quick. And these are called riser diagrams or isometric diagrams. And what do they do? Well, each of the plumbing systems, right, have a vertical measure. They go up and down. The plan shows you the horizontal measure of the pipe, where you also need to know which pipes go up and down, which pipes go vertically into the ceiling and up, and what's the size. And so that's what this is. It's connected to each of the pieces of plumbing equipment. Now this again is the horizontal measure that you get off the plan. The main reason for this view is to be able to determine which of the pipes go up and what the sizes are. And so when you do an estimate, I would always count for each vertical measure 10 feet of pipe, because again, it's going up. These are the horizontal measures that you get from the plans, so you don't really have to count for those, but the purpose of this view is to say which of the pipes go vertically, and that's very important when you're trying to price anything. Same thing with electrical wire that comes it comes through the ceiling too. It's all laid in the ceiling, and it comes down to the switches and to the outlets. Well, this is the equivalent of that for a plumbing plan, so you always need to know the vertical measure, and that's what that's for. So this shows you the vertical measure of the clean water system, and then the one we were looking at before shows you the vertical measure of the sewer system. And broken lines mean underground, so of course it's going to be underground. Sewer system's underground, and at some point it comes up and into the building. But this shows, shows you underground, also shows you vent. That's the vent. Broken line also means vent pipe. But you can assume sewer pipes always underground. Unless it's a multi-story building, then yeah, it's going to go second floor, third floor, fourth floor. But this is all underground pipe for the sewer. And again, the whole purpose is to show you the vertical measure, what comes up into the building, where these measures are already shown to you. Except for the vent, you may not see the vent pipe, so you may be able to. And see, you have to be really good, because these are not to scale, so you can't measure that and say it's 22 feet. You have to kind of go from the plan and figure out where each of these are located. If it doesn't give you a vent pipe length on the actual plan, or you can assume the vent pipe goes along with the sewer pipe, and it'll be pretty much the same length as your main sewer pipe. And then the vent to roof, or the vertical measures, yeah, for sure it's going to show you. Kind of confusing, but not if you do a detail class. And you're awesome if you can get it. Okay, so 2 sets of plans: dirty water, clean water. Vertical measure shows you the riser diagram show you the vertical measure of pipe, because you need that if you're going to do a takeoff. If you got to do an estimate, you have to know the horizontal measure you get from the plan, vertical measure you get from the riser. You get all of your notes, either in the specifications, in this case in the cover sheet. You get all of your pieces of equipment that you have to install. Plumbing schedule. Lab is a sink. Water closet's the toilet. And everything else is pretty much known. What do we need? We need the size of pipe for cold water, hot water, waste, and vent. And vent, because it all does apply. If hot water doesn't apply, what is it? It's a toilet or something that doesn't require hot water. Okay. And details lets the plumber know how things are supposed to be placed and what's it supposed to look like. And again, the plans: dirty water, clean water. Oh no, that's clean water. Clean water, dirty water, and make the measurement. So, any additional questions, or you want to take a class in more depth, which you probably would if you're a plumber, visit our website at S as in Sam, F as in Frank Johnson Consulting.com. See you at the next class, which would be the electrical set. Have a good one. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we are going to discuss the mechanical set in general and what the mechanical set is comprised of and why we have it. And so let's go. The first thing we'll start with, of course, is always the cover sheet that gives us information about the project, gives us mainly in this set a lot of abbreviations that we may see throughout the set, so we go here to reference what they mean. But the main thing is to be always familiar with symbols that go with the mechanical set. So when we talk about the mechanical set, it's really all of the devices that are used to move, heat, or cool the air within the project. So we're talking about rooftop units, exhaust fans, heaters, coolers, fans, anything like that. But regular fans, like you would see blade fans, a lot of times those will be installed by the electrician. But this is mainly rooftop units, some mechanical heavy equipment that would be on the roof, or heating equipment. And so they're going to give you all of the symbols, and usually, you're going to see the different types of ductwork. And ductwork is the material that the air flows through. And so you will either have rectangular ductwork or spiral. So square ductwork would give you dimensions 12 by 10 or something by something, where the round ductwork would give you the size of the radius size. So the roundness of it, in inches, okay, and everything is in inches. So that's the HVAC legend, gives you pretty much symbols that you would come across. And then we go to, they give you some notes and details on how they want you to connect the ductwork to the mechanical equipment and different things of that nature. So you go through that in detail if you are the HVAC person, to make sure you're familiar with the way that they want you to connect everything. And then let's go just directly to the floor plan. This is for our Scooters Coffee, so it's going to be relatively small. And so we have our air handling unit that is shown here. So how is HVAC represented? Because it's coming through the roof, and so yes, it would be shown within a roof. And again, it's very simple. And this is a very small one, so we always start pretty small when we do the basic review. And so what do we see here? Just the size of the ductwork, and this is the air handling unit. So this is the mechanical equipment and the condensing unit that produces the air, it heats or cools the air. These are the two units. And so just like in any set that you review, there are always going to be numbers or keynotes that's going to be referenced somewhere on the page and by symbol. And so if you're the mechanical contractor, you're going to read through everything and make sure you have everything in order. HVAC equipment also requires condensate or a plumbing scope of work. So, you have to account for that as well. So would you include that on the mechanical estimate, or would you include that on a separate estimate, because it is basically a plumbing scope of work that's involved in the mechanical scope? It all depends on how the electrician wants it represented. Okay, and so what we would do here in this case is just measure, when we're measuring for estimating, the length of the ductwork based on the size. So we'd have to break it all down. And the difference between, I know that this is rectangular ductwork. And typically, if there are probably some notes here that's going to tell me the size. Or if it doesn't, it's probably the same size as this. See, we don't have a size there. And this is the supply grill. Supply grills are always represented by the X, where the return grills are always near the equipment and have a slash, or just a single slash through it to let you know it's a return grill. So this is a very, very small project. Where the mechanical equipment, again, it runs, and how the air moves, basically, we have the larger ductwork near the mechanical equipment. And as it runs through the building, we make it smaller and smaller and smaller while we're pushing it through. And that's what pushes it basically through each of the pieces of ductwork to the room that is needed. And at the end, we do what's called balancing the equipment to make sure. And what these are also missing is a notation of the CFM, which is the cubic feet of air that comes out of each of the supply grills per minute. So this one's a little deficient in that. So, but I'm not the mechanical contractor that actually has to quote balance the system, and that's what balancing does. It makes the HVAC person make sure that the right amount of air is coming out each of the supply grills, and again the supply grills are noted by the X, where the return grill has the diagonal slash, and so you're always going to read all of the notes to make sure you know. And then this is the symbol for the thermostat, right? We have to be able to cut it on and cut it off, so shows you where it's located in the building. And then that there's wiring specific to the equipment, and the electrician either has to facilitate that, or between the mechanical contractor and the electrician, they'll figure out the size of wire and conduit that they need to make sure it works properly. So mechanical is pretty much the least complex of all of the specialty trades, and specialty trades are the mechanical, electrical, and plumbing, where you need to have permits and they need to be checked and inspected. But that's pretty much the basics of how the mechanical set is organized and how the plan is organized. And then it'll give you the equipment information with all of the technical aspects of the equipment, because that's important. And then the fans, if there are any fans, there's an exhaust fan in the ceiling, CFM. So this ceiling fan produces 75 cubic feet of air out of it per minute. And air device, these are the grills. So there's a schedule for everything to tell you the size of the grill, and then the size of the neck. It usually gives you the face size, and then the size of the neck. It tells you to see the plan, and the neck size pretty much goes along with the ductwork that it's connected to. So this is the mechanical set. If you have any additional questions, please visit our website at S as in Sam, F as in Frank, Johnson Consulting.com. And the next set we'll be studying, looking at really quickly, is the plumbing plan. And we have some older videos that go in more detail on this, and we will make those available to you as well. Once again, thank you for joining, and I will see you at the next class. Bye-bye. Hello, this is Stacy with SF Johnson Consulting and Construction Services, and in this recording we are going to go over the details of the scooter site takeoff. Each day we're going to upload a different takeoff, so this will be the first one uploaded. So over the next few days, look for the lighting plan, electrical, and the panel schedules, and all of the wire runs to be uploaded in the next couple of days. So site plan, remember everything, it's going to show you the wire runs or the conduit runs. Make sure you read each of the notes as to what references what. And so I'm just going to go down my takeoff where we had the waterproof site junction boxes. And so in total we had 8 of those, right? And we know that if they are, whether they tell us waterproof or not, we're going to make sure that we designate those as waterproof. Okay, the detector loops, we always want to give that and it looks like in this case they only have one. Is that a loop? Oh no, they had 2. Let's see, what is that? Oh, that's a site stub up for the loop. So 8 and 9 are both loops, so it's kind of awkward. Connect speaker. Oh no, 8 is the speaker. Yeah, connect the speaker to the detection loop. Coordinate exact requirements with manufacturer. Da 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 da. Okay, so this is the loop, and we are going to. It's talking about connecting it, and we know that these lines here are the underground conduit that we're going to need. Okay, And next on the takeoff, and remember the order you do everything doesn't make a difference. It's just the order that we did it. Okay, and so what is that? Connect the drive-through speaker, so we accounted for that. Next is connect the directional sign. We accounted for that. Next was the install the flagpole light. Because it is a light, right? We have to look at the details, see if there's anything. We have to connect that, and then it's also showing us the home run that is going to position 22 in panel A, and so it's awkward for the site plan, right? Because you have to determine where the panel is from the site plan. It's not going to show you, but what you want to do from the site plan is you want to always make sure you just run your conduit wire, whatever, power to the main distribution panel. And then you have to go into your power plan, right? You have to go to your power plan. Let's go to the power plan. You have to go to your power plan to determine where your panel is, and then extend it up from, stub it up from underground up the wall to the power inside the building. So you got to account for penetrations on two sides, right from the interior into the from the exterior to the interior. You got to account for that, and then up to the panel. So any of the site, right? This is all the site. If it was the site plan, has to be run in the same manner. You're going to run it to where the main distribution panel, which is in this area, okay, the switching gear, the electrical switching is right here, so this is most likely the meter, the panel. We can assume that it is because this is telling us this is the service entrance right here, so we can assume it's right here, maybe here, I'm not sure, but nothing here is marked, but we're going to take it from right here. That's where we took it from, right here. All right, back to the site plan. Okay, so next on it was the 4-inch PVC with rigid bins. Okay, and so that's what that told us. So we have about 30 feet of that, and then have a 4-inch stub up. We accounted for that. And then site note 12. I just said site note 12, and that's how many linear feet that is, about 55 feet. And so what site note 12 tells us, provide 4 electrical non-metallic conduits for drive-through metal board, referred to drive-through schematic on this sheet, all 1 2-inch conduit to the IT rack, 1 1.5-inch conduit to the IT rack for communications, 1 1-inch conduit for branch power, 2 20 amp, okay, for the purpose of estimated the takeoff, we don't care about that, but that is for the electrician, to the electrical panel board, and 1 1-inch conduit for loop detection routed to the drive-through area loop detection system. All right, so same thing we do here that we did with the other, is that we take all of those, and so what I said was number 12, okay, and I added this too because this is all part of it. Okay, and they give you the little bin just so it looks fancy and out of the way of the other ones. Okay, so I just measured that one time, right? So that would mean number 12, that would mean 55 feet. What did I say? Yeah. 55 feet of 2-inch conduit that we'd have to stub up. 55 feet of 1.5-inch conduit we'd have to stub up, right? 1 of these, but then we actually have 2, right? 1 here and 1 there, so we'll say 104 linear feet, right? Because each one is 1, so each run is 55 feet, or I'm sorry, 110 feet. Okay, so save yourself some time. If you know it's one, if they're giving you all of these different conduit sizes, but they're saying they're all together pretty much, just run it once and then do the math. Makes life simple, because why would you run that 4 times? It's the same distance. Next, site note 14. And sometimes to, save yourself some time instead of reading all right now, because you'll have 10 of these to do in one day. You just go ahead. Okay, let me see, site note 50. Okay, I don't feel like typing in 3 number 10 da 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 blah 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 when I'm doing this now. So I'm like, okay, site number 14. The main thing is to do what? To measure the how many linear feet. So that came to 67. We'll round it up, 67 linear feet. Okay, but what's 14? So if we did the math right, so it'd be 67 times 3, and then just one run, right, of 67 feet of 3/4 inch non-metallic conduit below finished grade. All below finished grade is PVC. So 3-inch quarter PVC with 3 number 10s running through it, right? That's what that means. And note 14, above ground. Okay, because yeah, once I ran it in, I have to run it, or once I brought it in, I have to run it above ground, right? Stub it up and then run it in above ground. And that was 47 feet of that. And then now building lights, counted those. We got 7, but again, these lights are also shown on the lighting plan, so you can count them here or count them there, but make sure you don't count them twice. And then the building emergency light, which was right here, but again, it's already counted on the lighting plan. Exterior building light, same thing. Did we count them again? I'm sorry. Exterior building light power. So that's how many linear feet to connect the exterior building lights. And, sometimes, you do want to separate everything: exterior building, interior building, underground, all of that, because of the type of conduit that would be required. Most likely, if it's exterior, depend on the specifications. You have to look and see what that says. But it could be rigid steel, it could be EMT, could be PVC. I don't know if you rarely use PVC above ground, but that's why you want to separate all the runs, so you don't have to go back and remeasure later, just in case, I put that in with something and it was wrong, right? So you have everything as detailed as possible. Secondary. Okay, so the secondary, in this case, I think we didn't have to worry about it because it was already existing. But that's how many linear feet from the transformer to the main distribution or the service entrance. In most cases, you do have to worry about it because you have to determine how many conduit and what's the power feeder. And so that was measured for no reason. It's about 85 feet. And then the lighting home runs. Remember, you always want to measure the home runs separately from the main power runs in most cases. And they could be different wire configurations. So you always want to, we teach our students to all the home runs and break the home runs down. It's the panel home runs. If there are multiple different panels, we'll break down the home runs based on the panel. Mechanical equipment home runs, you definitely want to do separately because chances are those are a different power configure or wire configuration. So you don't want to have to go back and re-measure those. Okay, so that is that home run. And then the menu site home run for the menu board, this one right here. So again, yeah, it has to run to the building. And see, what we did is just ran it all the way to the building, but no, it'll run into the building, and then this portion have to be stubbed up above ground. So whatever that distance is, stub up above ground. And we just gave it a little leeway because it could just go right there. And more is better, but less is never. Okay. Flagpole home run. So right here to here, and into the same. We ran the flagpole home run here because I believe this is the lighting control. So, and that's how it says it's supposed to be wired. So, and then the lighting control, I believe, will be wired to the panel. But that's the part where you just want to do more than a little bit, than less. Okay, so that's why that possibly is run there. Let's see what number 10 says. That's the phone company. Oh, I must be. Oh, wait. We got a couple of things lit up. Gotta check it. Oh, where is the panel? No, the panel's right here. So that might be a mistake. It should be a little longer. If we're talking about the exterior building light home run. Oh, okay. No, it's right. So, oh, no. The flagpole home run. Yeah, that's not right because that should go to panel A 22, position 22 in panel A. So we're going to go ahead and fix that. And good thing this isn't due until the 22nd. So we went from here to here to that is the where we're going to bring in the telephone conduit, but then we need to go all the way from that location to all the way to the panel, and then we already gave it the 10 feet down over here, so we don't have to do that. And now we've got about 71 feet for that home run, as opposed to the 50 or 60 we had before. Very good. And what else? Monument sign home run, same thing. With that one, I don't know why we think it's run to only right here, but we're gonna add some more to that one too, because the home runs need to go to the panel, and we already did the little extra. So now that changes that to 85. I'm glad we did this together. All right, and that would be the total takeoff for our site plan. Let's make sure. Do we have this? Let's see. Looks like we're missing some home runs unless we went a different way. Let's see what 1 and 5. 1 is. Okay, we got that. And then 5 is circuit routed to wall switch. And we didn't route it anywhere. So let's see where the wall switch is. E1 for location. So let's go to E1. E1. Nope. E1. A 1 for the location of the wall switch. Oh, let's go back to that. 5. Oh, 1.0. Yeah, that's 1.1. So where's 1.0? Don't tell me they don't give us 1.0. 1.01. 1.02. Where's 1.0? Here? No, plumbing. 1.0. 1.0, not. Oh, wow, they leave that out. So, let's go look on the. Let's look on the lighting plan and see if we could tell where there's a wall switch, because that's where it would be, probably over here. Yeah, probably over here. So we'll just run that to here, and remember on the lighting plan, it's not going to show you where the power panel is, but see the little outline right here, so you know you're going to go from outside, you know where the power panel is, and then go a little bit this way. And we're going to connect that. No, but it says to the switch. And then, okay. Through the switch, so the lighting contactor, right? For the time clock, remember the time clock lighting contactor. I don't believe it shows at all where that is, so we got to do something, even when there's a problem. The lighting contactor that's on the single line diagram that all the lights run through, that's not shown. But we have to give this something. So let's say, what is it? Let's go back to 5, and we have to call it wall switch home run. So let's do that. Wall switch home run. That's why you take 2-3 days to do your takeoff, and make sure your wire is always the last thing you do. Okay, so from here, we're going to take it to the panel we know is here. So let's just take it to the panel. We know is right here. Right here by the door. And then we give it an extra 10 feet for safety's sake. Okay, let's take a look around and make sure everything is accounted for. We got that home run. We got that home run. It's like something's going from here. Yeah, that's when it's a little sloppy, but it is. All right, so that is the site plan takeoff. All of the counts, all of the conduit and wire runs, and the only thing, when you are, the one thing to consider that you don't see, we only want to account for what we see, but what we don't see always, when we go from site plan to the building, there's always a stub up. So you go from one kind of conduit, PVC, to a different kind once you stub it up into the building. So that's the only other addition that you don't see here that you want to always account for, is the stub ups from the site up into the building and through a wall or something like that, because those are additional costs for the penetration of the wall and what they have to do to the conduit to make sure it keeps the signal through the wall and all that good stuff. So, and that is the site plan for the scooters. Look for the power plan or lighting plan most likely next, but each will be uploaded within the next couple of days. We have to stop recording in a weird way, and so we're going to stop, and we'll see you soon. Hello, and this is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we're going to review our panel and our panel schedule for our online estimator, our estimating class for our Scooters Coffee. Now, because this is a very small project, all we have is one panel. Okay, and so what we have to do, and we started on, we always have to count the different breakers within the panel. And so, as we discussed in every commercial building, the power requirements for most of the outlets are powered by the breaker, or just the standard breaker, 20 amp 1 pole, right? Because most of the power requirements in the commercial building is going to use number 12 wire. Okay, and so you can kind of make the conclusion that if your breaker is 20 amp 1 pole, it's more than likely that that home run to the breaker is going to be a number 12. So 2 number 12s and 1 number 12 ground. So the first thing I always do, because we always have more than a lot of the 21s, we count those first, and then just make sure you count all of the other different types of breakers: 50 amp 2 pole, 35 amp 1 pole, because when we order the panel, and we always have to know what the panel is, the current rating, power rating, everything, how many, the amperage for the power, we order the breakers as well. Okay, and so we just started that, so make sure you count each one individually. And two, you can rest assured that if you have more than a 20 amp 1 pole, 30 amp 2 pole, whatever, your home run is probably most likely going to be something other than the number 12 wire. And so you have to make sure that you look very carefully, whether it is on the panel itself, it'll tell you the wire size, some do, or you have to look on the power plan, or you have to look on the equipment schedule, but something will tell you, it's a clue that if you have more than the 20 amp 1 pole, these will probably use a different, other than number 12 for the home run. Okay, and the next video we're going to do very shortly for this takeoff, right? You're always going to get the single line diagram in this form, in an elevation view. But in order to do the proper takeoff, right, we have to know physically how many linear feet from the panel to the breaker. And so remember, you have to go to the power plan and do that physical measurement. That's the only way to get this, and you have to be as accurate with that as you are with all the other home runs. But in this short video, we are going to, so we did a screenshot of the final, all of the counts. So you see the majority of the pink, those are the 21s. So just make sure you account for every position, all of the breakers, because when you purchase the switch gear, you're going to purchase these breakers too. Okay, and so in the next video, we're going to go over the lighting plan, what that takeoff should have looked like. And in the end, after we do the screenshot reviews, I'm going to give you the actual takeoff from the actual estimate. That'll be loaded every Thursday of the week, and then the estimate itself will be uploaded every Saturday. And you know that your takeoff should be uploaded or sent to us through education at sfjohnsonconsulting.com every Wednesday. Your takeoff should be sent to us, and then every Friday your actual estimate. Okay, so we will see you in the next class. If you have any questions, please make sure to email again at education@sfjohnsonconsulting.com, and we will see you on the next video and in the next class. Bye-bye. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and in this short video we're going to review the scooter's electrical lighting plan and the takeoff and what it should pretty much look like. What we do, we have the screenshot on the website, and so for every lighting takeoff, of course, right, we're going to count all of the different lights, which these are all T1s, and then we have A's, and then we have the junction boxes in EM1. So this first project is really very simple, not very difficult at all. So I'm going to flash up here this screenshot of the takeoff. So pretty simple, all the exterior lights, all of the other lights. This is very simple. All the junction boxes counted. And then we did the conduit runs as shown on the plan. Okay, so what this doesn't show are the home runs that have to go to the panel. And remember that the panels on the lighting plan, they're not as clear as they would be on the power plan, because that's the purpose of the power plan, to show you all the power components. But there is a little outline here to show you where it is. And so don't forget, the very last thing we're going to do is to run, it looks like only 3 home runs for this project. So run one from here to there, one from here to there, and one from here to there. And so I just did that really quickly on the takeoff software. So that's what the home runs would look like, about 45 linear feet of home run, give or take all the up and down. So we'd add about 10%. Or when we only have so few, we'll go ahead and add 10 feet per home run. And remember that in most cases, the lighting wire, power wire, they're able to use MC cable. And so that's different than the home run wire. So we know the home runs are either 2 number 12s and 1 number 12 and a 3/4 inch conduit, or if it is a mechanical equipment, which doesn't even look like we have any here on the other plan. I'm not quite sure. I'm sure we have fans or whatever. When we do the power plan, it'll show. But home runs, usually 2 number 12s, 1 number 12 ground. But this one was pretty simple. Just count all the lights, don't miss anything. And usually the procedure that I use to make sure I don't miss anything is I do all the counts first, then I go to the other plan, do all those counts, but then I do the MC cable runs. And usually if I've missed a light, I'll be able to find that when I do the MC cable runs, or when I do the home runs, then I can see that I missed something. So always give yourself 2 or 3 days, always like 3 days, one for the takeoff, one for the pricing, and then one for the Excel spreadsheet. So this is just a small lighting plan, take off what it should look like for our Scooters Coffee. If you have any questions, visit the website or send me an email at education@sfjohnsonconsulting.com. And I'll see you at the next video. Hello, this is Stacy with SF Johnson Consulting and Construction Services. And in this video, we're going to be looking at the Scooters power plan. And we've broken the screenshot into two pieces. So we'll be able to see that. And as always, when we have a kitchen of any kind, the first thing you always want to do, you want to look at the power plan to see how the outlets are arranged, because you don't want to go through and count duplex, 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 quad, and then you find out later that, yeah, it's a duplex, a regular duplex, and this is a NEMA 515, and this is a NEMA 6 something, and then you have to recount each one of those individually. So you always want to make sure when you have a kitchen that you look at the kitchen schedule to see kind of the best way to count all of your outlets to make sure that you don't have to double up your work. And so this plan is kind of strange, where the call out for the outlet are numbered 1, 2, 3, 4A, 4B, da 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 da, all the way down to C. And so, which includes 6, 8, 9, 13, 14A, 14B. And so for this one, I would recommend, because you have multiples of 14Bs, you have more than one. And so I would recommend, and then sometimes you have a B and a C, and so you have to see, well, that's a quad. So which one of these applies if I have a B and a C? So it's a quad, right? It shows a quad, but B and C are two duplex. Making life so difficult for us, okay? So what I would do is probably, are they both the same? Well, it looks like they're both on two different heights, and so I would just say two duplex, or BC combination, which is basically two duplex, not a quad. Okay, not a quad. Okay, so that's a little confusing. I'd have to ask and put in a note right there. And so this is exactly what we did as far as counting the outlets on the power plan. Now, if they had this oval notation, then it was a outlet for the kitchen, right? And if it did not have an oval notation like this one, right, it's just a regular quad. We'll just assume it's a quad because that's what it's showing is a quad outlet. Unless our symbols show us that this is for some reason, it's a duplex outlet, even though it's a quad symbol. Okay. And so, again, the most important thing for this, really more than difficult, more than it should be set for the power plan, I would go through and count based on the call out for the equipment schedule. So I would count based on these, which means you'll have to have a new count for all of those, which is okay because you rather be detailed and slow and concise instead of making mistakes. So I would start, 13, whatever I see, 25, I have one of those there, and just go through. Okay, so by the end of your takeoff, you will have, and I will have the takeoff up separately, each of the takeoffs for the power plan, lighting plan, noted separately. I don't have this for the presentation, but this was done on another computer, so we do have the takeoff. All right, so that's what just as far as the outlets, again, all of the outlets that indicate the oval, okay, correspond to these outlets in the equipment schedule. So I would count them based on the markups or the notation on the equipment schedule. Now, any of them again that don't have the oval, which are the ceiling receptacle, you can go ahead and just say dupe ceiling. Okay, so wire runs. As you can see, the majority of everything here is a home run. And so, again, when we run the home runs, it's not to be the exact same way that the electrician would run it when they run it, is to give an allowance to do a good job to show that you've accounted for that home run from its location, as stated on the plans, to where the panel is. Okay, so the way that I always start the home runs, because eventually the whole sheet's going to be filled up with your home runs. Okay, so the first thing we have are anything that's directly connected, because this is not a home run. And so I normally, let's make sure it's to scale, for 3/8 equals 1, it is. And so we always want to measure our wire that's directly connected, because most times we can use MC cable for that. And so that's not number 12s that we have to account for. So I usually call something like that power wire. And from one to the other. And remember, the plans are to scale. And so if I measure that to be 11 feet, then it should, in real life, if I went to this Scooter's Coffee, it should be actually 11 feet in real life. Okay, and see, from this point, we're just going to run home runs. Okay, and it's only one panel. And so if it was two panels, I would break up home run panel A, home run panel B, whatever. But it's only one. And so this is the messy work. I'll just call it HR for home runs. And so what we do is just start from the nearest outlet to the panel. And the home run, this home run is going to position 7, panel A. This is panel A. Something as simple as that. Position 3, but I want to read 5 to make sure there's something else that I need to account for, or should coordinate all requirements and quantity for each electrical and blocking mounting for sign provider, da 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 da. Okay, we don't care about that. Okay, so from here to here, and we're going to bring it in. And we got this one. Right, that's 1, 2, 3. We got this one. So we bring from here to here to there. And now, for all the other ones, I will start. What is that? Okay, that's a home run. It kind of tricked me. I will start to the home runs that's nearest the panel. Now, I won't do mechanical equipment home runs. Those will be separate, because chances are, why? If we have a breaker, chances are it's not number 12. So we want to do the home runs that are all, we know for a fact that they will be number 12. So we're not going to do the home runs for the mechanical equipment, but all the other ones. Okay, so we're going to start, and we see what 14 is, but we're really focusing on home runs. And so you see how you just want to keep it neat. And then at the end, we want to add 10% to our run, because it has to go down the wall. Okay, so we want to start closest to the panel and work our way out. Why? So we can see. Okay, so that's an idea on how to do the home runs. So you know that all of your black, it typically is telephone, but as long as you know it's the junction box, and it'll say 7, whatever we need. Junction box plus the conduit to the ceiling. So you always want to account for those. Okay, but mainly these are all your home runs. Okay, so you know that you want to make sure that any of the home runs that aren't like this position, one position to the panel, you know that's pretty much a number 12. But you always want to check your equipment schedule, right? Because some things may not be number 12. And so you want to make sure you have your wire right. So these are two number 10s and one number 10 ground and 3/4. So where I see that oval in the number 9, okay, where the number 9 is, I know that I need to make that number 10 wire. I need to make number 6. Is that home run is number 10s and not number 12s. Okay, so you should have all your equipment home run wire configurations either on a schedule for the equipment or if it's not here, at least hopefully it'll be on your panel schedule next to the position that the equipment's going to be connected to. Okay, so you want to make sure that you don't, so wherever that 9 is, oval 9, somewhere in here, wherever it is, there's the 8, there's the 9. So you know your special receptacles. That's the symbol for a special. You probably could always assume that it's not going to be a number 12. Why? Because it, by virtue of it needing a higher current rating, higher current to run it, chances are it's going to use a different wire, right, to produce the higher current. So it's going to have a different wire other than number 12. Let's see. We saw some other special receptacles. Let's see. Yeah, that's a number 9. I guess that's the same one. And then there's some special ones. So those other ones were number 6. Remember, it was number 6. And then let's see what number 3 is, because that looks like a special receptacle. If that's giving me, see, no, number 6 is, oh wait, no, number 3. It's a special receptacle, but it still uses number 12. But that's fine. You just want to make sure you're using the right wire configuration run when you're doing your home runs. Okay, so I have a photo, and what I did was break this pretty much in half. So of course we're going to count all of our outlets based on what they're called. And then the other thing is to do any of the power wire that may be a MC cable. And then after that, you just got to run all your home runs. And so we broke it up. This is part 1. So you saw as I was doing just a little part how they all run here pretty much. And just try to keep them all orderly. The same way you would most likely run it, in real life. You wouldn't run it all over the place. So for the purpose of estimating, we're gonna make sure it's all orderly from one home run to, or we could have ran this way, but just as long as we account for it, that's the main thing. Account for every home run. Okay, that's part 1, and we broke it in half, and then that's the bottom part where all of these we ran them all here, and then most likely to save time, okay, we ran them all here, and so we know we had 1, 2, 3, 4, 5, whatever of the same kind, whatever. So we know we had 10 of them, 10 home runs, and so we said, okay, 10 times that. Instead of doing each one separately, save you some time. Okay, so that's the pretty much the visual. But the key with this one is to make sure you, anytime you have a kitchen, so it's a restaurant, it's a restaurant, coffee shop, anything that's making food. Okay, it's going to have a lot of different kitchen equipment that will require different power requirements, which means it would require different wire configurations, and the mechanical equipment as well. Okay, you can always assume, except for maybe the exhaust fans, maybe the exhaust fans would be number 12, but you can pretty much assume that any of your rooftop unit, your water heater, all that stuff, the home run for that one is going to be other than number 12. So you always want to just leave those for last. Do your runs for your rooftop unit lasts, run it to the same panel, but then give it like an extra 10 feet to go down the wall and into the building, that kind of thing. Okay, so this is the power takeoff for the scooters to get all of our takeoff done the right way. Okay, your air handling unit. Okay, you're gonna run it whatever 15 is, and know that you always have to account for your disconnect switches. These are disconnect switches, these little boxes. So if your box, your piece of equipment has one, make sure you account for it, either an allowance, giving it a material cost and an hourly rate on how long it's going to take. Always never leave that out because that is part, even if they don't give you the value in the set. You always have to make sure you include it and the home run for it. And of course, we're going to go by the panel schedule, or in this case, it gave it to us right here for the mechanical equipment, what the power should be. So, any questions, email me at education@sfjohnsonconsulting.com. This is going to end this session for a review of the power takeoff for the Scooters Coffee. And the main thing again, you can count. If you got a good counting tool, you'll never mess that up. But the key is making sure you don't leave out any home run. You run it to the panel, and you try to do it in the neatest way possible, and just account for every run. So, any questions, let me know, and I will see you in the next class. Hello, everybody, and this is Stacy Johnson, SF Johnson Consulting and Construction Services, and in this video, we're going to review the full Scooters plumbing set to complete a full takeoff and give the student a good idea of what we look at when we review a plumbing set and what we need to look at when we produce the estimate. Plumbing is kind of difficult in its own because unless you have a good cost book that incorporates all of the connectors and the angles and the T's, doing the takeoff can be very difficult. But because we use a very good cost book that incorporates all of that, we can make measurements and use assembly prices and win a lot. And that is always our goal, to help our client produce very detailed, bare bones estimates that can compete and can win. So, first sheet we're going to look at here, they give us the plumbing specifications. And so it's just going to be some information taken out of the full specs to give the plumber an idea of the domestic water pipe fittings, the sizes for the sewer pipe, water pipe, vent and waste, water heaters, just to give some information that you would also find in the specifications. So it's important to review the specifications always prior to looking at the construction documents and taking the measurements. Right, so those are the specs, and we always want to be familiar with plumbing symbols. Okay, so they give us quite a few symbols, but if we do this a lot, we're going to pretty much know what all the symbols are. Abbreviations, in the event you see something you don't recognize. Floor cleanouts, wall cleanouts, sanitary sewer, all of the stuff that you would find in the plumbing set, and how they designate the different pipe runs: cold water, hot water, waste, vent, grease waste, condensate drain, gas pipe, roof drain, and any existing pipe. Okay, and so what is a set of plumbing plans? Well, the plumbing contractor is responsible for building the system that moves liquids and gases. And so the plumbing plan is full of all of the equipment that it's connected to, all the pipes that connect each one, all of the controls for the system, And what our job is to make sure that we account for everything we need to account for in terms of measuring the pipe runs correctly. If it's new construction, we have to make sure we include the rough end for that particular piece of plumbing equipment. That is always an additional cost to install the plumbing fixture for the very first time. So you usually, it's only when in new construction, or if you have an addition where it's a new toilet put in, you never forget the rough end cost, because again, that could be very expensive depending on the equipment. So it can go anywhere from 100 and something bucks to, for a shower, it could be $1,200, $1,500. So you never want to forget the rough end cost, in addition to the plumbing fixture cost, and then all of the cost to run the pipe, and then the cost for insulation on different types of pipes if it is asked for, and then the cost to test the system. So all of those would be incorporated into your plumbing costs. So now, what's most important is when you talk about the plumbing fixture, when we talk about any plumbing fixture, we want to talk about, or reference, or make sure we know the size of the cold water pipe connection, the size of the hot water pipe connection, the size of the waste water pipe connection, and the size of the vent pipe connection. And so when we buy our equipment too, we have to keep those things in mind as well. And so in every set of plumbing plans, you will definitely receive all of the schedule of the plumbing equipment. So a LAV, a LAV, that is the technical term, always for the sink in the bathroom. So when we see LAV 1, LAV 2, we always automatically know it's a sink, but it's in the bathroom only. So you'll never see the tag LAV for a kitchen or any place else other than a bathroom. So the LAV is the sink strictly for the bathroom. So if we have a restaurant, which this is a coffee shop, we'll have a sink, hand sink, whatever sink. Those would be, and we know that those are uh, in the, not in the bathroom. So water closet, technical term for the toilet, right? So we always see those old timey terms in the plumbing set. So we have a floor sink, we have a floor drain, we have a trap primer. These are all pieces of the or items included in the plumbing equipment. The grease interceptor, sample port, trap seal, wall clean out, floor clean out, and it gives you, again, you always want to know the size of the water, cold water, hot water, waste, and vent if it applies. So for a floor drain, the cold water, hot water doesn't apply because it's a drain. But we do need to know the size of the waste pipe connected to it and the vent pipe. And then, of course, it's going to give you the manufacturer of all of the equipment where they prefer you purchase. And, you know, sometimes they'll have a national supplier depending on the size of the franchise. And it'll always tell you something down here if there's a national supplier. But with the regular, you know, typical plumbing supplies, it's nothing that special where you would need like a specialty distributor for toilets and sinks, right? So it tells you too, because we have not only the toilets and sinks, we also have the equipment in the kitchen. And we need to know the sizes of those cold water, hot water, waste. And there would not be a vent for the kitchen equipment. So the ice maker, coffee maker, and this indicates that they're directly connected to the, to a water source. Okay, so it's all the equipment. So the MEPs, or the mechanical, electrical, and plumbing sets, are really solely based on equipment, the specifications of the equipment, and how the equipment is supposed to perform. And so you'll get a lot of technical information for all of your plumbing set, your electrical set, and for your HVAC set. Okay, plumbing details, yes. So they're going to show you a TYP is typical, right? The term typical means we perform, or we do one operation the same way every time. So this is a typical. inline circulating detail, the circulating pump. This is how it is supposed to be connected, and it gives the plumber the detail for all of the plumbing specialties, is what's this called. These are special ways that plumbing pipes are connected. So these are referred to as the plumbing specialties, and it's giving the plumber the exact elevation view, pretty much, on how it should be positioned. Okay, so it's important for the plumber to look through all of that. All right, so in a plumbing set, we have two, just like the electrical set, we have two plans. One plan is what I call the dirty water plan, or the sanitary system. And then the other plan is for the clean water, domestic water system. And if there are any gas lines that run, those are also shown on your water plan. And if it's a lot of different gas and different pipes of that nature, then it'll have a third plan, possibly, where it's just all of the gases, like a dentist's office may have a separate plan for all of the things that run to the dentist chair and all of that stuff. So, two plans, typically sanitary and then the clean water. So I always refer to the clean water plan, dirty water plan. Now, all of the pipes, of course, run to the same equipment. And so, what's the plan? Plan view is going to show you all the equipment. 3-inch floor sink right here. Okay, ice bins right there. Okay, so the sanitary system is going to show you where all of the sanitary pipes are connected to the sinks, the toilet, the grease waste. Okay, and so our job as estimators for the plumbing plan is to, first of all, always make sure your plans are to scale, right? Because we want to make sure our measurements are correct. So what this states is that for every 3/8 of an inch I measure, it's really 1 foot. So I'm going to make sure I have it to scale. 3/8 equals 1. I agree. And typically you want to go ahead and see if you have a measured, a standard measure that's stated on here, and measure it. And if it is 4 feet 6 inches, you know your plans are to scale. And how you read this from hash mark to hash mark, the number in the middle is the actual length. And so we'll get our dimension tool and put it in. Where you put it is that where the hash mark and the line meet. So somewhere like there to here where the hash mark and the line meet. Yep, 4, 6. That way you know your plans are to scale. And so when you're making your measurements, you know they are correct. Okay, and so this is a highly dimensioned set of construction documents, meaning it has a lot of dimensions already on it. So if you didn't have a tool, you can use floor drain to here is pretty much, or it's parallel to this segment of line, which is 4 feet 6 inches. And so because these are two parallel segments, this one here giving us the measurement, this one here showing us the distance from this floor drain to this connection right here, I can assume that these two measurements are the same length. And so this, basically the length of this pipe is 4 feet 6 inches. Okay, so they give you a lot of measurements on there, so you can use that for that purpose. And so our job would be to just, now, one of the tricks of the trade for I like to do for the plumbing, equipment, is not to count the equipment from the plan, just to measure the pipe lengths from the plan. So I'm just going to go ahead and do a 3-inch sewer. Okay, and so I say okay, and then I just follow the line because it's to scale. So it's going to be actual length. So I can go in and put a 45-degree angle, 45 if I want it, but I'm going to use good assembly pricing, so it would include all angles and all of that. All right, so that's the 3-inch, and I'm going to stop that because we have the 2-inch. Now, this is a solid line, so that is a pipe where the broken line, I already know it is a vent because for my symbols, broken lines are always the vent for the pipe for plumbing. Now, if you have a broken line on your plan from any others, on the maybe for the floor plan, you have the broken line. That chances are that means it's underground something. If you have a broken line on an electrical set plan, then that typically means it's underground conduit. But if you have a broken line like this on a plumbing plan, that is typical to how they represent the vent line. Okay, and so I have this kind of covered up, but we see here that it's a 2-inch vent, so I'm going to go ahead and say 2-inch V. The least amount of typing, the better, because we do this for a living, so we know what we're talking about. And we know it's plumbing, so we know it's a vent pipe. Okay, and then it looks like this one too is also vent where it looks like it's teeing up here. And then we'll just right there. And then here. Okay, so, and then here. So over time, you're going to mark off all of your stuff. And you'll have all your links. So for my 3-inch sewer that I did measure, let's light that up. This is 6.5 feet. So for my 2-inch vent that I've added up is 30.8 or 31 feet so far. Okay, so the plan view is going to give you the horizontal measure of pipe, the horizontal measures when you measure that. But you have to know the distance vertically, right? Up and down. Because the water pipes go up and down through the walls and through the ceiling, whatever. Sewer pipe goes below ground and then up into the building. And so what you have in every plumbing set is the riser diagram, or they call it the isometric view or whatever. And so what this does is kind of trippy, right? It shows you this is to represent up and down or vertical measure of the pipe. And so you can use this to do your takeoff. And what I typically do, or how I explain this, you see these runs are the horizontal measure, the same thing you see on the plan. So you don't count that. The one thing we're looking at are all of the vertical measures. Here, here, here. So when we do the takeoff, we can say that we have the 2-inch and this is a vent pipe. So basically the vent pipe goes from above the ceiling, because if this is the hand sink, this is the ceiling. So it goes above the ceiling and down to the hand sink. So I have to account for that measure of vent pipe to the hand sink. And so the purpose of the riser diagram is to show you the vertical measures of pipe, and it'll give you the size. Okay, so this is vent to roof. There's always a vent to roof for all your plumbing systems, so it tells you the size of the vent to roof. Okay, and so what I typically do when I get the riser diagram, in terms of takeoff, every time I see it go up, I'll give it 10 feet per story, right? 10 feet per story of building. So if it's only one, commercial buildings are typically 10 feet in height, unless it's auditorium or something. But typically a office building or even a restaurant inside is 10, 12, no more than 10, 12, 16 feet. Look at the section view. That'll tell you exactly what it is. So I give each one of these runs 10 feet up to account for the takeoff for that. So now, when I was at the sanitary plan, I said I usually don't use the plan to count the fixtures because you can get a little confused if it's not a good plan. But where you can count fixtures is just from any one of your isometric or any one of your riser diagrams. Because the riser diagram represents the whole plumbing system, which means it's going to show every piece of plumbing equipment, and you can count from here, and you can be very accurate. Nothing's going to get in your way. 3-inch floor sink one, 3-inch floor drain one. Everything is really clear here. And so you can see it better here than trying to do it here. Once you've already put all the measurements on, everything like that. So I would always recommend doing your fixture counts from your isometric. And again, this is what we call the riser diagram. It shows the whole plumbing system. These runs you see here, they reflect on the plan. These are the horizontal runs that reflect on the plan. But the isometric or the riser diagram is strictly used for the vertical measures. So when you're doing your takeoff, you can account for the up and down for the pipe. There's a way to show you on the plan too, but it's so much easier to do it this way. And so what I would typically do is say I do a counting tool, 2-inch vent, click, click, click. So I know 3 times 10, that's 30 feet of 2-inch vent pipe, and do it for everything. And now the roughing cost we were talking about is the cost to connect your fixture for the very first time in new construction. And so this little box right here kind of represents that roughing cost. Okay. So when you see that, you say, oh, rough in for a 3-inch sink. And it only applies to the very first time in construction. Okay, this is the sanitary riser. So the riser for, remember, you have two systems. You have the sanitary system and you have the clean water, gas, or air on the other system. So yeah, you have riser diagrams for both of the plans or both of the systems. Okay, so here's the next plan. And again, now you have, these are water pipe of 1/2 inch. So keep in mind that our water systems are usually copper, all the copper pipes. Water systems are copper pipes. And in most cases, your sewer system, that's a PVC, but some states require it be cast iron, especially in commercial or, commercial buildings. So it's really for you to look in the specifications to determine what pipe you use for water, sewer, and then if there's gas, it's typically black steel. Okay, or again, it'll be very clear in the specifications what type of pipe to use for each of the plumbing systems. So this is the domestic water system, same fixtures, right? So we don't count the fixtures twice. It's just two different water piping systems going to the same piece of equipment. And so this also has the riser diagram. Now, instead of the sewer pipe, we're talking about the copper water pipe that goes to each of the pieces of equipment. Now, your riser is going to be different because there's some things that the sewer pipe goes to that the water pipe doesn't go to, like floor drains. There may be a floor drain where it's not, there's no need to run water to it. And so you won't see it, but then we have to read the notes, make sure we understand what's what. Okay, so riser diagram for your water system. Same thing applies. And if it's a lav, right, a sink, you're going to have hot water, cold water coming down to the sink. Okay, so, and keep in mind that, you'll have, again, some things on your water riser or your domestic water riser that you won't have on your sewer, like the water heater. Okay, so recirculating pump, that won't be on your sewer plan. So it's really important to pay attention to detail and when it comes to all of your plumbing equipment, so you don't leave anything out. Okay, so that is the water plan, two plans for a plumbing system. Sanitary, okay, which this one includes the riser diagram, which is really cool because it makes estimating easy as far as determining all of your pipe runs. And then the water system, running to the same equipment, a riser diagram to say which of the pipes go up and down to the equipment. Okay, and that's pretty much a full overview of a plumbing plan. Right, we have the notes from the specs. We have all of the information about the plumbing equipment. We need to know the sizes of the pipe, what the equipment is. It's a kitchen, so it's going to have even extra equipment. Need to know the sizes of the cold water, hot water, waste, vent going to all the equipment if it applies. And then we have two plans. We have the sanitary plan to tell us what all of the sanitary pipe and the sizes, and we just measure. And then we look at the riser diagram to get the vertical measures, where the plan is all of the horizontal measures of pipe. Two systems, so we have to do it twice. And then we have pretty much by the time we add up all the pipe runs, the cost of the equipment, all of the fixtures, testing it, roughing cost, and you have a pretty good, very good job here. Pretty small, but we're going to finish individually now, do each individual takeoff for each of the sheets, and then put together an awesome plumbing estimate. All right, so if there are any questions, please email me at education@sfjohnsonconsulting.com, and we will see you at the next class on the next review. And thanks a lot for joining me. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are going to review this site work estimate, takeoff actually. It's already complete because I thought the better way would be to do it first and then review each point as we go on. So remember, this is an existing location where we're adjusting the site work. Here's the building envelope, but we're working on all of the new site components, which the gray represents asphalt. This represents new concrete. We have new wheel stops. There are new upright curbs, and so we break those into straight portions and the curved portions. And we had to reinstall the gate, and so basically that's what this is, and install a new walkway, and then all of the control joints we have to count for, all of the parking lot stripes, and that's about it. Oh, and then we have a new dumpster area that we have to go and look at another view because the foundation is different. So really with this, because we have a good cost book, we'll start with curbs. So the straight portions, and then we added the curved portions. Okay, and then let's see, the concrete, we broke it down. So that portion, and then we had to do all of the we'll get that later. Then we did the wheel stops. All right, so you count those individually, and it's based on all of the, so we always have to go here, right? So for instance, the curbs cost book, it'll vary from 12 inch, 18 inch, 24 inch. So we had to make sure, you look at your details for each, so you can make sure you're at least pricing it for the right things. But if you went by, you could also price it by a cubic yard of concrete, right? The height, the depth, and then we measured how many linear feet. So those are the three dimensions, and divide by 27 to give you cubic yards. I turned cubic feet into cubic yards. Okay, so you can do it that way, or our excellent cost book. That's not our excellent cost book. Our excellent cost book will give us, and then do we already have it? No, we did the paving. We were on the paving because we already did the estimate too. So we're gonna where'd it go? It's down here. We'll put in curbs so you can just have an idea, because we'll come back with the actual estimate. Let's go here and let's pick this one. So those are asphalt, and those aren't the ones that we chose. Let's go here. There we go. So curbs, the vertical curb, see, that's what we had. Vertical curb, upright. Okay, and ours was 6 inch by 18. So we had the straight portion is $9.77 for the material, cost unit 0.119, and then the equipment, and this is all per unit, so right, per linear feet. And so depending on what we had, right, concrete apron, I actually could have used that for that. I might go back and use that for the concrete apron part. And then we had the walkway. Okay, so that's for that as far as the pricing. But yeah, so you just got to go through. So this is asphalt, and let's see how they do the asphalt. That's interesting, how they price the asphalt. Yeah, so asphalt for roads, assembly cost, on-site roadway, base and aggregate, the binder course. All right, so and the compaction, square yards. So we get square feet divided by 9. That'll give us square yards. Okay, or it gives us to us per square foot. Okay, so that's what we have for this portion and that gray area. So where's my asphalt? Okay, and so this was already, it didn't give us anything for that, right? This part, so we didn't account for that unless there's something we need to do, and then we'll go back and fix it. And then of course, let's see, the handicap stripes, these right here, and then the symbols is 2, and then these we had stripes for. Let's take that back off. I don't know what they were trying to do with this, if this was actually something that they were going to paint on, and these were something actually that were actually going to get painted. So I'm like, number 8, how do they figure that's 8 and that's 3, and is it? So I'm not really clear, but we did account for these broken striping, and I'm like, okay, this is number 1, 1, 2, 3, 4, 6, 7, 8, okay. And then I also assume that these numbers will get painted everywhere, even though they only put it here. So that might be a lot of assuming, but we assume that that is the case, the broken striping as opposed to the solid, and that's what is reflected on the estimate. Okay, so all of the stripes. Oh, we don't need that one. And we got all of those handled. The curb, the asphalt, and this is a 4-foot walkway, so we could price it by assembly by 4 foot wide. I believe we did it separately. It's on the estimate. And then the dumpster pad. So this is the enclosure, but then the pad itself is on. More details about the pad is here. There are the bollards, 1, 2, 3, 4 of those that's we've accounted for, but then also the thickened slab edge. And the bad part about this is that it's not to scale, so it looks like the thickened edge is around the perimeter of the whole thing, as well as 2 going along the middle portion, going along with this. So that's basically how we price that, is that as far as the thickened slab edge, it was the perimeter we measured, and then twice in the middle, because that's what it looks like over here. And so that's how it was priced. And then we'll see that we've included the rebar in there as well. And let's see, and then all the expansion joints and the control joints, and I think of that as far as that's it for this. So this is basically the full takeoff for that. It's pretty simple. And if you have any questions, please email me at education@sfjohnsonconsulting.com. And Let me know your thoughts, and please also subscribe. We will get the estimate portion shown to you just so you have a good idea of all of the man hour totals for each and the pricing, because like stuff like the bumper pads are precast. One cost, it includes the dowels that hold them in, so we'll go over that. And yeah, hope you enjoyed the presentation, and please give me your thoughts and email me, and I'll see you at the next class. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we have a doozy of a project right now that we're looking at. We are doing the structural set, and of all the sets, the structural set is the most challenging. It's for me, it's a lot of fun because it is so challenging and complicated, and you just can't rush if you're going to do a good job. You just can't rush a structural set. So, what's in the structural set? Well, our set, we have the foundation that is going to extend from the existing foundation, and everything that's going to go with that, all of the column pads. So, we have some that are A, of a certain make, right? They're all going to be different, and we'll go over each one. We have B's, and then there's a C, and then there's these things and how they're connected to the column pad. And then we have this thing with the call out, right? And these are paint booths. Okay, but again, it's just the foundation. And then here we have something that's existing, or no, it's not existing. This is something new that we're creating or making on the existing foundation. And so that's the foundation. So the structural set is the foundation, and then we have the equipment platform. So there's a new awning that's going to be put on there. So we have this structural member, hollow structural steel, 8x8 by a quarter, high and low. So it's on, should have an elevation view, probably doesn't, but it has the section view so we can see what it is. And then here we have new, in our demo, if you can remember, we demoed the railing because this was a patio. So we demoed, I believe, I'm not sure, some part of it was. So we demoed everything, and now we're going to put in 2x10 joists at the 16ths, and then there are some additional structural members that have to be there, LVL beams. And so we have all the measurements done for those, and then the roof framing. We have new roof framing, and it's a new parapet wall that's going to be created right here. And so we have that section view, and we can start just looking at details there, because parapet wall is in the wall we extend above the roof, and so we have it at the front of the building, I believe, and that's at CS/301. So we'll look at that and all of the section views. And so let's start with the foundation. And so when we do the estimate, we'll come back with the actual estimate. Now, first thing we see, we'll start here and work our way around, is the section view of A over S201. Well, that's telling us the foundation and how it's built on this stretch. Okay, so this is A, whatever that is. And then here it gives us another section view to show us how that column pad B is constructed. And so we'll look at A and B. Now, remember, when we do the section length, whatever we see at that section view, it's that many linear feet. So if we have a top plate, bottom plate, if we have bolts, if we have whatever, it's going to be based on that linear feet. So if we put it at the 8 inches, whatever, it's based on each section view's length. The column pad really is it may show us how this is connected to the column pad, but the column pad is just going to be a particular width times the length times the depth and the structural steel that's going through it. And so we'll do a takeoff for each of, so for this estimate for the structural, it'll be a takeoff for linear amounts based on each of the section views. So the GC knows how many linear feet of section view. See, now C is not really a section view. It is, but it's not for us because, again, it's just showing us how the makeup of this A column pad is. But this A over S201, that's the full length of that wall. So whatever we see there, and also footing, that's the concrete footing. That's the full, that goes, I think, here, here, and here. And so whatever we see there, and there's a list of all of our, so what is A, what is da-da-da, what is B, what is C? Alright, so, right, structural notes. Alright, so column pads or pad footings. A is the size 2 by 6 by 2 by 6, so square, you know, but by 3 feet 2 inches deep. Okay, so those are pretty big column pads. Alright, that's huge. It's a 3-foot deep pad. And so yeah, we have to determine, and here's the reinforcement. So we have 3 both ways, 3 number 4s equal top and bottom. But that's what our section view is going to show us, how those rebar are positioned within the concrete pad. So all of them are, they get pretty big. 8 by 8, 5 by 5. Now this is, oh, no inches, 3 feet, 3 feet, 3 feet 6 inches. That's odd. No, wait, what am I doing? 2 by 6 by 2 by 6 by 3 by, okay, got it. Too many, got confused. So 2 by 6, 2 foot 6 inches by 2 foot 6 inches by 3 feet 2 inches deep. So they're all 3 feet 2 inches deep. 5 by 5, 8 by 8, 2 6 by 2 6. Hey, what the hell are you looking at? All right, and then the anchor rod schedule. Okay, so that's what we'll use for that. So just very quickly, because we'll zip through and we already did the length, so really it's just a matter of going ahead and now showing and putting it on the estimate and seeing how much it cost. All right, so A over, and let's go to S201. A, everything's pretty much on S201. And so we have A, where do we have A? Over here. So that length is going to be this configuration. So what do we have to do? We have to determine the length. This is the length of the wall, and this is the slab on grade, and then also we have to determine the length of the rebar. And so this rebar is going to go into the existing foundation at this point. This is the new foundation, and number 4 continuous all the way through that length that we measured. And then this set, so now we have the length that's continuous. Then we have this one, this pretty much upside down L shape, and this upside down L shape. Number 4, and it's 4 feet long. We're going to place them every 16 inches at the exterior. And then, so this connects the existing slab to, well, the existing slab to the new one, and then this one right here, number 4, 5 foot 8 inch dowel at the 24s. That's this one. That's this one. And then the continuous one. And then here we have a continuous L beam, L2, 2x2 by 3/16, all the way down that length as well. So each one of those things will be listed individually on the estimate under that section view based on the length. Okay, so that's pretty much what we have to do for every one of these. Determine, and because we have all of this is the existing, and this is the new. It should be, it is, yeah, the new, the existing, and you just have to match that rebar. So it is time consuming, but you have to do it based on each of the section views, and that's what's going to be done. So based on each one of those section views, F, S2, or whatever F was, and then even though we have the column pads, that goes continuously through. But we have to see what is CF1. We didn't go over that. So we have to create that too on the estimate, line by line, whatever it says that is. So let's go to that. And that is the continuous footing, 8 by 3, 2. With 3, number 4 continuous all the way through. So that's easy. We have to create that, price it. That's easy. So we broke down all of that. Now let's look at these, whatever this is. Okay, so these are whatever this is. I don't even know what this is, but we know we're going to have some new trench drains through it. Existing slab, and then let's look at 3 and 4 over S201. 3 S202. Alright, so that's this. Was the center, and then the section view from here. So basically we have to always, when you have a new slab and an existing, you always have to do this deal right here. So it's giving us that section view. And now what's weird, this is not a very good set of plans, and I just want to show this. Here we go. I just want to show this. Alright, so now we call these out. Okay, so let's take a look at that. I need to measure the length because it's on the other page. Okay, so we go to, those are the paint booths. So that's these. And so the section view right here, we have to know how to build these walls. And so what I've figured out from this section view, when you cut your section view, it says if you cut it right here, now you're looking based on the arrow, you're looking this way. And so if I'm looking, if I cut it here, here's the section view. And so now basically my walls, it's a base of whatever this tells me, 8-inch, and with 8-inch walls, that's the new slab. That's how we connect it. But then I was like, what is that? But then you just have, it's like it's just floating. Well, remember, when you have two different scales, you got to make sure you're on the right scale. This scale is 3/4 equals 1. This scale is 1/4 equals 1. Oh, well, I figured out this is this. the bridge, and so it's showing me in the bridge. So if I use scale 1/4, remember this is a section view of this, and it's going through this. So it's trying to tell you, if you cut that and you stood in that gap, that's how you would see the layout of the concrete. But this was the more confusing. I'm like, what the heck? And so this is actually what they call the bridge right here. That's that 8-inch reinforced concrete bridge. And so it's this whole area, and I know that it's that, and I measured it. It's like, okay, 5 feet 3 inches. So I put it on that scale. It's on that scale, 3 feet 3 inches. And then I put it on this scale, which is 3/4, right? It's like sometimes it's rocket science. It really is. And I said, okay, well, oh, 5 feet 3 inches. Okay. So that must be this, right? So if the scale is different, remember that it's going to be a different length based on the scale you use. And so I'm like, okay, so it's just this long, whatever the heck that is, and why they stopped it, because it looks like it's this. Is it just that long to where it's like a concrete connected to only here? It's like this still don't make no sense the way they have it laid out. But I just assume what I'm going to do, just so you know, Sean, for that I'm just going to do this area right here. But as far as whatever the heck that is, I'm assuming it doesn't is it the whole? I don't think so. I'm not thinking it doesn't go any bigger farther than, I don't have it going here because that's longer than 5 feet 3 inches if I did it all the way to here. So just right here is that what we're pricing and everything for, that square, because it's very odd. And so that's just about it as far as the takeoff numbers, and everything is just all about a number. And then once we put the actual estimate together, we'll go over the line by line items that made up each of these things that we will have on the estimate. And even right here, this is 1 over S201. It's like, okay, what do we do with that? 1 over, it says field verify existing pit lock. Okay. So I'm like, okay, I'm assuming because it's dark. Usually stuff in dark colors means new work. So it's dark, which means this is something it's new, even though it's on the existing foundation. Just like this is new on the existing foundation. But I don't know. So I'm going to account for that too. So 1 over S201. Where are we? So 1. So I'm assuming this is all something new that we're doing. No. Yeah. Drilling the holes. And this. And covering it up with whatever that is. So. Okay. That's for that section view. And I'm assuming that's this existing slab, but this right here, I'm not quite sure what we're doing with that. It just tells me what the reinforcement is. I'm assuming that's concrete. Yeah, foundation section. So we'll be doing that, adding that to again where we see this right here, 1 over S201. So yes, foundations are very different, very difficult, Okay, and but we're gonna get it done, and we'll be back with the full estimate. Any questions, please email us at education@sfjohnsonconsulting.com and look very shortly for the full cost estimate on pretty much everything you see here, and then it'll be explained even further. All right, thanks a lot. Talk to you next time. Hey everyone, this is Stacy again, and we are still on the same project. Our repair facility for crashes. Let's put it that way. And now we're looking at the plumbing plan. So because it's not a big, there's no really huge need for the plumbing aspect. So what we're seeing here is it's important. They're giving us a couple of call outs here and here, and then this is the piping that's running through the main building, and then we have some standalone eye wash stations, and then these call outs are actually right here. And so what's important is to make sure when you're doing the takeoff that you note the scale. So you can't use the same scale for this full set and then these separately because they are of different scales. So we can measure one scale or whatever, but when it comes to actually, recording the actual numbers, we need to make sure if we're recording the numbers for the upper that we have the scale set to 1/8. Okay, so now we have, these are accurate measurements and for this. So this one's going to be a little tricky because they're both on the same page. This is 1/8, so you could double, or no, this is 1/4, so you can double that and use all of 1/4 scale, but I don't do that. What we have to do is do each one separately, and when we print it, just note that you have to print it differently for the different scales. And so because remember, this is new construction, or this is existing, we have to note if we have in our plumbing plans, if the plumbing here is actually new, or are we replacing existing plumbing? Because if it is new, because this is the existing building, this is the new construction. So if we're just replacing, and that's why I say this, if we're just replacing sinks, water closets, and lavs, then we don't need to incorporate the rough-in costs. But if they're actually new, then yes, we do. So what we need to do is go back to remind myself and go back to the building demo plan. Let's turn off some of these colors. Right. Let's turn off. Yeah, no, there's no bathrooms. This is the demo. There are no bathrooms in here. Those are all new bathrooms because this is the existing building. And even with the color, you don't see bathrooms. So all of our plumbing, go back to the plumbing plan, just a quick reminder that no, it's all new. So yes, we'll have to incorporate all of the rough ends for each of the pieces of plumbing equipment. Okay, so all this SS, sanitary sewer, 2-inch, and then we go down here where we have water closets, urinals, labs, floor drains. Okay, and then here we connect to the existing, and then the other bathroom, everything is new. so rough ends for everything. And so that is all of the horizontal measures, all the horizontal measures of piping. And then we have our two plans, right? In our power, in our plumbing plan, we have the sanitary system, so all the sanitary items, vents, sanitary. And then we have our clean water system with all of our new hot water, cold water, hot water return piping. Same thing here, all of the call outs, hot water, cold water. Okay, so we run each one of those separately, all the horizontal measures. And then we also have gas that we're running to the paint booth and to the heaters, gas lines, and CO2. Now, with the CO2 lines, or the, not CO2, compressed air. With the compressed air, this symbol, it says, well, based on where the compressors are going to be. So for the purpose of the estimate, we just included the full measure, this full 1/2 inch piping for this, the full measure of the building. So the full measure of the building was 68. So pretty much 68 feet. So each one of these runs 68 times 1, 2, 3, 4, 5, 6, all the way. Okay, so that's how, we have to add that one. That's how those are run. So we would have a pretty good, and then the CO gonna go up. And then we have to account for all of the controls, but this isn't all the way complete yet, so we have to do that. So remember, all horizontal runs, and again for all of the compressed air piping, because we don't know where the compressors are going to be, we just, these measures are, we just make it the full 68 feet per location. Now the riser diagrams, the rule of thumb, what we do depending on the height of the building is usually 10 feet per vertical measure of pipe. And remember, these are the horizontal measures from the plans, and these are the vertical measures. So we have to count each one of those based on what it is. Vent, 2-inch vent, and this is the sanitary riser. Okay, and not complete because we got a 2-inch vent right here. So we kind of do them really early so we can look 1,000 times to make sure we have everything. And then that's that riser, and now we have the water riser. Vertical measures of the pipe that go up. 1/2 to the cold water, hot water, whatever. And these are the measures we see on the plan, so we don't have to worry about those. And that's the whole purpose of the riser, to show you the vertical measure of the pipe so you can get as accurate as possible for your takeoff. And here is the gas riser. And the only thing we have here really is 2-inch going up. Everything else is the vertical measure we see on the plans pretty much, except for a couple of locations. And where it comes into the building, you have to account for that connection. And then all the controls are here. And of course the different size. And that's going to be it for the power. I wanted to say power. I don't know why, because that's coming up next. That's on my mind. For the plumbing plan. Okay, so if you have any questions, same thing, same email, education@sfjohnsonconsulting.com. And we will be back with a full estimate to see what a job like this costs, and in comparison to all the others that we have to complete. And please give us your thoughts and make sure to subscribe. See you very soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and we are going to go over just some parts of our foundation or structural estimate based on our takeoff that we did a few days ago on this auto repair location, and we did the takeoff, and all of that is on video already on the channel. And so just want to point out how we would actually put the estimate together. Now remember, when we're doing, now this is the structural set, and so in the structural set, in our set, it could be a number of things depending on what you're doing, but this is a existing building that has an extension of a metal framed building, and so we're basically putting in the foundation that the metal frame building is going to sit on, and then once it's built, then we have all of the interior framing that's going to go inside the building. And so structural is all of the foundation, all of the roof framing, and everything related to this. If there are headers and posts and beams and columns and column pads, then those are the things, and all of the reinforcement, all of the rebar or the mesh or whatever. And so I'm just going to go through some points. This ended up being a $1.5 million estimate for the structural set. And so just want to go through, when we're doing, we come across, and I, methodical, I do everything just in line. And so the first part of a structural set is the foundation. And so, yes, we did broke down the foundation based on the section views and individual items. So we had quite a few different, 12, I believe, of the smaller column pads they call A. C, B, I think we had 2 or 3. And we had a bigger one, only one of C, and a bunch of other rebar. And then in here, in the new building, we had the paint booths that had 8-inch foundations and 8-inch walls. And so that's a whole different section. This is the call out right here, and then the full slab, which was 4,000 and some square feet. And so won't go through the full estimate because 1.6 pretty much $1 million worth of estimate we have right here. And so there's just some portions like and again, when we have a existing building and we're adding on to it in terms of the foundation, you're always going to have some portion of the dowels or rebar basically that you are going to go from the from the new foundation into the existing. And so this is what this section view F over S201. So we'll look at that one first. F as in Frank over S201. So we go to page 201 section, and I always get that's 301. So F as in Frank. And so yeah, now you can imagine for each one of these section views we had a line item on the estimate, but we'll just look at a few. And so this is the existing building, this is the new building, and so anytime we do have that, we're going to have some dowels that secure new to existing. And so yeah, we're going to put a 1/2-inch dowel, 1 foot rod, and times 4.5 minimum. That's how far it's going to go into the concrete on this end, right? At every 24 inches. And so when you do the takeoff, then you want to figure out, okay, if we got to place it every 24 inches, then if we have, how many feet of that did we have? F over, what is that, 201 or 301? We had 71 feet of that, so it says. And so we'd have to determine, let's go back to F. So if we had 71 feet of this, so we know continuous number 4, there'd be 71 feet, because whatever we see at the section view is that much in takeoff or in length. So 71 feet of that section means 71 feet of that, which means now for our placing it every 24, that means every 2 feet. So we just take the 74, did I say 74 or whatever, 74 divided by 2, right, because we're placing every 2 feet. And so we have 37 locations that we're going to be placing that, so we know how many of those or how many linear feet of that we need. And so that's what we had to do for every section view that you see. Okay, and so we had a lot of the drilling the holes and the column pads. Now we got all of this out of a cost book. So you got to make sure you're getting your cost not from your uncle, but from a construction cost book, where he gave us now the cost per column pad. And the column pads, again, were based on a certain size, right? These are the column pads A, B, and C, certain size with certain reinforcements, so we know what size they are, right? Same with the continuous footer, we know the size, so we go to our good cost book, and it helps assist us with the material cost and also the labor cost, the man hour units. How long is it going to take us to do a certain thing per unit? Okay, and so that way we can determine how many, everything we need. All right, so section view, that's one part. And another part of the section, or in the structural set, is some of the framing, right? And so we have some beams. So again, section views, we'll look at E, right? E over S301. So let's take a look at that on the plan. E over S301. So 301 E, and that's our section view, and that's our telephone. And so now we know that this was a fun one. So you have to, hopefully you're a nerd. Well, if you're an estimator, you have to have fun doing this. And so you start from top to bottom. So now we have a continuous 2x10 with 3 16D nails, joists at each joist. And we have 2.5, it's late, 2x4 studs at the 16 we have to add, then the Simpson ties, then the treated, oh, this is what I wanted to show you. No, maybe not. Yeah, and then the treated this and that. Okay, and so E over 3, let's look at the estimate. E over 3, S301. Where is that at? There we go. We had 67 feet. Okay, so all the way down. The studs we did by square feet because we knew that they were 1.5 feet high times 67. That gives us that, and then cost book kicks in, and then the Simpson ties. We know how many because we do that same thing. We turn 67 feet into inches, and then we divide by the placement. So if we have to put every 8 inches, we divide by 8. If we have to put every 32 inches, we divide by 32. If we have to put every 16 inches, we divide by 16. Okay, and so that's that. And then there was one other. Sometimes in the structural set, you have to, okay, so that's the paint booth and how we figured out all the rebar and everything for that. There were 2 of them, so we figured out the cost for 1, and we multiplied by 2. And then there was one other, here we go. Now we're at the roof framing. Okay, so the new roof, well, we have to have 18 gauge studs, parapet. We got all of that. Okay, and then we had to have a metal deck, but this is what I want us to look at, is L lintel number 1 in section view A over S301. So let's look at that one, because in that one we had fabricated, well, it will end up being a piece of fabricated steel. And so I want to go over quickly how we determine the cost and price and all of that. So let's look at A over S301. A right here. So at the wall elevation at the entrance. Okay, so we had the studs, the 6-inch or 8-inch metal. That's easy. But then we have these C8 by 1875. Okay, and so these are C-beams, steel. You have I-beams, J-beams, C-beams, whatever. Okay, so this is a C-beam. And basically, the second digit tells us the weight per linear foot. So how many feet can this beam hold, or how many pounds can this beam hold per linear foot? And so that's always the standard. So whatever you see by whatever, that second digit's always, it always means, sometimes you have what, 25, 125, whatever. That means that's how many pounds per linear foot that beam will hold. And so in order to turn that into a price, we have to turn, because fabricated metals are priced by the pound. And so we have to change this into pounds. And the way that you do it is, if it holds 18.75 pounds per linear foot, you just multiply the linear feet by the pounds, the number of pounds, and you have how many pounds. And then you can charge by the pound. So what is that? We'll look at that section view on the estimate so you can see how that's priced. A over S301. I think it's farther down, and that's about all we're gonna, A over S. Okay, and so we had the C8 by 18.75, we had 17 linear feet of that, and so we say 17 times 18.75 is 319 pounds. And so cost book again kicks in and tells us how much it is, the cost of that per linear foot or per pound. And then you can figure out the cost, and then we have to do some and that is the cost to install. It's the full price of everything for that. And so I got to see why we don't have a, and that is the man hour unit for that too. So the cost, so it's going to take 13.40 hours to install that according to the cost book. Okay, so that's the one thing that's kind of different if you're dealing in something other than, metal studs or whatever. When you have fabricated metals, you have to determine how many linear feet you have, and then multiply that by the pounds per linear foot. You have the pounds, and then yes, the good cost book's going to tell you the cost per pound. All right, so that is the full structural. All we did was go to each section view, right? We had how many linear feet, turn that into square feet, and it's just crazy. But in the end, it's a whopping $1.6 million. And this is just the base rate. We haven't even added overhead and profits. So any questions at all related to anything you see, please email me at education@sfjohnsonconsulting.com. Please also give us your thoughts on the presentation, and make sure to subscribe. All right, and we'll see you next time. Hey guys, this is Stacy. Just wanted to go over a little information you should think about in addition to all of your takeoff information when you have your demolition cost. Do you need temporary enclosures? Do you need temporary structures? Do you need temporary power? Are there going to be an amount of cleanup fees? And definitely with your demolition, you're going to have waste fees, your disposal, your dumpster fees, recycle fees. Those are things to think about. And two, when you think about demolition, in a lot of the cases, the costs are reduced. Your estimate cost would be reduced if there is value in some of the items that you are going to retain. If you're going to retain a lot of the demoed items and they do have a value, they have a salvage value, then you should, or you probably will, be required to deduct that amount from your estimate cost. So keep that in mind. Anytime, and in the laws of demolition, there's laws associated with this stuff, that unless the owner requires or requests the item returned, then it automatically becomes the ownership, or it comes under the ownership of the demolition contractor. And so if that is the case, you should typically reduce the amount of your estimate. So you want to think about all of these waste fees and all of the salvage value information that you're going to deduct from your estimate. Will you have fencing costs? Do you have to, do things of that nature? So always keep that in mind. And those are costs in addition to the cost to actually physically remove an item. You got to think about the waste fees, disposal fees, the hauling fees, and the cash value of any of the items that you retain. And so, if you have any questions in addition to that, please email me at education@sfjohnsonconsulting.com, and I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to uh, present a small little video on, pricing and determining man hours. We have a takeoff class, and I'll be teaching demolition takeoff today, and just wanted to remind you when you are trying to do competitive bidding, it is very important to make sure you are accurate in the number of man hours that you are determining for the job based on the scope of work, because if you over determine how many man hours it's going to take, you're going to overestimate how long it's going to take, which means you're going to charge too much for labor, which means you're going to charge too much and you're not going to be competitive. And so we always recommend that you have a very reliable way of determining man hours, and we use a cost book. And for this class, in a cost book, it will break down what you're going to do, and it will also tell you what portion of a man hour it's going to take for you to do that. So if you know you have 100 of those, then you multiply that number by 100. We have specialized Excel spreadsheets that we've created that will do that for you if you know how much, right? And you know how much because you're going to do a what? Takeoff. So make sure when you are determining your labor that you have some way to accurately determine how long a scope of work is going to take. And in the construction industry, they have tons of ways for you to determine, how long something's going to take by a cost book. The cost book will include all the information you need to determine, if not the material cost, if you input it correctly, but also your accurate labor. And that is very important if you're going to do competitive bidding. So have any questions, please email me directly. I'll be happy to answer any questions you have related to the construction work that you see me presenting. All right. And you can email me at education@sfjohnsonconsulting.com. Have a good one, and I'll see you next time as soon as I turn it off. See you guys. Bye. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and let's talk about finishes. So our finishes are anything that goes in and on, I like to say the project, but anything that goes on the project or in the project or in the building after the main structural components have been constructed. And so drywalls are finished, and that's the most odd finish, I think. Roofing materials are finished, and all the floor components are finishes. And so we want to go over this set of construction documents for the Brunswick location, because some of the finishes, every set of plans, it's not great. And so, just want to note some of the inconsistencies in the plans. And so the finish contractors will always want to look at the interior elevations and the finish plan. And so in the finish schedule, of course, let's look at the finish schedule. And so the finish schedule is going to give us each of the rooms and tell us the floor finishes and the floor and the base, and then all of the walls, north, south, east, west, and then the ceiling, and then any remarks. And so we can basically, been doing this forever, so I know I need to do, after I've done 3 of these, pretty much the same thing. Everything is sealed concrete, which I've chosen as epoxy. And there are some things that are not clear, and so you have to make assumptions but then note the assumptions in the estimate or just exclude what isn't clear. So the finished schedule, and so we go to the finished plan where we're going to make all of the measurements. And so we start here where we do all of the measurements for the bases. Pretty much everything was a rubber base except for, I don't know why we did that different, except for the bathrooms, pretty much. And maybe I was doing some other, let me see, what is that blue for? Oh, closet paint. Okay, and so too, if you're ever confused about, because here you can only do how many linear feet closet paint, but if you don't know the height, usually the reflective ceiling plan will give you the heights of the ceilings in every room. And let me see if I can find that real quick. A good reflective ceiling plan will give you the finish, which is, we can tell by the finish, is very few painted ceilings. So we know that the ceiling, even if there was no way to determine the height from anything else, if there were like no section views or whatever, just go to the reflective ceiling plan, and then that's going to tell you the height of the ceiling. So you figure you're going to paint the ceiling to the height, right? You're going to paint the wall to the height of the ceiling. And so you have to go through and do each thing individually, because the height of the ceiling in the IT room is 9 feet. But then the restroom, we know we can exclude that, because that is, I think that is, we don't have to worry about that as far as the ceiling component, because everything here is acoustical ceiling tile. But as far as the paint, the bathrooms are all tile, and I believe that, but they give us interior elevation views for the bathroom, so we don't have to guess. But usually you have about 3 to 4 feet of wall that needs to be painted above any bathroom, where the like 7 feet of, if it's a 9 foot, it's probably 6.5 feet of tile, and the rest is paint. But this one's pretty good because we get some interior elevation markers. But again, if you can't determine the height of the wall for your paint, if it is painted, you can always go to the reflective ceiling plan. Kind of got off on that one, kind of. So, two finishes. You're going to look at your door schedule, because you need to know, and I specifically marked which doors I'm staining as opposed to the doors that I'm painting. So if you're the finished person, yeah, interior elevations, exterior elevations, the door schedule. And then if you are to paint the window frames, you can use this to measure the lengths. So that's good. Okay, so let's go back to finish schedule. So here's everything that we're going to do per room, and then all of the marks are given to us here. RB's a rubber base, ACT, and all of ours is 2x2. So you know what each thing is. Carpet tile, we measure that by square yards instead of square feet. So you have to convert once you do the measurement, divide by 9, all of that. And so did all the measurements. So the epoxy was this area, all the concrete. Then we had the ceramic tile, was all of that area. And then we had carpet tile and the luxury vinyl over here, and plywood. Now, plywood is all of here, but it didn't tell us that we're doing anything to the plywood, so we just measured it. Because the plywood is just the flooring, it didn't say we had to stain it, anything, so there's absolutely nothing included for that, including, but we did include the rubber base for that area. Yeah, so the rubber base is included, but as far as the flooring, we didn't include anything because the plywood is just what the regular floor is. Okay, and so that's that part. So that's all the interior, and then we always want to go back. So here, interior elevations, it's going to give us all of what's on the wall based on the wall finish, interior elevation 401. If we look at 13, it's the finishes on this wall, 12 finishes along this wall, 14, and so on and so forth. So if is for future reference, if you're looking at the finish schedule and there's a room like this room with no interior elevation, that I'll exclude it, because that probably means there's nothing that's going to be done. But then you go to the finish schedule, and that is the mezzanine, and I believe they don't even give this a name, so we don't even know what that is. So is it a good set of plans saying just ignore it, or is it a bad set of plans? We had to do something, but it didn't tell us what to do. So I just left that alone. Only gave it the base, no finishes on the plywood floor. Okay, and so you got the doors. You got to see how many you have to paint, and then you want to look at your exterior elevations. And so here's the outside of the building. So you kind of want to know, okay, is there a finish I need to be aware of? So quickly, I know that the metal panel for this building is excluded as far as what we need to do. So we've excluded that. Brick veneer, new paint. So we would give that a square footage for we have to paint the brick. So everywhere we saw new paint, we measured that and we applied that to the estimate. New lights, that'd be on the electrical. You don't have to, it's just pointing it out. Canopy, roof, existing, so nothing here. But we did set a cost to paint the gutter systems, all existing and all new. And yeah, so, but everything here was marked. See, C's and D's and Y's, but in the areas that there were no marks, we did not apply any kind of finish. We didn't put anything as far. So all of this, there is no cost for painting, for anything other than the doors. So that should be noted. Okay, because there were no marks here. Assumed, it may be by mistake, but everything here is excluded. If the mark isn't there, then we just excluded it, because it's too confusing to try to figure out, okay, is this the same as this? No, because the texture, see, it's a different type of finish, so that's not the same. And that's the roof, it's not the wall. And so yeah, all that gray has been excluded in terms of, is there any paint, any kind of finish, any cleaning, anything. So it's just better safe than sorry, because that would really increase the cost for not really sure if we're doing anything. Then it can be clarified later. But everything that is marked, there is a cost. These are all the downspouts and all the gutters. And so in terms of finishes, you know, you want to look at the finish schedule, which we did. Look at the finish plan, interior, exterior elevations, do your measurements and match it up. And then let's see, is this it for this location? Yes. So at the end of the day, these are our totals, all of our subcontractor prices. So that includes material, but we can break it down into individual painting, as we've done before in a couple of videos. But this is a subcontractor price, that's why there's no labor. This includes material and labor in that one price per square foot. And then the other items for the finishes, so we added the coffee bar and placing chairs and the refrigerator and a couple of other things. The bathroom grab bars, and all of that. And in the end of the day, before overhead profit, not too bad. So if you have any questions, please email me directly at education@sfjohnsonconsulting.com. Tell me what you think. And this is the last video for today, which is the 14th of November. But for today, the remainder of the week, there'll be a ton more to go over each of the takeoffs and the estimates, to clarify anything and to give you tips and hopefully help you become an excellent estimator. Never rush anything. That's what I've learned over these years. But give me your thoughts, and I will see you on the next video. Hey everyone, this is Stacy, of course, with SF Johnson Consulting and Construction Services, and I just wanted to go over something really quickly that is kind of abstract, and it's difficult for a lot of people, but it's important that you kind of get it right if you want to get your material takeoff correct. So we're looking at a reflective ceiling plan that shows us all the new ceiling finishes, and this one has quite a few section views. Okay, so when you see anything like this, you're going to assume that it's some kind of soffit, right? Some exterior, it's late, some wall that's extending down from the roof joist or from the ceiling. And so you want to make sure you account for that. And so the first thing you do is basically, what I do is that we know that we have two of these. So we have a section view 4/A111, which accounts for this length, right? That length. A section view gives you a section of a wall, right? So this is the sections of the wall extending from the ceiling. So it's understood that this section and this section, well, it's right here. Okay, I would understand that whatever I see for this length is going to be the same here, but they did put the section views. Just the purple made me miss it. Okay, and so basically the section view, or the length for 4/A111, is all of this. Okay, which I think we have as, where is it? Somewhere up here. What is that? 24.3. Yeah, 24.3 linear feet. But not this. So it's just this, this, and that. That seemed a little short. Oh no, that's 14 right there. So, and 5 and 5. Yeah, that's about right. All right, so that 24 feet for that section view. And then, so we have the length and then the area that accounts for it. Same thing here. We have a 3/A111. We have the area that's outlined in the green, and then it's also going to have a length, right? Which is, that length is, there better be extension. Let's turn off all the bubbles and make sure we have the, we have that one. Make sure we have the other length accounted for. Okay, good. All right, so that length is the red basically, which is 4/A11, which is 24.3. Okay, so now we have to look at the section views, because it's telling our framer that, okay, this is the area, but then there's some portion that's down that we need to account for. So 3/A111 is right here. And so for the soffit, basically, we have, this is the area that we've already accounted for, but then we also need to account for this length and that length, and usually it's about 6 inches above the ceiling, so that's probably like a foot, right? Foot. And so for this length, if I had to, which I do have to do, determine a square foot, right? Square is length times height. Well, each one of these is a foot. It's about a foot. That's 6 inches. So 3 feet. Because we have to count for that above the ceiling. So that's a foot and a half, and another foot and a half. Foot and a half and a foot and a half is 3 feet. And so the additional square feet for this soffit, which is 3 over A111, is 3 feet times whatever our length for that was, which is that. That's how many square feet of additional framing or drywall and framing. I mean, you can think of this in terms of, because we've already accounted for that. So you can think in terms of this is the framing. Now, the framing most probably extends to the, and I'm doing this takeoff specifically just for the drywall. The framing most likely extends because of this right here tells you that they're only breaking off a portion of that, so we can see for the drywall, and so it probably extends to the roof joist. So you have to be able to determine the length of these, because it's basically, if you had to break it down, right, we have a flat area, which is this for the drywall, and then it's in terms of studs, we have whatever this length times 2 times the length of the whole section is how many square feet of framing, if you want to do it separately, and then the drywall is just this. Okay, same thing for both sections. And the other one, now if we had to do this one, we already did the flat section, but the additional vertical is it's to scale. Okay, so we could figure that out. Okay, but again, this part's gonna go, this is it's gonna go all the way to, from most likely, the ceiling joist. Okay, so you have to look at a different view to determine what's the height from here to the ceiling joist. Probably 6 feet, but take a look. Depends on a lot of stuff, but there should be a building section view, and we won't go over that right now. Okay, so that is very important when you're looking at the reflective ceiling plan. Just like the floor plan has section views, the ceiling plan has section views too, so you have to be able to go to those to determine your additional material. Right, so any questions, please email us at education@sfjohnsonconsulting.com. Let me know what you think, and make sure to subscribe, and we will see you next time. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and now let's talk about framing and drywall. So what we have here is our, this is actually our smallest of the projects that we had to do. This is number 3, and the way that they broke this out, I don't know if you can look, but I'll get close, where they have a call out. So the broken line is the call out, and so we're going to go to a different page in order to see the layout for that framing. We're actually going to go to image number 1 on page A401 for all of the new walls for this area. But in the meantime, some walls are here, so we went ahead and measured P1, and we always go through the openings, go through all the doors and windows unless it's bigger than 16 feet. Okay, so that's wall P1, and then we had our other wall here, our firewall P3. Okay, and then we had P6, which was a 10-foot high masonry wall right there, and P5, which is one side drywall over there, 10 feet high, P6 and P5. Okay, so now we'll go to the call out. And of course we have to do the ceiling too, but we're going to jump to the call out. Alright, and so all the different colors, and what do we have? So we just go through and then we measure the desk for our finishes, go through all of the now right here, this desk has to be sitting on something. And so what we did is we just priced that all of the reception desks, because they all have reception desks separately, so it's like $1,700 or something. So that would include the base, the top, the everything. Okay, so we didn't include in some of them, like here, P4, in the very first project we did, it told us that these walls were 3.5 feet high. So we knew for all the other ones that they were 3.5 feet high. And again, it's not clear here. So, but the very first set, the bigger set, said that these are the walls at the workstations. And so this height, we've assumed them to be 3 feet 6 inches high for all of the workstations. So, we just did all the measurements and we have the takeoff, right? So P1A, P1, okay, and then this was not clear at all. So this was completely excluded from any of the estimates because where is that? So there's a couple of ways to try to find this if it is not a mistake or if there's any way to get clarification. Otherwise, it just needs to be, which we did, is excluded completely. And here too, we will have to go back and add it, but there's nothing on the plan. Even if we looked here at 1/A301, I mean, if we go back there, where are we? Let's go back here. Well, this is in 99% of the time cases. That's why this is going to have to be, and again, this was not included in this drywall estimate or framing. And you see, and it's weird because this is a CMU wall in the building, and the building plans are of the architectural set of the A plans. So that tells us that this whole section is inside. Okay, so they need to give us more information. This section view, you are assuming that it's for the opening for the door, and that's all we used it for, is for the opening of the door. Even if you go to the exterior elevations to try to get clarification on fill in the openings, at least because again, this is a call out. Let's go back to the floor plan. Always go back too far. Okay, so remember, this is the call out, this is the exterior, and so there should be some indication on the exterior elevations at 4/A201 where this is and where the other one was, where this is. And again, it was excluded from the estimate. So let's go to the exterior elevations and see if it's even shown there. Oh, going too far. Where's the exterior elevations? A401. Where are the exterior elevations? Where are you? Here we go. All right, so that would have been that CMU wall fill in. It was one near the front door. I don't see it anywhere noted here. And then I said, okay, well, what's that? Maybe it's on B. Let's read B. And then nowhere else is it noted on the exterior walls that there is a CMU portion that needs to be filled in. We had some on the building number 1 or 2 where we had to fill in the door that we had demoed, But that, again, that's why that's not included in B, is not fill in wall. Existing concrete masonry unit. Existing. Okay, and so very confusing. So we go back to that plan because that's it's not there. Okay, it's not there. So I'm thinking they may have mixed up two different sets of plans. I don't know. Sometimes I put, if I'm reusing a sheet, sometimes I leave the old address even though it's the name of the same project. So again, for the GC and for the student, this wasn't included because there's no indication that there should be a section view here telling us about the reinforcement for the CMU wall, all that good stuff. Nothing like that. So it's been excluded, and then when they want to give it to me or whatever, then we can do that. All right, so all the new walls. Okay, so now let's go to the partitions. And I think we have the estimate. All right, so there's our new CMU wall where we have priced it per linear foot. Cost book information 100%. And we had a 4-inch hollow metal panel at the sink. We had to put that. And now P5, P1, P1A, P4. You see how we broke down the framing, the drywall. If it had sound bats, and then the finish of the drywall per CSF is 100 square feet, right? So that's 100 material and labor. And look at this one. And then normally, we want to let the GC know based on what we see in the plans what the height of the wall is plus the height of the bracing, and price it all like that. Same thing, breakdown. So let's look at the plans and how we look at the partition. So P3 was a 6. This is the firewall. That's the big wall that separated where they do most of the work. That was this one. Okay. So that's easy. And then again, how we lay it out on the estimate. Okay, so the math is important, right? Especially, let's do it for P3. Just so you can see. Now, that's the framing. That's the drywall. See, we have 3 on each side. And it's 40 cents per square foot. But we said the total square foot times 6. That's the drywall. But we're only finishing 2 sides, right? So let's go back to the misspelled word partition. So, right, we're only finishing that side and that side, but there's 6, right? So in terms of the finish and the level 5 and all of that, okay, go back. So we go back here, right, 6, but we say 2 times that gave us 30, whatever, 16, 56 times 2. So it'd be 34 CSFs for the finishing. And then the sound bats are the same as the total square foot of the framing. And then it had fire seal on top and bottom, both sides. So that would be the length times 4. All right, 79 times 4. All right, so, you do that for every one. And then we have to do our area. And then our soffits, right? Our walls coming down from the ceiling. We went over a video specifically, I think it was this project, showing how we had 2 different types of soffits at section view 3 over A111 and 4 A111. One was 7 feet. The other one was 25 feet. I don't know, one of the two. Or 18 feet. No, 18 feet and 24 feet. And so we went to that, and we go to Right, so the soffits are here. 4 A1 11, so that was that length, and then this one was this length. So we broke up the soffits for, we calculate the area, and then we also calculate the section view material quantities for the drywall and the framing. So we have to look at 1 over A301. No, that was for the front door. That didn't give us info about this. No, we have to look at 4 over A111, which is here. And now we see that the soffit, that's the area part, but then we have to count for this up and then this area as well. Okay, and so that would be what? I mean, just give it 2 feet, you'd be good. Okay, for that times the length, so that's how many square feet. And then the 3 one is this one, so you have to count for. So if this is 6 inches, we already did this on the other video, so I'm not going to go over it again. The video last night, I think it's entitled Special Ceiling Drywall or something. But yeah, so you got to include that. And then what's also included in your framing, nope, structural framing. We'll come back with another video for that one. You also include all of your door frames that are new. And here I just did if I had to paint or stain a door or whatever. But then all of your, so your door and frame schedule is going to give you your door information, the type of door, the height and the width of the door, and then also your frame information, and maybe your hardware too or whatever. But a lot of this is existing for the smaller projects, so I knew I needed, and use a commercial. You're always going to see HMs or aluminum, hollow metal. We had a few wood doors for, I think one of the other ones, like two wood frames, but typically in commercial it's a hollow metal frame. And just count them up in the typical sizes, 3 by 7, and then if it's 6 by 7, it's probably a double door. We have one of those, I think. Yeah, hollow metal. Okay, so that's the framer scope of work too. And so let's look at the estimate again. So we have the soffits, and then 1 over A301. Okay, so keep in mind upper wall, lower wall. But again, the whole point of being able to be a great estimator is to be extremely, and make sure you're accounting for everything. So 1 over A301, let's go to that real quick. 1. So this is the wall that didn't tell us anything about the extra CMU, but upper portion, lower. And so what we have to do, so we have the section view. I think it was like 24 linear feet of all of this. So what does that mean? You have 24 linear feet times whatever. So 24 linear feet of that, 24 linear feet of that, 24 linear feet of this, 24 linear feet of that, 24 linear feet times the height for that framing, insulation. That's what everything is on that. And then the lower, and as we can tell, this is outside because that's an awning. This is inside. And see, inside at the lower, you have drywall you got to consider on the inside, plus all of that. And so, go back to the estimate. Upper and then lower had more stuff because it had a drywall plus the framing. Okay, and so yeah, you gotta count for all of that. And then our windows, and what we did, this one, they should all be, that's each, but that one should be a linear foot because cost book for commercial glass is that much per linear foot. So we have 5 and then 8 linear feet of window, and then all of our doors, all of our frames, and then drywall framing before. Pretty much the cost, give or take what the GC wants to mark up the material or whatever. Okay, so that's it for this is project number 3. So this is the smallest of the drywall framing components, the smallest of the projects. And if you have any questions, email me at education@sfjohnsonconsulting.com. Otherwise, we have so many more to come. And I will talk to you soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, going over now our structural set for the smaller location. Okay, so remember this is an existing location. The only one was new was the real big one, the Brunswick, the very first one. This is in Akron, Ohio, and this is a renovation of an existing building. So what they're doing here in the existing, they're going in install new exhaust fans, a new rooftop unit, and the associated condensing unit. Okay, and so when they do that, basically we're going to be either replacing probably existing units. I'm not quite sure, but got to think back if these were all we were replacing existing units. So what we always have to do, this is the structural set. That's where we find the roof framing, because structural it's a single story building, so the roof is part of the structural set, and so anytime we put a hole in a structural member, when I say hole, I mean we could put a door in, right? We put a door in the exterior walls, our structural members, meaning it holds the building up. And so anytime we put a hole or an opening in a structural component, we have to shore it up by structural members, right? And when we say members, that's just a technical term for a 2x4, a beam, a column. Those are members. Okay, and so what we have to do for this one is basically add L frame beams, 4x4 by a quarter, along each side at all the new openings. Because again, anytime we open up a structural component, we weaken the roof basically. And so in order to give the roof the strength back that we took out by chopping out a few of the roof joists, we have to give it back with our beams that it's telling us to do. So a couple of things. Typical is what we use when we want to let the contractor know we're doing the same thing to everything here, but we don't want to keep typing this over at every location. And so let me turn off basically what this is telling us is that we're installing this 4x4 by a quarter L frame everywhere we see this symbol, this broken line. And so wherever we see that, we know we're doing the same thing. So that's why we use typical. Otherwise, you would have to rewrite all of this, put it here, right? Put it here, put it here. So remember, anytime you see typical, it's based on what the symbol or what the thing looks like. And every time it looks like this, or if it looks like that, we're going to do the same operation to that. And so at every one of these pieces of mechanical equipment, we're going to attach those beams. And so one thing I wanted to point out in how we do the math to determine, because we got to do material quantity, so we measured all of those, and those about, I think in total, like 200 and something feet. And then we have to attach them using one on each side. Okay, L beams, a 1/2 by a 1.5 by 3/16, that length, and that's how we're going to attach it. And so that is about a 1.5 piece of that is where we attach it here and there. And so you want to be able to determine not only how many linear feet of this, which we've easily determined, but how many linear feet of this you're going to need. And so you're always going to want to know what the placement is, and the placement is every 4 inches. And so what we'll do is measure in total how many total linear feet. Like I said, it came up to like 200 and something. We change those feet into inches by multiplying by 12. And then we divide by the placement, which is 4 inches. And so that tells us how many times we have to put that piece there. Then, however many times we have to do it, and this would account because we did the total length for both sides. So, however many times we'd have to do it times 1.5 linear feet, and that would tell us how many linear feet of this we need. So that works whether it's studs, nails, anything. If you have to put something at a particular placement, meaning you have to put it every 18 inches, 24 inches, 12 inches, 8 inches, 3 inches, whatever, you get however many linear feet in total, change those feet to inches, and then divide by the placement. 18 inches, 24 inches. That tells you how many times you have to place it. And then if it's a particular length, then you say, well, that many times 5 feet, 1.5 feet, whatever. A lot of times for your rebar, you have to place like a 4-foot dowel every 18 inches at the corners of the slab. So that's how you do that, right? All right. So that's all we had to do for this one. And then, okay, remember how we determine when we have a beam. Let's see. And we had to do the paint booth. We did that before. See, that's kind of what I'm talking about when you have a dowel is 4 feet and you have to place it every 8 inches. Well, I want to determine how many linear feet of number 5 rebar I need, or in this case, okay, continuous, that just tells us, right, it just goes all the way down. So if I have 100 feet, it's 100 feet of that or whatever, right? But the placement, that's different, right? Each way, and the thing about this, when it's each way and it's the same thing, do it one way, multiply by 2, it'll be the same as doing it each way, even if it's different lengths. Even if it's not a square, somehow that still works out that way. It has for me. Yeah, I think it does. Or maybe it's all been squares, but try it for yourself. So it's the same. If you had 25 by 4, right? 25 by 4, and you had to place it every 8 inches. So let's work on this. 25 times 12, that gives us inches, and we had to place it every 8 inches. We divide by 8. That would tell us how many placements. So if that's 25 by 4, it'd be that many placements times what? 4 feet. So, you do studs the same way. It's easier when it's studs. Think about studs, right? If you got a 100-foot wall and you got to place it every 24 inches, then that's 50 placements, and you got 10-foot studs, so that's 50 times 10. It makes it kind of easier to think about it when it's studs. All right, so I think for this, this is really the only structural part for this one was everything at the roof framing. So let's look at the section view though real quick and see 2 over S01. This is, okay, no. 2. Wait a minute. What's the page? What is it again? Am I missing a page? 2 over S001. Okay, that's the first one. 2. Okay. And so, yeah, that's here. The masonry lintel. And the lintel is here. And lintel is just like a beam, but that's what they use for, it's a technical term for like the steel one. It's like a steel beam. They call it a lintel. So it's pretty much the same. Okay, and so remember, when we're doing cost booking, the W beams, I beams, L beams, C beams, it is the second digit that helps us determine what we need for our estimate. And I believe I got this one up. I think I do. Or if I don't, we'll open it. And this is this one. Right, so our fabricated metals Okay, here we go. W 16 by 36, we have 32 linear feet of that. So we say 32 times the 36, that gives us how many pounds, because the fabricated metals are priced by the pound. Okay, so it's 5,000 bucks for that. Okay, so that's the only thing. And then usually the L beams that are like 1.5 inch by quarter inch by 3/16. Usually they price those in the cost book by the linear foot. So you can get, it's like $28, anywhere from 14 to 28 to $32 a linear foot for those smaller ones. But for these that you have to get made, just go by that formula. The second digit determines how many pounds per linear foot, and then you measure how many linear feet, and that gives you how many pounds. So, and that is it for this one. And we will be going on to many of the others, trying to get this finished, not only for you, but for the client, so they can see, make sure, everything we did with the takeoff is complete. And that's how we like to do it, because people are too busy to be sitting around talking. And so we give them this so they can review it on their time, and if there's something we missed, or they can let us know. And hopefully not, usually not, but you never know, everybody's human. So you look at something 3 or 4 times, especially when you got a bad set of plans, you're like, oh, I think I should add that. It's always better to be safe than sorry. Especially you always want to put what you see on the set, nothing in addition to that. Or if you're good and something's missing that should be there, then yeah, you add it, and you add a note, that kind of thing. All right, so if you have any questions, email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class or the next video or whatever. Talk to you soon. Hey everyone, this is Stacy again, and I want to now go over the very last of the structural sets for our 3 projects. And this is the middle one, and this is the second one, the second largest. And so they pretty much have, in this case, we have some columns now that we have to install, vertical members, and we have pad footings that the columns sit on. And pretty much what they are, 2.5 by 2.5 by 1 foot and 4 inches deep. This is the reinforcement. And so any good cost book's going to give you the cost per pad for that size, or approximately that size, and then you'll adjust the cost book price based on what it says and what it gives you and what your specifications ask for. And so you may have to run, the specs may say 4 number 4s. Okay, well, you might take the cost book price and then add an additional run of a number 4. So just know, any cost book you use, and I was asked which one we use Craftsman cost book. There are a ton of them out there, and they all do the same thing. So the main thing is to use the one that you're most comfortable with, and know that it's not the Bible, but it gives you a good reference for which to build your material list, and to get a pretty decent cost. And what I like it for the best is for our man-hour totals, because we go by what the construction industry says, and what it says is what we do. And so that's why all of our estimates are always very tight, bare bone, and our clients usually do really well. The only thing they have to do, they can verify the material cost on their own, but what we like is that we can verify that these labor rates are within industry standard. It's not something that, my uncle did it for 40 years, and so he knows how long it takes to install a column pad. Like, okay, well, and you have to imagine there are not very many women in this industry doing this, so I always have to hear that a lot. But hey, I just go by the books, and we do very well. I would recommend going by the books. Okay, and so that's the final estimate for this middle one. We ended up at, well, that right there for the paint booth, that was The paint booth, I believe, is like an 8-inch concrete with the reinforcement. So it's pretty thick up there. So that was the structural for that one. Okay, let's go back to. So here are all the structural components, and remember, here's another W beam, 8 W8 by 18. How we or by 11 3/8, and then the bottom plate. No, bottom plates. What we need for here. That is just the third dimension of the lintel. And then how do we measure? Based on how many pounds, right? So we know how many linear feet we have, and then times it by 18, that's how many pounds, and then that's how you price it, is by the pound. And bearing plates, and so let's look at the foundation, this first thing. And so we had, remember this is a renovation, so we had to cut the slab and then build that out. And then our new paint booth, so also that's the 8 thick concrete, and then the 5-inch thickness, and then all of the column pads. And C1 are the columns, and then the column pads, and all the section views that go with them, and all that good stuff. And so what we do, we mark it out, get how many, the area for the new concrete, the area for the new paint booth, and then how many linear feet. It's just like all the other ones. This one is from the first project. Instead of doing 2 now, we're only doing 1 for this one. And we have some trench drains. So let's look at really quickly A over S201. That's the trench drain section view. 201. The other 201. Alright, so A. So what do we have to do here? Start from, well, the length of it, expansion joints. Gotta add that. The trench drain itself, which is in the plumbing set, we'd add that in the plumbing plan. And then basically the rebar. Okay, so same way you put it at the 16s, right? How many linear feet? I think it's 22 linear feet. So you can say this plus that plus whatever, add all that together. So that's what you're going to place every 16 inches, right? So that's, we do that. And then the column reinforcements, how they sit in the column pads. Okay. And then we had to, in a portion of this foundation, drill some holes, and all of that through our slab. C, let's go back to the, let's see where that came from. C, yeah, right here. Okay, so yeah, we had to drill holes every however many feet in both directions. So let's go back to that. C over 201. That's 201C. Yeah. So drill 2-inch in diameter holes at the 4 feet each way. So each way, same. So with this was, it was kind of crazy. So, you know, just go through every 4 feet each way. We just visually went through it. And then how long is that? It's about 1 inch. We can scale it out, and then we know how many linear feet of hole we have to drill, because, and I think it came up to like 2 feet altogether for, you know, in total. Because you got to know how many. Then we had to do the compaction, and then the slab number 4s. And here's the one we're talking about, where it tells you how long it is. So it's a number 4 rebar, but it's going to be 2 feet 4 inches every 24 inches. So again, you know how many linear feet of that you have. Change it into inches, divide by 24, and what whatever that number is their number of placements, and then so that's your multiplier, and then you say that number times 2 feet 4 inches is how many linear feet of number 4 rebar you need. Okay, because a good estimator, you got to be able to do your material quantities, and that's all this is. Material quantity is easier to put together than the cost estimate. You got to do all the extra stuff with the cost estimate. Material quantities, you can just boop, 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 knock it out. Okay, so same here. We had a new awning, and so just look very closely. Good set of plans, and then your imagination, right? 1/2 by the square plate, so we need 2 square plates, right? And then for these at, we figure 4 different locations. Go back and check that. It's like we do so many of the same one. I'm like, oh, did I do that one right? I was like, I'm thinking about the other one. So yeah, material quantity. So 4 locations, because you're going to have this on both sides of the awning, and each of the locations going to have 4 screws, so you're going to have 16 of those. And I think this is an existing wall. Yeah, it's existing, so you got to include the cost to drill those holes for that to fit in. Okay, so all those kinds of things. All right, and I think that's going to be it. Oh, this is our let's go back to, because it was very interesting. That's our foundation, but here is our roof framing. We didn't go over that. So what's happening with our renovation for the roof is these are exterior elevation views looking this way, but basically these are all the lintels, which is again the metal header. Instead of wood headers, the lintels are metal. Some bracing had to be taken out. Like the other video, we had to do what it said there, took care of that. But this is overhead doors being installed, so they needed the metal header basically to hold the framing for the overhead window installation. And then some other stuff going on here. So let's go to 1A 301. It's right here. Right here. Okay, so they only show us one time, but it's all of the 4 that we saw. So again, this is a C-beam, C8 by 1875. What's that mean? It holds 18.75 linear pounds of weight per linear feet. So we know how many linear feet times the weight. We can figure out how many linear feet and figure out the price, because we price again those by the pound. All right, so that is the middle project that came up to at $115,000 for the structural components, structural set. And shoot, that's it. So we have videos for all 3. And remember, we're going to go over, once we review all the videos, there's going to be a lot still coming up for each of the scopes of work for each of the 3 projects. Then we're going to add everything up based on the square foot of the project, the different prices, and then we can go forward and start to create for each of the trades, see, which is going to be the fun part, creating a work schedule, a work breakdown schedule for each trade. And what you have to start to think about, especially if you're an estimator and you don't actually do the work, but you know how it's done. That's what a good estimator is. You don't do the work, but you know how it's done, and you can visualize it being done. And so the work breakdown schedule, you'll be able to see, okay, what would the framer do first? You lay out the bottom plates or whatever. You have to determine what comes first, second, third in order to create the proper work breakdown schedule for each trade. So now you can create your budget for each day, whatever. And so that's what we're going to be doing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Hope you enjoyed this video. Let me know what you think. And please subscribe if you haven't already. And I'll talk to you very soon. Hello, everyone. This is Stacy with SF Johnson Consulting and Construction Services. And in this short video, we are going to look at the new site work for the middle project that's not the biggest one, not the smallest one, but kind of big. And so the site work, here's the building envelope. And what do we have here? We have new concrete pavement, some parking stripes, an apron for the ADA ramp, and an equipment pad, and some numbers that we're going to put on there. So let's get rid of and a new bollard and an ADA sign. So we have quite a few. So let's get everything off and then build it back up. Okay, so the site work is all the work that happens outside the building. For our case, it is a renovation. So basically, they're adding new parking lot spaces to store, I guess, the cars once they're finished with the collision work. And then a new area here, new concrete. Then we have a new equipment pad, 40 inch by 40 inch here. Some ADA signs, and our pricing will include the footer. So anytime you have signs, you always got to make sure you include the footing for the sign. And we have some symbols. And when it came to these, we just priced it for the three that were there. I think the first time we did it, we overdid it, assuming it was a mistake that all the other spaces weren't marked off. But I think the only three we have, and then the ADA symbols, and then here's the apron, and then we have more stripes. So this one was really pretty easy. So we had the curbs. So let's do the curbs. So we always distinguish between the curved ones, okay, and straight ones. Okay, so there's the straight ones, because it's a little more in the formwork when they're curved, and so you get as close as you can. So we have that, and here's our signs and our apron, no, our symbols, the new bollard. Where did it go? The new bollard. Oh, it's over here. Where is it? Hold on. Slide it up. We have three new ones. Okay, that's right. And here's some more curve. So we said that was the difference between the curved one. That was a straight, and we break it down right here. Okay, and so these numbers are the radius of the curve. Okay, that's why they have those there. So when the machine is laying the concrete, or when they do the angles, they'll know that the radius of the angle is that number. All right, so this wasn't too difficult. I'll just light up everything again. And so again, the stripes, you can price them per linear foot if you want to go through and just do all this like we do, which is more accurate. Or you can price it by the area, and then the symbols are separate. And what we normally do is do one of the stripes, because they're all the same, about 19 feet long, something like that. I think we had 20. And then we had to put them all in. So let me just fill in all the colors, and that's all of our new. Oh, let me show you how the difference between the new concrete and the existing concrete. Okay, so you really have to look very closely, because the darker color is the new. So it basically stops right here, and you can see even the little representation for concrete. These are more black than gray. So this would be your line. That's where we got our line for there. And then here, they just straight out give you the line. Okay, so always be aware when you see how the difference in the curve right here is gray, and it's black. Okay, so you'll know where to start and where to stop. That's real important, especially when you have a renovation. So everything new is going to be more black. Okay, so if you have any questions on this one, please email me. Give me your thoughts. Please subscribe, and I will see you at the next video. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, here to talk about landscaping. And probably this is our first landscape review, but what's landscaping? All of the new grasses and mulches and trees and shrubs. And so what you'll get is a list of all the different trees. They'll give you their scientific names is the first one, and then the name we find them at the nursery. Okay, and then it's good that they tell you how many. And so for a tree, you're gonna well, this set of plans doesn't give you a good detail on how they want the tree planted, how far under how deep the roots need to be, and how it's maybe secured if it's a smaller tree. Most sets of plans will give you all of that, but this one doesn't. And so we just do what's normal for what the cost book says for the tree at about, it really depends on if they need to use machinery to dig the hole. That if it's that big of a tree to where they're not going to dig it out by hand. So really there's a lot more detail in this set of plans that needs to be provided before we can do really good on any landscape plan. So keep that in mind. And one other fact is that usually for the price of the tree, they charge 2 to 3 times their cost of the trees in the event that the tree dies. Then they don't have to come out of pocket to replace the tree. And also with landscape, it's usually about a 6-month service contract or maybe it really depends on the contract, but minimum 6 months to a year and a half maintenance for them to go out and make sure the trees especially are getting what they need, they're not dying. And usually you also have an irrigation plan that goes along with this, but there was not one with this. So it's just a bunch of planting all of the shrubs, and here are the symbols. So we have mulch we have to put in there, and then a lawn area. So we just assume we're going to plant seeds or set maybe the lawn strips that are already set, and then mulch. And so just like any area, we're going to use that in terms of square feet. But some of the material, the mulch one is square yards and cubic yards. So I believe the price is in cubic yards and the mulch is in square yards. So we have to do the conversion to convert our square feet totals to the cubic yards and square yards. Any material with a volume, just like concrete, it's going to be measured in concrete's case, is cubic yards.